We already live. I don't know. I was supposed to set up some stuff first, but it looks like you're already live. Let me share. I'm using a different program today, and I thought it was gonna give me some time to set up some things because I still had like 10 minutes to go. But it seems like you're already live, so let me look for music to play. But I hope you're doing great in case you're here. I hope you're having an awesome day on your end. All files. Stream. No, I haven't seen it. Let me share with you. I haven't seen it. You see the video of I haven't seen it yet. I've not yet seen that video. But in case you share it, I'll give it to you. Where did you see the video? Where did you see the video? Like on which platform? Did you set up first platform? Like where did you see that video that you're talking about? Is it on X? producer saying that, oh, producer, where did you see that video? Was it so? Well, but you can share the link. I see it as well. I'm trying to set up stuff and I have an issue with my connection here. Sorry. I think I lost connection for a minute, but yeah, we're back. So, in case you're here, thanks a lot for being around. Hit the like button. Producer is saying that there's a video of a robot holding a gun. It's saying that it's not sure if it was AI generated or not. I wish you can be able to share it. The link. I see it. I haven't seen it. Is it on X or on YouTube? I haven't seen it yet. But there's this American robot. Let me share it. You see, it is being trained to do such stuff. Let me get that video. I'm going to play it right now. It is being trained to be able to shoot and do whatever. Although, yeah, let me get it and share it. You see, just a minute. Just a minute. I think I know where I have that video. Trying to use a different platform. Yep. But let me share that video. There's an American robot that is being trained, made by an American company. It has been already been deployed to Russia, not Russia, Russia, Ukraine war. But since producers say that there's a robot which is doing so, I said let me get that and share. You see, this one is being trained to how it can be able to throw stuff like. Let me share here. Did it come here?
All right, you guys ready back there?
Yes, sir.
It is being trained how it can be able to load these things. So it's actually an American robot. It's called MK Phantom. I did a video on it about its features and all that. There's a video about it in case you want to see it on the channel. But right now it is being trained, or it is experiencing like real-time experience in Ukraine, how stuff is going on. But of course, this is today I'm not here to talk about this, but let me.
All right, thumb, release.
So it's not like it is there. It's still very far. I mean, in terms of development, not yet that advanced.
All right, you guys ready back there?
Yes, sir.
How formidable?
Okay.
thought that I called you. Let me get what we want to talk about today.
All right, thumb, release.
So of course, like I said, today I'm not here to talk about this. In case you're here, thanks a lot for coming around or for joining. I hope you're doing great and you're having an awesome day. In case you want to go away, just hit the like button. But today I wanted to talk about the issue between Alan and Lloyd. So there is an experiment which Alan is doing, or Alan has been doing, and also it's the same experiment which Lloyd has been doing. And now when Alan did it, he got different results from what Lloyd got. And we reached out to Lloyd, and I reached out to Lloyd and was asking him like what could have been the difference between his experiment and what Alan was doing. Because for Lloyd, he says that he's able to get more power out than the input power, but he doesn't show us really clearly like those measurements so that we can be able to see for ourselves, like in case what you're putting in terms of voltage and current and what you're getting out in terms of voltage and current. But for Alan, he was able to measure it very clearly. So Lloyd said that it might be a different, say that maybe the solar panel is different. There's some excuses which he gave about solar panels, and also they're saying that Alan is not using an MPPT controller. I mean, the Alan's one is not really the correct version, but there's a time we talked with Lloyd, and there's this, I think, let me just also see how I can be able to share it. From what we talked about a year ago, it was an interview with Lloyd Stoval, and during that interview, Lloyd also shared, he told me that you can be able to use any solar panel and it will be able to work. It doesn't matter. But when I did ask him, like, here you said it doesn't matter, then he said that because my English, like, I think I failed to understand. There's a way he put it, like, it's because my English is wrong. But I think, first of all, let me play Alan's video, then we see what he's doing, and then get to what Lloyd is doing. So, Trevor, thanks a lot for coming around. I see you here. Today, I'm trying these different programs, but this way I can be able to share now stuff on the screen. But you say that here is a commercial available LED solar simulator. Yeah, I'm gonna watch it. I think let me begin with Alan's video, but I think you've already seen it. Even you've already seen it. You've already seen it. But I think let me begin with Alan's video. We watch it, and then I play the interview that we had with Lloyd and what he said back then, and also what he is claiming right now, because it is a different story from what was back then. So let me share. In case you're here, man, thanks a lot. Just hit the like button. I think I should have put that one as the what. I can't remove this one. I can remove the robot from the screen, and I can add this one. So this is a video from Alan or Alano. Also, if Alan was in Kenya, we could have called him Alano. Trevman, thanks a lot for being around. Let me play this video, but I think you've already seen it.
Hi folks, this is advertised as an 18 volt 1.1 amp 20 watt solar panel, and it's currently out in the sun. It's doing what it's supposed to do as a solar panel, and I've wired that into the multimeter to show you what it's coming in at. So although it's rated at 18 volts, on the multimeter it's bringing in 20.8, which is really good. Now that's volts, so let me see
Is
what
it coding on
current
your
that's going
side?
to bring
Are
in.
you
It's
able to
bringing
hear
in
it,
the 10.
Trevman?
Now it's wired up for current, and according to this it's giving me 200 milliamps. Now on the advertising of the product on AliExpress, it says it's 1.1 amps. But as you can see from there, it's only giving me 200 milliamps. Right, according to my other multimeter, it says 230 milliamps. So that's two multimeters saying it's around 200 milliamps.
So at this point, Alan is measuring from outside when he's, outside from, I think this is the sun now. So the sun is giving him, this one is getting 0.23 amperes, while the other one was, while the voltage was, I think 20. The voltage was 20. Yeah? Then after this, now he will stack them up using LEDs, like how Lloyd explains, and then he measures what he's able to get out of it. And then, yeah, let me continue playing the video. I wish Cecile was around to see this, because
Okay, just to show you that this battery is 100% charged. It's saying 13.1 volt at 100%.
Hey everyone, in this video I'm going to show you how to create a 3D model using just one image. And the best part?
So the idea using solar panels with LED lights, can you generate enough power? What you put in and what you get out. So I'll go through the spec.
yes, so that is what he wants to find out. Can you be able to generate more power? Like what you put in, will it be way more than what you get outside? So for Lloyd's experiment, he's able to get more outside. But like I said in the description of this video, it doesn't show. It doesn't measure exactly the way that Alan is doing, because Alan is showing you the voltage in, voltage amperage in, a voltage in, current in. Also Alan is showing you voltage out and current out. So that way you can be able to calculate power in and power out, and you find out. So let's continue watching.
In a minute. But that's the idea. Do we get enough power out to justify the power going in? Okay, so we have the 12 volt 20 amp lithium battery connected to the DC to DC converter. This is 12 volts to 24 volts, 10 amps. So that's wired in there. This is on the multimeter, and we're getting 24 volts from that. So this is the experiment here. I have 6 18-watt solar panels, and they are being lit by 5 volt LEDs. And if you look at the power there, that's the draw. That's actually set to 5 volts, 1 amp. And it's down to 3.28 volts. Okay. So basically what I've done is I've got the multimeter, and I've put on the multimeter onto DC volts, and I'm getting 70 volts from that arrangement. Okay, show you there.
You can see that it's getting 70 volts, which is a lot. Yeah, from 20 volts is able to get 70 volts, which is a lot. And that is what even Lloyd has been doing with all the people who have been experimenting in what he has been doing. 70 volts, which is a lot. From all this is getting from a solar panel that was showing it can be able to output something like 20. And remember, the power that is putting in is way less than that. So 70 volts is
again
good.
Okay, so what I need to do is switch this over to current, and to see how much current I'm going to get.
Yeah.
If I switch this off,
That's what you want.
Change it over to amps.
Yeah.
And put it down to amps, and you can see that's the multimeter there that's going in there. Nothing is coming up. So that means I have to go small.
So you see, in terms of current, there's nothing coming out, because as of now the dial is on the ampere, is still on the ampere reading, yeah. So there is nothing coming out. So you'll have to switch to the milliamperes in order to get something out of it. So
Smaller than 20 amps. So if I take that out, put it into there, and then go smaller, it's showing 1.0. So I think that's
1.0 amp, 1.0 milliamps, 1.0 milliamps.
set to 200.
So basically, if you calculate the power in 1.0 milliamps, if you take 1.0 milliamps and you multiply by 70 volts, what do you get? Get something like 0. What do you get? Is it 0.00 something? Let me do that calculation right away. Should be 0.07. Eh? 0. I think 0.07 or times point or 0.7. No. It's 0.07 watts. So that is what is getting out of the system.
Milliamps. So that looks like it's maybe it's 100 milliamps, maybe with that, I think. I'll have to check the setting, but it's very low.
Yeah.
So although I am putting in 1 amp here, which is 1000 milliamps at 5 volts.
So 1 amp at 5 volts is putting in 5 watts and is getting out 0.07 watts. So this system is losing power. Like you're losing power. But now for Lloyd, of course, when he does it on his side, he says that you're not losing power, but instead you're making more out of it. Like the power in versus power out. According to him, you're getting more power out. So I wanted to know this as well. That's why I reached out to Lloyd himself, and I was trying to ask in order to find out, like, maybe in your case, you're showing that this is possible. What do you think is the mistake that Alan is doing? Maybe you can be able to explain to us like much better. And I said maybe I can have him on the show, but of course we did not agree. And I want to play the video of the reason why we did not agree, because in this video I wanted to know,
I'm getting
maybe is Alan using the wrong type of solar? What could be the issue? Like such stuff of things. But let me
100 milliamps and 70 volts. What I'll do is I'll wire this into the Victron MPPT controller, and I just want to see what that registers. But the thing is, because my battery is 100% charged, so there won't be any charge. That's the only thing. I need to run down, need to see something going in. But at least
But
at
of course,
20
Alan
watts.
himself is going to come on the show in about an hour or so from now. He's going to come on as well, and he will be able to explain more on what he's doing here. For me, I don't want to go deep into what you were showing here, but I just want to go to where the solar panel is. But Alan showed us that Alan's channel gets a lot of ads, even if he's not yet monetized. Let me go back to the solar panel so that I can see what I was about to see. So here we see the type of solar that he's using, or the solar cell that he's using. It looks like my internet is a little
Supposed to
bit
do is a
slow.
solar.
Here you can be able to see this is the type of panel that Alan is using. Now I went ahead to ask Lloyd, like, could it be the panel or stuff like that? Like, I wanted to know more what is causing this issue from Alan's side. And according to what Lloyd said that it must be, the solar panels, he's using different solar panels than what he was using way before. And also I've gotten some people saying that when you're doing this thing, you should not consider current, but now current and voltage just to go together. And luckily enough, I got an interview that we did with Lloyd about a year ago when we were talking about this stuff. And back then, Lloyd never used to rely a lot on ChatGPT. Like last time on Gemini or AI, like last time when we were doing that live stream, it was very difficult to like to speak to him, because when you ask him a question, he's sending like I don't know, like a very long thread of AI answers. Now you cannot be able to read like the entire thing on the live, you see. So, but this back then it was very easy to talk to Lloyd, and I want you to listen to what he said in some of this stuff about the type of solar. So let me try to get to there's this section, or I can just try to get the video itself so that I make it simpler. There's an audio file that I have of a full interview that we did with him way back, and also I have this one. This one was just something that we talked with him also way back. I just went ahead to screenshot some section of it. So listen to what he said. Like the type of solar that you're using.
Doesn't matter, long as you can stretch over the LED lights over the whole panel and cover the whole panel. It does not matter what solar panel you use.
So you can hear what he said. What he's saying, according to me, the way I understand English, yeah? You can help me understand here, but according to me, the way I understand English, he said it doesn't matter what type of solar panel you're using, as long as you can stretch the LEDs on it. But now when I went ahead to ask him, like, but 1 year you told me that it doesn't, 1 year ago, you told me that the type of solar panel doesn't matter, because he was saying that the reason why Alan is getting different results because him is using a different type of solar panel or solar cell. And I was like, a year ago you told me that it doesn't matter. So how comes right now you're again telling me that now it is getting different results because he's using a different panel? Then Lloyd said that I never told you anything like that. So I went and looked for this conversation we had. And then I went ahead to screenshot it, yeah? And I sent it to him. Then he said that it is me who is understanding the English that he's saying wrongly. So if you listen to that conversation, like he said, what does that sentence mean? Like, is my English wrong to understand that sentence? Like, it means it doesn't matter the type of solar you're using as long as you stretch the LEDs on it, or does it mean something else different? Let me replay it again. Trevman, your English is much better. What do you think he means here? Because you said that my English is wrong and he never meant that. Let me look for the reply he gave me and I read it. You see what he said. Like the type of solar that you're using.
Doesn't matter, long as you can stretch over the LED lights over the whole panel and cover the whole panel. It does not matter what solar panel you use.
You hear how he said with like, it doesn't matter what type of solar panel you're using. But when I did, let me read the answer that he gave to me, or the thing that he gave to me, and he said it was because of my English, that my English failed me. Wait to see. With the answer. Let me get that answer. But how do you understand that one? Let me also share this conversation. This was way back. I don't know if this one is audible, but let me know if it's but now
The frequency into this, he's able to take those spikes.
he seems to be more serious about it. He looked at maybe how things are, and then he said, let me come up with a free energy communicated. I don't know.
All that stuff he got, a helicopter off of what he has. If I show you how to do this and put it together and you actually run your TV, why would you have to be the right time waiting for Maxwell?
Yeah, like the market will already be saturated.
This is opposite of what Max
Communicated. I don't know what you talked about, but he told me that he seems to be more serious about it than what we hear from Maxwell.
That's because he's able to take those spikes and turn them into amps. For anyone listening, This is what I want you to do. If you're talking about technical, he called it a transit energy trap. A transit energy trap. Okay? So that's the reason why I sent you Mel's videos, because he's using that trap directly from Nikolai Tesla's patent.
You're saying Trevman? Yeah, Trevman is saying Trevman. So Trevman, you see, a year ago when I was asking Lloyd a lot, like when I first knew him, I used to ask him a lot, like because I used to get those type of questions a lot, like people want to know, yeah. People want to know, like, how can you be able to do this? Can you be able to replicate this? What do you really need in order to redo this experiment? Do you need a special type of solar? Do you need what? And back then for him, he just used to tell me that it doesn't matter what solar panel you're using. Back then, that is what he used to tell me, that it doesn't matter. And the good thing is, I usually have this conversation, or when I talk to someone, it's very difficult for me to forget something we've talked about. You can only deny and say that you never said so if I don't have like any recording to bring it out. But in this situation, I had one to bring it out, and this is what he said. But of course, he said that according to him, even on his videos, he doesn't use any type of solar. Like he uses those specific ones, and that was him, of course, trying to explain why, in regards to Alan, he's getting different voltage out. I mean, voltage out is high, but current out is low, so the power is very low. And he said that now, if you use this type of new solar cells that he's waiting for, I think they're called amorphous or something, that they're way more like advanced. They have better efficiency in terms of absorbing light, and they'll be able to generate more power out than what you put in, or they'll be more efficient and much better than the solar panels that Alan was using. But now that begs me the question, or makes me to ask the question, like, now since last year you've been doing this thing, and this new like solar cells, I think you just began using them recently. But back then you used to tell us that we can be able to do this and it works. Why now, like, when someone is doing it and getting a different results, you're saying something different? But yeah, let me read. You're saying that Lloyd stated in another video that it is the monocrystalline solar that he is using, the same type that is used in solar powered calculators, which is very little in current but high in voltage. Also, he stated so himself. So I was trying to look for one comment. So I was asking him about the same and said that, and this is where your English and your determination fell short. What I said is, it doesn't matter what type of solar you use, they all work, which you see. But in the video, again, when I give you evidence to show you that they all had different outcomes, this is how you twist that into making it all the same, even though you see the evidence yourself. So he's saying that, and this is where your English and your determination fell short. What I said is, it doesn't matter what type of solar you use, they all work, which you see. So this was regards to when he said this sentence. Like the type of solar that you're using.
Doesn't matter. Long as you can stretch over the LED lights over the whole panel.
And the question that I'd asked him for this, I think, let me try to find that original audio. Because the question that I did ask him was, like, in order for you to get more power out and all that, do you need like a special type of solar? Do you need special type of LEDs? He said that he explained about LEDs, and also the solar panel said that it doesn't matter. But right now he's saying that it is my English that is failing me to understand him. So another thing that they said why Alan was getting different results was that because the MPPT, apparently the MPPT charge controller that he used is not an MPPT charge controller, that you have to open it inside and then you find out on your own. Let me see if I can. Travan, let me know if I play this audio. Is it audible? Like, do you hear anything? It doesn't give me the option to show it on screen. I don't know if it's audible or not.
Did you see that? He's able to take those. Been trying to get you not to use these things. They did everything.
He seems to be more serious about it and try. He looked at maybe how things are, and then he said, "Let me come up with a free energy." Communicated. I don't know what you talk about. There's about 4 or 5 people who have reached out to me who really believe that free energy is real, and they seem to be like very interested.
Year.
Not getting
You got. Here's the thing.
Is it
Current.
audible?
Okay. Then you don't need any more of the battery because you got another component that's like little generators that's giving you all the power you need to charge back up the battery. Okay, let's take an example of how the original car worked. If you didn't have an alternator in your car, your battery would go dead. If your battery goes dead, it wouldn't fire the spark plugs that ignite the gasoline. Okay? So in the initial, you turn over your car, he amplified that, which is voltage only. He amplified the voltage. Okay? When he did that, remember, this is only voltage. Okay? It's potential energy. That's what we call it. Voltage is potential energy. It's not usable without current. Okay? So what happened is what is current? And this is what people mess up when they say, oh, Nikola Tesla was going to transmit energy over the air. You can't transmit energy over the air because amps don't go through the air. Okay? Amps do not go through the air.
So there is a statement that he said here, which I want to play, and this is the statement that I wish Cecile will have listened to, because last time when we talked about, I think it was during the last that live stream when we had with Lloyd, and we were arguing over and over again about how he was measuring current wrong. Then he came to say that current doesn't matter. I think he said it on my WhatsApp that current doesn't matter. What they're doing here is called photon energy. Like it is photon energy, and in that type of quantum physics and stuff like that, current doesn't matter. But there's a place here that I got. This is an interview with him last year, and he was talking about how current matters. So yeah, let me play. I hope you listen to it. I do hope you're doing good. I see you're around. I'm waiting for Alan. Alan will come in a little bit later, I think in an hour or so. He said that he wants to explain more. But in case you want to join, I'm using a different program today, but I think there's a link I'd shared. If you press on it, I think it will bring you over. Or if it's not working, I can generate a new one. In case you want to join.
Okay? So how do you get your amps? It's called frequency. Each tower would take electricity, voltage from the air and the earth. Each antenna he built would have done that automatically. So he doesn't need to transmit anything. It makes no sense if you take one tower and you get electricity from the air and the ground. Why would you need to transfer the same amount of energy over to somewhere else if you can just take it from the air and the ground where it's at? So what he was going to transmit was the frequency, which was the radio waves. That was a radio tower. I would tell people to go back and study Nikola Tesla and what he was supposed to build for, J.P. Morgan, the banker. He was supposed to be building a radio station and be the...
Alan, you can come. You can come on. You can come on. You can come on. It's okay. Let me... Is the link still working? I'd pinned a link somewhere. I don't know if it's still working or do I have to generate another one. But you can come, copy link. It's a different program, not EasyMax, but I think the previous link still works. Let me reshare here. But I think the previous one should work still. Although I'm not familiar with this one, I said that I'm gonna practice, but I did not. But I think it should work. But I want to get to this seat section.
First person to send a radio wave. But Marconi stole his patents, used his patents, and made the first broadcast. This is what made J.P. Morgan mad and said he was going to shut down. He amplified that. Which I don't care is what any applications. If you got
listen at this point.
Voltage times current, which means amps, you can run anything you want.
You see, Lloyd is saying that any application, when you get voltage times current, which is power, yeah, he's saying that you can be able to run anything you want. And this was way back when he was trying to explain Maxwell Chikumbuso's invention. Because when he was trying to explain Maxwell Chikumbuso's invention last year, does that one work? There's one which I pasted, or it doesn't work. I generate a new one. Let me know if this one works. Does this one works? If it doesn't work, let me know so that I can generate a new one. Let me know if it works or not. So I was saying that a year ago when he was explaining to me about Maxwell Chikumbuso's tech and how it works, he was saying that basically how Maxwell Chikumbuso's tech works was he was able to amplify voltage, but now what he was struggling with was when it comes to now like current, where you say that you have to use MOSFETs to amplify current. And that is what he was saying in this section, that for anything to work, you need voltage and current, which is power. But now he went ahead and sent me a message last time when I was telling him that you're measuring current wrong. He said that in quantum physics, quantum photon physics has nothing to do with watts or volts at all. That's why you're measuring wrong. You will never understand what we are talking about because you're still measuring light as voltage and amperage when it is actually photon energy. So these are just things that he himself told me actually. These are things that he himself said, so that for any application to work, for any machine to work, you need both current and voltage. But right now, it's a different story. And this was a conversation we had with him a year ago. Right now, suddenly current doesn't matter. So let me see what I did saying. Then he said you didn't need current. He's making it all up. Yeah, so when I bring to him some of these things that we talked about a year ago, he says that it is because my English, I don't understand him, what he's saying. That's why I'm like, man, what do you mean? Like, am I hearing this thing wrong? That's what he said. He said that you can't do anything without current. Is it working? Is it working yet or not yet? I regenerate. I don't know if Alan was able to come on. Oh, Alan is here. Alan, you're here. Right now, it's a different story. And this was a conversation I had with him a year ago. Right now, suddenly current doesn't matter. So let me see. Alan, you have to mute. He said you didn't need current. He's making it all up. Alan, you have to mute. Yeah? Alan is here. But I hope you heard what Lloyd said. So I don't know. Is it my English? Let me take it back a little bit.
Amplified that, which is voltage only. He amplified the voltage. Electricity, voltage from the air and the earth. I don't care is what any applications. If you got voltage times current, which means amps, you can run anything you want. As far as this electrical, when we talk about electrical motors and stuff like that.
So you heard what he said. Alan, you're here.
Can you hear me?
Yeah, I can.
1, 2, 1, 2. Can you hear me?
Yes, I can hear you. Can you hear me? So, Alan is not able to hear me.
I'm not hearing you, Chris. I don't know whether you can hear me, but I'm not hearing your audio.
I see. Now, this is the issue with using a new program. But you guys can hear me, right? You guys can hear me, but Alan can't. So
Can you
I
hear
don't know.
me?
Yeah. I can, but you can't hear me. I think maybe I need to do something. Let me remove some of these things from the scene. I can hear you, but you can't hear
Right.
me. I don't.
I can't hear you. Can you hear me? You can hear me. I can't hear you.
Yeah, I can hear him. I can hear him as well, but I don't know.
Um,
Let me do this. Let me
let
do
me
this.
just see.
I don't know what is up with this
You
new
have
pro.
been unmuted. Okay. Um,
Do I have to share my audio with him?
resolution video. Okay. Audio. Let me see. Test mic. Okay. Speakers.
Your
Test
audio
mic.
is okay.
Okay. So the speakers are okay. I'm getting the speakers working are okay here. So I'm not too sure why I'm not getting your audio.
Mm, I don't know, but you can just maybe this new program, or I can switch to the other one in
Okay.
about. Because I don't know. He can't hear me. I don't know.
Okay. We got audio.
You hear me now?
I have you now. You've got audio.
Oh, yeah. I switched to a new program today, and now seems like I'm also trying to learn it as well. So let me try to. But how are you doing? How are you doing? How are you doing? I hope you're doing great.
I'm not too bad. How are you? You okay?
Yeah. I'm also great.
I've just
Uh,
come on. I've just basically come up to and switched on your channel, and I noticed you went live, and that's why when I said, look, I'm available if you want me to jump in
yeah,
and give you my thoughts on what you're talking about there about what we talked about last time as well.
yeah. I'm glad you're around. I was playing your video. I think you saw it. I was playing a video and I was just trying to explain something that came up because it was Lloyd was I mean I for me I'd reached out to him personally. I did ask him like why is Alan getting a different results from what you're showing, and then he told me more about like maybe your MPPT charge control is not really an MPPT charge controller, which I was like, why? Because I saw it was written on it MPPT. I think he also told you the same thing. And
Well, yeah. Well, let me, before we get into it, there's a couple of things that I just want to clarify for
yeah,
people tuning in and listening. And,
yeah,
things that we have to factor in. And Lloyd is right on to a certain extent on a number of things, right? I do not have the same technology Lloyd has there, right? I don't have the same LEDs. I don't have his battery. And although he is using this MPP controller and so am I, he is right in saying that this is fake and rubbish. I actually went online and I checked to see the difference. Lloyd said that real MPPT
mm,
controllers should have a coil inside it, and I went and confirmed that online with manufacturers saying about the difference between the PWM and an MPPT. So although this is AliExpress labeled MPPT, if you look inside it, and there's a number of videos online, nothing related to Lloyd, this is other people showing that these are fake. So this is not an MPPT controller. It's badged as MPPT, but this is fake because it doesn't actually have the coil inside it. Now, so that's really put a kind of a kibosh on the, I'm doing what I was doing. This is a proper MPP controller. This is a Victron MPP controller, a 115. Now,
yeah,
I'm going to be doing testing. So I'm going to be doing more testing,
mm,
and I'm going to be using this instead of the other knockoff AliExpress controller, because this is a Victron and this is a proper MPP controller. The other thing that Lloyd is using, and I'm not using, maybe I'm not using the same LEDs. I did some research on the whole idea of the light from the sun. You know, you're getting all this light and photons from the sun and infrared from the sun and all this kind of stuff. And I wanted to find out what kind of frequency we should be dealing with. Now, they say the sweet spot is about 600 lumens from light, artificial light. The LEDs that I was using with that experiment that you see in the videos, they were just bog standard AliExpress LEDs. I didn't even focus on the lumens for them LEDs. So they could be, for all I know, they could be 2,000, 3,000 and not very good. So what I have done is I've ordered 6,000 lumen LEDs, which have come in. And I'm going to use the same solar panels, although the solar panels that I was using, as you've seen on the video, they were missold. They were saying that they're 1.1 amps at 18 volts, and really what they were was about 100 milliamps. So, you know, again, lying from AliExpress, mis-selling from AliExpress. But what I am going to do is, and I think I showed you this before, I'm just going to do a quick experiment with this. This is going to have two solar panels with the new 6,000 lumens LED lights, and I sandwiched in between, and they'll be connected to the proper Victron MPPT controller. And I will just want to experiment to see how much energy I will get from the new LEDs going into a proper MPPT controller. That's the first thing I just want to say. So it's not like for like with Lloyd stuff. My technology could be a little bit different, but it's all down to experimenting. The other thing that I just want to mention is that the one thing that I got interested with Lloyd's setup was it wasn't about so much self-charging. It was trying to have 24/7 charging. And what Lloyd had set up, which I found very interesting, was he had a solar panel outside of his house getting proper sun on the solar panel, which was charging up a normal battery, right? A normal 100 amp hour battery, 12 volt. Now that battery was supplying the power to the LEDs, where he had all the solar panels sandwiched. You know, I have a picture of Lloyd's setup, and he has loads of solar panels, and in between the solar panels was all the LEDs, and the power he was getting, or the energy he was getting from using the LEDs, was going into another set of batteries, is my understanding, and are going into an MPP controller, and then into another set of batteries. So, although that's not kind of self-charging, it's another way to get energy where you're getting 24/7 energy from the solar panels, rather than relying on, you know, all solar panels outside on the sun. So I just want to caveat that before we get into discussion, talking about and discussing the solar stuff, because I did like that idea, and I still think that has definitely potential and something that I want to try and replicate. But for that little experiment there I was going to show you, I just want to see if I increase the lumens on the LEDs and use a proper MPPT controller, will I actually get more power? Will it provide more power? I mean, as I said, whether it works or whether it fails, I'll do a video and I'll show you, and you can see it for yourself.
Okay. So yeah, that's a good explanation. There's someone who had joined, I don't know, called Alam, but it looks like he away. And Adebayo, I've shared the link of Adebayo was asking for the link of your channel. I've shared the link.
Yeah, if anybody wants to link to my YouTube channel with the experiments on it.
Yeah. I've shared it on the chat. If you click on it, it will take you to I think he's back. I don't know is he though. Yolam, is it Adebayo or what? I think it might be Adebayo. Looks like he wants to know more about you. But I've shared the link of it. And ID was saying that lumens don't equal to frequency. I don't know if you'd seen that comment.
Yeah, well, see, I'm something I haven't experimented with, but people suffer from a condition called SAD, which is seasonal affect disorder, and they need to have a special SAD light. You can buy these SAD lights, which are supposed to replicate the sun, and apparently it helps people with the condition called SAD. So I was thinking in my mind, if I bought a SAD lamp and I actually put that over the actual LEDs, would that make a difference with the frequency? And also, Lloyd was talking about the ambient light, the difference between solar and ambient light. So the solar panels that you get in calculators and garden lights and stuff like that. And if ambient light are better when dealing with low light because they're probably like monocrystalline,
Yeah.
will they generate more energy? So I got a link from Lloyd, and he was showing me the ambient solar panels that you can buy, and they're pretty cheap. I think it's about, you can buy a pack of 10 for about £6 on AliExpress. So for the sake of doing that, as we're into experimenting and proving whether this technology works, I might go ahead and buy them 10 and then light them up and see what happens. Now, a satellite, unfortunately, is quite expensive. They're not cheap. So if anybody wants to fund a satellite for me to actually buy it so we can do the testing, then we can arrange some PayPal payment if you want to do that. But I'd like to see the difference between a normal LED lights and then using a satellite, and if that makes a difference.
Happy to make the. Wait, which camera are you using by the today? Or today you using? Are you on the phone or on the?
Me?
Yeah.
I'm just using a normal Logitech camera. So on a PC.
Lam, do you want to say? Lam, do you want to say anything, or you? I don't know who Lam is. I think he's at the bio.
Actually, last time I spoke with him on WhatsApp, he told I shared it with him. So today he sent me a link. I don't know if so it came. But the thing was, I don't know whether I sent you or not.
Okay. You're the boy from Nigeria, the one that was in the US, yeah?
Pardon?
You the guy from Nigeria?
No, I'm the guy from Uganda. He told me you're coming out to Uganda to do what? Something like that.
Oh, this guy says that he has been able to make up energy. He has been able to make energy from radio, like what Maxwell is doing. Then he sent to me a video, but it was V1's video. But although your internet is a little thing not working properly, but he said that he has a device that works. He could be able to get from radio waves and convert it to like electricity, more like what Maxwell Chikumbus is doing. And I was like, "Are you sure?" I still doubt you. I'm not. But yeah. Do you want to share more? You want to just hear what Allah is saying?
No, the thing is this. Sharing is not bad, but I just, because right now, if I'm to start to explain someone how it works, the person can easily learn it and they can easily do it because I've done it and it is right from scratch. Without using even a single cell, all you need is a wire like an aerial, and it is able to give you a lot of power, way much more stronger. I've used it for cooking, flat iron, everything, lighting the other bulbs. I showed you the video without need of any other external current. So right now I have no fear to share much more detail about it because I'm just trying to see in case maybe I'm given patent right or something like that to be okay. In case it fails, then that's when I can see what next. But in case anyone wants the verification of what everything, I told you I'm in Kampala, guys. That's where I am. You can make an arrangement, then you see, and then you either believe or you doubt. But I sent you a video of you once I was using it on a flat iron, the other old filament bulbs, then the other chargers, everything. And then you want the one that I was using it on a percolator, everything. So the only thing that I'm now working on is trying to see how to take it out of the area so that you don't, it works without the area. That is why I've not yet launched it, because there are some things I discovered. Not all places within the world have the same frequency. So sometimes changing it from one place to another might affect its working.
Okay,
That's what I realized. Yes.
you can share the video. You can, if you have a video that video which shows it how it's working, not really like showing how you make it, but how it's working. You can show it my WhatsApp. I can play it so that all these other people can see it well and maybe see how they react about it.
I can share it with you, but unless I just try to make another video, then I try to blur out things, because last time what Lloyd says about these MOSFETs, it's just not a MOSFET alone. MOSFET alone cannot work on that thing. So there are other bunches of components that are needed, which if anyone is very technical and is able to see them, I think the person can easily replicate it. So there are the things that I'm trying to avoid. That's why the last time when we spoke with you and we weren't yet like in the same page, I was like, "Ah, let me just leave it, because I might share much of it, and then tomorrow someone falls in it and is able to do it."
Chris, can you ask your guest there to pull back on his microphone? It's too powerful, and it's just I'm not understanding anything. It's just distorted on my end. The microphone is the volume's up too much on it, and it's distorting.
Sorry, so what about the? Is it
Like
now okay?
Yeah, that's a bit better. Yeah.
Okay. I was saying, I've made it like the MOSFETs alone, as Lloyd says, can't do anything. But there are other bunches of components that are needed for it to be able to trap the waves, and those frequencies are what is converted into electricity. But it gives way much more powerful electricity than these ones. Still able to use it for cooking, lighting, everything you want. Even though you want to make EV cars, you can still use it for.
I'm sorry, Chris. I didn't understand any of that at all. The audio. Can you just tell me what you said there? It's just the microphone. There's a lot of kind of noise on the microphone, and I'm just not understanding what he's saying there. Do you want to just explain what he said?
yes, it looks like there's an issue with this microphone, but basically for him, I reached out. He said that he has a more like a tech where you can be able to get energy from radio waves, more like what Maxwell Chikumbuso is doing. So then I did ask him to share more, like if I can be able to see it or what he has, but he was a little bit scared to share more, and is what he's saying, because I was asking him if he can be able to share a video of the same. He's saying that he's afraid to share because he feels like people will copy it, stuff like that. But he's saying that MOSFETs alone cannot be able to work. I think that is what Lloyd was explaining in a previous. There's an audio I was playing. Lloyd was saying that it is MOSFETs that was helping Maxwell to be able to amplify current. So he's saying that MOSFETs alone cannot be able to do that. I think for him, he knows a different way or technique that he's doing that works. But now he cannot. If he could have been able to share maybe a video of what he's doing, then we share, everyone can see it, and then like it will have been easier. But also your microphone is somehow a little bit, I don't know, louder or more like bass, like the bass is very high or stuff like that. Or maybe
Mine.
yeah.
My microphone or
No, his lamp
yeah.
lamp.
Yeah, he needs to what he needs to do is he needs to mute. It sounds like he's playing something in the background as well, and it keeps jumping in. So if he's not talking, I'd probably suggest that he mute his microphone, because obviously you can hear that it's coming in while we're talking.
Yeah.
Now going back to Maxwell Chikumbuso and his idea of his TV working, and the whole idea that when you look at the picture, there's a lot of MOSFETs there, as you know. So he's obviously using them as part of it. Cheers, Dan. But so I was thinking, if the whole idea of ambient light, if you get power from ambient light, when you strip a TV, an LED TV, when you open up an LED TV, what you see is LED strips on the TV, and a lot of the time when the TV goes, it's one of the LED strips is faulty, and you just replace the LED strip. But they're actually placed a couple of inches, like you have a strip, and then there's a couple of inches, then another strip, and then another strip, okay? And there's nothing in between them. So I was thinking, and I'm trying to work out Maxwell Chickenbusso's idea. And I just come up with this idea. Now, I don't know whether he's doing this or whether it's possible, but I was thinking, what if you got small solar ambient light solar panels, and you fitted them in between the gaps of the LEDs, the LED strips, and wired them all together. So when the TV switches on, it won't affect the actual picture, but yet it will, them ambient LED solar panels would get a small amount of energy from there. And by getting that small amount of energy, he can amplify it in whatever way possible. Maybe his MOSFETs or something. And that's how he does the self-powering TV. Now, I'm only guessing at this. And I don't know whether that would work. And maybe down the line, if I get my hands on a TV with, and I stick loads of solar panels in. I mean, this is the whole thing about experimenting, and everybody that's on this channel and what we talk about is to kind of share knowledge and to try and find a solution that we feel works. But, as they say, when Thomas Edison invented the light bulb, he actually, when they said, oh, you had 1,000 times trying to design the light bulb and you failed 1,000 times, he said, no, I didn't fail 1,000 times. I just found 1,000 ways of how to not make the light bulb. So he put a positive spin on a negative. And I think what we need to do is not so much the infighting or arguing with each other, but just to share all the knowledge that we have between us to see if we can come up with a solution. Because I don't think we'll ever get to see Maxwell Chickenbusso's TV.
Yeah, exactly. That's why when you say that you hope you can get your hands on one, I laughed, because I wanted to ask you, like, are you sure you can get on his TV? You can get your hands on his TV. But
well, we won't get his hands on his TV. But what we can do is we can brainstorm, and we can kind of step outside the box, think laterally, rather than be restricting ourselves to what we've been indoctrinated to believe. I'm reading a great book at the moment by a guy called William Tompkins, and it's all about his connection to extraterrestrials actually working with ETs. And this is going back to the 30s and 40s. And I have the book downstairs. And what he did and his team that he worked with, the way they thought about how to fix a problem, they didn't restrict themselves with the indoctrination or what people saying, you can't do it. They just said, what if? And then just let the juices flow and start thinking of ideas. And then eventually turn these ideas into proper products and technology. And so what we need to do is, that's what we need to do. We need to all work together and brainstorm, and before we turn around and say, no, that won't work, we have to try it. I mean, that's what I'm about. That's why I did them videos. Yeah. I wanted to try it to see for myself if it worked. It doesn't matter if 10 people tell me it's not going to work. I want to try it to see if what happens, Yeah.
By the way, for you want to try it. I did saying that's a total guess, Alan. There's no amplification without losing more power. And I also want to play this video. This video was shared by Travman. According to Travman, I shared this video that they explain how you can be able to use LEDs to get maybe something from a solar panel. So I think it will also help you maybe when you're going to do the next experiment. But now, what do you think about now this guy Lam? Now, do you think maybe for him he has figured it out or not yet? Because he
Who's
says,
the
yeah,
who figured out Lloyd?
no, Lam. This guy who is on the whose speaker we cannot be able to hear it. His microphone we can't hear it like much better.
Yeah, unfortunately, Lamb's microphone, he was over driving, and I wasn't really understanding what he was saying. But look, if he has an idea and he says that it works, then like everything else, you need to have the evidence. You need to show what's going on. Now, I know he doesn't want to reveal the technology because somebody would steal it, right?
Yeah,
and
that's what he says.
if his motivation is to make a device where he can sell it and make millions of money, loads of money, that's fine. That's not my motivation myself. If I can put together a system that works, I will show you how it's done. And if 100 people go off and copy it, well then great stuff. I don't mind, because I'm not doing this to make money. I'm doing it to prove that it can be done. And I know, as I say, people in the past have done some great stuff, but they've been either bought out, they've been either killed, or they've been shut down, or they've been ridiculed. There's too many people out there have come up with great ideas. Now, I'm not saying they all worked. Probably 90% of these ideas didn't work, but there is a 10% that did work. And unfortunately, anything that threatens, and it's funny that the book I'm reading with Bill Tompkins, who does this advanced technology, one of the things that he said in the book was, as soon as you threaten the petroleum dollar and the electricity companies, then you become a liability and they need to shut you down. He says it in the book, and this is going back to the 40s and 50s.
So it is true that there's some sort of security issues when you come up with such technologies.
Okay, so what security issues is Maxwell saying with Say It?
For Maxwell, just says that people are after his life. But let me play this video first from Trevman, then we'll continue.
Okay.
Yeah.
Hallmarks LED solar simulator model HORSSLED.
Wait. Oh, the video is audible, right? I think you can hear it. You can hear the video, right? Hope you can hear it.
02H is a precision LED-based illumination system designed to provide stable and customizable solar radiation for photovoltaic, material science, and environmental testing applications. The simulator delivers a wavelength range of 380 to 940 nanometers with adjustable irradiance up to 1000 watts per square meter at the working distance, enabling light intensity variation from 0.1 to 1 sun. Featuring a horizontal beam orientation and a 32 by 32 mm illumination area, the system provides uniform and repeatable illumination with Class B spectral match, Class C spatial uniformity, and Class A temporal instability. High-efficiency LEDs offer a long operational life of up to 10,000 hours, instant startup, low maintenance, and enhanced operational safety. Additional features include adjustable color temperature, pulsed mode operation, a programmable timer, and forced air cooling for reliable performance during extended operation. The system supports both manual and PC-controlled operation, making the HORSSLED02H suitable for accurate solar simulation in research, device characterization, and laboratory testing environments. Hallmarks LED solar simulator model HORSSLED02H.
It looks like an advert though, but model is a precision LED-based illumination system designed for stable and customization solar radiation. delivering a wavelength range of. Do you think that this will help you more? Although now this one now, can you be able to wrap it and like the way you guys do along the solar panel?
Well, the problem is with the sun is that you're dealing with a lot of frequencies and not just one or two. And unless you can actually simulate all the frequencies you're getting from the sun, basically have a fake sun, then you're going to have a loss, I think, anyway, on a solar panel. Whatever solar panel you use, or whatever you try and use to try and compensate for it, if you cannot replicate the frequencies of the sun, then you're not going to get the benefit. You're going to have less energy being put into the actual solar panel. That's just my guess.
So, like the option you guys are doing is much better than compared to this one.
Well, the whole idea of when you're developing and playing around with a project, right? Maybe that device might be ideal to try and get the best quality light that you can get for the solar panel. But look at the size of it. I mean, it's huge, right? So, and normally what you do is when you're making things, when you're inventing, you make them, prove that it works, and then the next question is, how can I make that smaller? So maybe if you were starting off, you bought one of these to prove the point with LEDs, and if it did work, then you'd say to yourself, well, okay, how can I replicate that but make it smaller? And look, I know one of your listeners there was talking about the technology and talking about guessing. I mean, they probably have more of an electronic background than I do. But the thing is, you have to understand with me, even if 10 electronic engineers tell me it can't be done, that won't stop me going to try it. Okay, so there's no point somebody trying to push their belief system or their knowledge onto me to say it can't be done and try and stop me from doing it. I'm still going to do it because I want to see it myself. Okay, so and chances are they're probably right. I'll do it and go, oh yeah, they were right. But that won't stop me from doing it just because somebody tells me. There's been too many times in the past where people were told, oh, it can't be done. I'm an ex-corporate IT guy. And according to the book, it told me it can't be done, but I did it. So I'm not a person to believe when people say, oh, you can't do it, because I've been in that situation where I've done it when I've been told, oh, you can't do it in a corporate IT situation. Okay, so I appreciate their comments and I respect the comments and the knowledge, but I'll still want to do it and want to have a play with it.
Lam, do you want to say? Lam, you're joining like twice. Yo, Lam. You want to say something? Lam.
Hello?
I don't know, Lam, you can hear me?
But I'm hearing a lot of echoes.
Looks like there's an issue on your side, but you can you hear or you're gone? I think it's like you joined twice, so you can hear.
Yeah. Now, can you get me?
Yeah.
Am I having echoes or it is now okay?
I think it is okay, Alan. Yeah.
Is it able to get me?
I'll just unmute there. No, the volume's okay now. I'm just having a bit of difficulty understanding his accent, so you might have to just translate for me, Chris. So just
you will speak slowly. He's from Uganda, but he will speak. I think Alan just speak like you will understand within a minute or so.
Yeah, it's okay. Then maybe let me speak slowly.
Yeah.
Now, about that photo, like that thing that they have said, I believe it is possible because there is a certain video I watched and a certain guy did it way back, that same technology. So I was even thinking of replicating it because there is a certain kind of, there, what they have to do is there are two things. Once those guys have done that thing that is able to connect with the radiations from the sun, there are some things that I realized that can multiply power. I know in physics does not coordinate, but I've tried it and is able to multiply electricity. So
Yeah, which thing was that?
no, there are some other components that I added. Actually, it's another project that I was working on, power multiplication system.
Mm.
Okay, you said the sun can multiply the electricity,
No,
and how is it doing that? What are you using to do that?
now, after making the ones that are able to get electricity from the radio frequencies, I started making one that is able to multiply electricity. And I was using a 100 Ah battery, actually a 50 Ah battery, and was able to run a device of 500 watts for close to 5 hours. When I put that technology, so implying that that device cannot be worked on in real sense. Actually it was 45 Ah battery. It cannot run that device even for an hour because it was an incubator, egg incubator, because it's what I make. So after putting in a 45 Ah battery, I put in that device of mine, and something that couldn't run it for an hour was able to go for around 5 hours. So I believe in some of these things. They are, if they have the ability to multiply that power, it is also very possible.
So
Right. Are you using MOSFETs also to do that?
No, these ones I'm not using MOSFET. Actually, I don't know whether you guys call them MOSFET, but they are some specified transistors that I use.
Okay.
Yeah, there are some specified transistors that I used, and the connection is not there in the Google. How, like, you can't, unless someone sees how I've connected them. It does not exist.
Okay.
And
So I
mm,
know you don't want to show what way you've designed it for, what you want to keep that private, but can you do a video to show us the input and output, at least to show
yeah,
that it is doing what you're saying it's doing?
yeah, I can make a video. Let me see, even tomorrow when I get time, I can make it, and then I can share with you. Actually, there is even a video that I have already that I shared with the host,
Yeah, but
but just
that
because
was
it
view.
was one
You
view.
said maybe it was in Luganda. For me, I know like very little Luganda.
Actually, by then anyway, it's okay, but some part of it was in English. Okay, but maybe I'll do one, then I put it in English, and then you'll be able to see.
That would be good to see it, and then maybe we could then, after seeing it, then we can have a chat about it. And then, I mean, if you want to keep it private, and if you
Yeah,
want to, if you say, look, I'll show you everything, but this is a private link, and then we can look at it, and then you can delete the link, just to kind of, and then myself and Chris could go, actually, yes, we had a look at the video, and we can testify that what he's doing is correct. Or it's up to you what way you want to do it.
all right. It's okay. Then what I will do, I will, after, I don't know, or if you would give me either your WhatsApp or something like that, then I can send you the video, either view once, or we can see how we shall do it, so that you are able to see. No any extra external power is being used. It is just the area, and that is it. It's what is producing power. Because actually, there is another one I did, and I was using these these 9 volt batteries. I don't
Okay.
know whether you know. Yeah, so that 9 volt battery was able it was just to power out this device, for the device to be able to work, to do everything you want at home.
Okay, so I've seen some of these experiments using a 9-volt battery and using coils, and although they work, the drain of power on the 9-volt battery was pretty much instant.
Now, for this one's case, the 9 volt battery was not what was lighting it was just enabling this device to work. And in any case, a 9 volt battery cannot have enough power to, let me say, to run a 1 kilowatt percolator even for 5 seconds, but this one was able to boil water in I think 2 minutes, and we just switched it off. It wasn't that maybe the battery still had enough
Hey,
power as
can
it
you
was.
show us? That's the thing that you could be showing us, man. Not, but it's okay. You go on, go on. Yeah, you say
Yeah.
that it's
So
in a few
yes.
minutes.
Yeah. So I just decided to turn it off. However, based on Maxwell's innovation, if he is no longer coming out, then I know that because there is a certain challenge I faced, which I think maybe it also was what he faced. Most of those devices, after using them like for 1 hour, they would be overly strained and they would blow off. So
Yeah.
that's why even after I'd used them, after I'd made them, I couldn't first say that I've succeeded without first of all finding a solution for them.
Well, I think, what I was trying to do, and I said to Chris the last time was, Maxwell has the TV that's working on its own. And that's what I'm trying to, my aim is to try and get the TV to be self-charging. It doesn't have to be, we don't even talk about free energy. Forget about free energy and all that stuff. If we can have a system where it's self-charging, where we can get a TV to work and it's self-charging, then we've really cracked it. That's really, it's a start. So that's really where I'm focused on. So if you have a device that you're getting all this power from it, then maybe what you should do as an example is to get a TV and power the TV and have it self-charging, and then just hold it up and go, there you go, there's your like Maxwell, there's your TV, it's self-charging, and it'll carry on. I take your system is self-charging, is it?
Now, with my system, there was one I was trying to make the ability to self-charge, but I've not yet concluded it because there are some other things that I realized. Like with that one, I failed a lot. I am still on the way, but I'm trying to find a way on how to bring back the power. Because I realize that it brings a lot of power, so I want to bring it back to self-charge. But however, for Maxwell, when I looked at Maxwell's video, it didn't need self-charging. For Maxwell was a bit easier. Let me say easier than what I was doing. Because one of the things that I was looking at was high power consumption. But for Maxwell, it was just once you have the device that is able to bring radio frequencies of around a certain level of frequencies, you just needed to because TVs take around they run in DC 12 volts inside. So it is you just have to give the polarity to the power 12 volts, and then that is all. So it is pretty easier.
Well, Maxwell talks about his microsonic device, and we know that Nikola Tesla did RF harvesting. And I've looked at a few people on the YouTube, making simple projects using RF harvesting, but the power is so minimal, is so small that you couldn't really use it unless there's another way that Maxwell is using RF harvesting that we're not familiar with.
Now, yeah, that is true. RF is small. It comes in is it called microamps or 1 millivoltage? It's very, very small, very, very small. But actually, those small ones are the ones that I get, and I'm able to convert them into something that you're able to use for cooking. So I'm sure it works because I've done it severally.
Okay, well, if you do the video, that would be great to see.
Yeah, I'll make a video and then I'll share it. You see, because what I'm looking at, what I'm doing right now is I'm trying to, cause since I've just developed it, I want to first look at it. How about when it's raining? Can it be struck by lightning? Such things, and another thing, I'm looking at how to take it out completely out of the area, so that let me say, if I'm to make a car, that car has the ability to run anywhere without need of area. So all those kind of things.
So like for you, you've been able to amplify what you're getting out of it, because I think it's millivolts or something. Even Dr. Eli said something like so. Like you've been able to amplify.
Now this is it. there is voltage and current, because even the current itself is too minimal. But now I had to amplify both the current and the voltage.
Like, how do you go about it? If you just explain in a nutshell, in a way that you don't give away a lot of your knowledge.
Okay,
That
then what we do, once the frequencies have been harvested, it has to go through some ice in order for it to be harnessed and then like compacted. Then from there, you take it to, you have to feed it through different diodes, and then from those diodes, then it has to go through some other transistors. Then from those transistors, that's when it can be taken to an output, either to a transformer, to make sure that it brings out the 220 voltage.
Okay, so you're stepping up the voltage. So
yeah, you have to step both the voltage, because I doubt whether those millicurrent, it is both voltage and current, because even though we try to increase the voltage, if the current is not matched, we will not be able to do anything. But
yeah,
it is able to cook. Yeah.
and the current is important as well. Well, I'm just thinking, like, if you had the DC, a 12-volt DC TV, you wouldn't actually have to convert the AC or the DC to AC, because you could keep it at DC and just have like a bridge rectifier and smoothing capacitors or something to keep the DC stable for the 12 volts for the TV.
Yeah, that one could work like that. You could just do it like that once you have those, because radio frequency, the current is AC. So once you are able to reach it, that's why I say that for the TV is something very easier. Or if I was looking at just these small devices, it would have been so easier. But I was looking at it being able to power heavier, power consuming devices. So that's why it took kind of long, and it had to take a lot from me also.
Well, I wouldn't worry too much about, if you can get the concept working, then your next question will be, how do I reduce the size of it, and how do I increase the power so I can power bigger devices? So once you have the concept and the concept works, then all you have to do is just the scaling of that.
Now, the thing is this: the device is not big; it is very small. The only heavy thing from it is just the transformer. Let me just go to the bedroom, because I even keep it in my cupboard. It's just something very small. It's not something big.
Chris, can you go and enlarge the videos, because if he's going to show us something on video, so we can see it.
Yeah. So, in a nutshell, this is just the device that is able to do it.
bring it to see.
Yeah.
Okay. Yeah.
Okay.
Yeah. It is just something small.
Okay. It's off camera at the moment.
You can.
Yeah.
Just, are you able to see?
Yeah, like bring it to your face now. Bring the camera is in your face, so bring it closer to your face, maybe.
Are you able to see?
You can. Yeah, there. Okay, yeah.
So it is just something small.
Okay, so is that your circuit board that you put together?
Yeah. This is my circuit board that I put together. So it is from this, and then it has to just be able to go through the how do I call it? From this, you just only need the area and then the transformer, and you're able to do everything.
Okay, so and what you're getting is that you're putting in DC, but you're getting out AC.
No, we don't need any other power, external power from this.
Right. Okay.
Yeah. The only thing you need is an area.
Just an area. Okay. So that's an RF device then. That's where you're getting the power from. So if you have the bigger the antenna you're going to have, the more power you're going to get into it.
Actually, what I did, I just tried with these local antennas of our old TV antennas. Yeah, let me just go out, and I'm able to show you.
Now, the antenna that you use is obviously when you're using antennas, the wavelength of the antenna is going to define what frequency you're going to use. So, is the wavelength important to the power that you get from the antenna?
Yeah, exactly. Because there are times when my outside is a bit dark, so you're not able to see. But the wavelength, because that's why in most cases we have specific wavelength that we use with this one. Because if it is too much, then you will realize that the power would come too much and it is able to destroy this. But now, if it is again too less, then it's not able to power it. So that's why I said what I'm going to do is to make sure that I give it its own wavelength that it needs, so that there is no there is no interference from outside, and
Okay.
by that is able to work without
Okay.
any.
What frequency is that? What wavelength are you allowing that? What is it
It
using?
is,
What frequency?
it is 12. You get it?
Is it like
Because
is it like 400 megahertz? Is it 800 megahertz? Is it 2 gigahertz?
now this is it. I don't know how to explain to you, but I I personally I don't have those specified meters that are able to measure that, because I've not yet bought one. But what I do, I go to my meter and there is a certain specific one. It's just 12 that I measure. So when I see it 12 or 16, then I'm able to use it. If it is below that, then it can't. If it is higher than that, then it will be able, because I have not yet bought those other sophisticated equipment to tell me exactly what it is.
Well, the smaller the antenna, then obviously the higher the frequency. So, like if you have a CB radio, the length of
Yeah.
the antenna, the wavelength for a CB radio is 8 foot 4 inches, something like that, right? But as you go higher in frequency, if you go higher up the actual frequency to say 2 gigahertz, then if you look at a Wi-Fi router, the antenna size on the Wi-Fi router is small because the frequency is higher. So 2.4 gigahertz, which is Wi-Fi, would have a smaller antenna. So how small is your antenna?
No, what I do, I don't know. Okay, there is antennas from the radio, from the TV, that are used in the TV. They are
Okay.
like,
So a TV antenna would be VHF, UHF, around in them frequencies.
yeah, I think so. I wish there is a way maybe how it would show my screen so that I go to either Google, then I'm able to show you.
Yeah, well, analog TV uses VHF and UHF, so you're in around them frequencies from about say 100 megahertz up to about 500 megahertz, give or take. That's probably the range of frequencies you're dealing with.
Yeah, that must be it, because I'm using the ones for the TV.
Yeah.
Yeah.
Okay.
Mm.
Well, it'd be good to see it. I mean, looks good what you have designed there on the circuit board. So it'd be good to see it working. Now, you did say that you don't need any power, but you did mention the 9-volt battery that you need to connect it up.
Okay, I mentioned that. I said I made two devices. There is one that I needed a 9-volt battery to power it, and then this other one I don't need any battery to power it.
Okay, so that's kind of phase 2. The first one you use the battery, and now the second one you don't need the battery at all. Okay.
So true. I first used the one that I needed the battery, 9 volts battery. And then afterwards, that's when I went and I did this one that I don't need any battery.
Very good. Okay, well, it'd be great to see it working, and see it in action.
Yeah, I'll make probably tomorrow when I get time. I'll make a video for it, and then I'll be able to see.
Yeah. I wish you could share. I wish you could share a video. It could be free. You can hide the things that you say you feel like we will be able to steal your stuff. But you see, when you share a video and someone sees that it is working, also people will understand more. Because for now, just ask a simple question like if people believe what you're saying is true or not. And I see 100% says no, although I don't know how many people have answered that question. But only one person. So if it's only one person, it doesn't matter who has voted and said no. But you see, if someone sees maybe what you have, they now maybe might believe more. But usually the biggest issue with radio waves is you get millivolts from it.
Yeah, That is
Bridge.
true. They are very, very tiny.
So
If
so
you
that's why.
if you yeah if you can amplify if you find a way to amplify the power that you're getting either from RF harvesting or even ambient light, and that small amount of power can be amplified, which is probably what Maxwell is doing, then I think you're onto something.
Yeah, because actually, even another thing I realized, based on this, it is also very, very possible to make wireless charging system or wireless electricity transfer, like being able to make cars that actually it's another project I'm now starting to do, making cars that charge wirelessly as far as 5 kilometers away from the power source. It's now another project I want to try to do, so that
Yeah,
I
well,
see.
I think you're right. I mean, we already have mobile phones that charge with a coil. So you have two coils, one on the mobile phone and one on the
Mm.
base. You know, inside the new cars today and the new mobile phones, you just put the mobile phone on top and the phone charges because of the coil underneath. So that's what you're talking about, yes? The wireless.
Now, that is there for using that coil, but now this one here, where I want to be based on this, I want to try it without using a coil, whereby because the coil cannot be effective 1 kilometer, it has to be very near it. So I'm trying to look at being able to make a device that is able to transfer power. Let me say 2 kilometers away wirelessly, where let me say a car is here, and let me say you're in the jam, and the charging station is 2 kilometers away. You only tap on the screen with a button, and you're able to charge your car while it is running without needing all those other things of coils and stopping and things like that.
Well, I think
Because I
that's what.
realize it's possible. Yeah.
Yeah, I think that's what Tesla was doing with his Wharncliffe Tower before JP Morgan, pulled the funding. He wanted to transmit the power wirelessly, and then what you'd have on houses, they'd probably have an antenna on the house which would pick up that power and then convert it and then power the house. But because JP Morgan, being who he was, a banker, he wanted to make money from it. He wanted to meter it, and because Tesla didn't wanted to give it away for free, he pulled the funding, and Wharncliffe Tower was pulled down. So I think that's really what you're talking about. It's to obviously send out the electricity where people, if they have the right antenna tuned to that frequency, they can pull that power from it and then bring it into the house and power, get power from that.
Exactly. That's what I'm looking at right now. It's what I'm looking at. Actually, it's another project. Once I'm done with taking this thing completely out of the area, that would be the next I'm going to work on. So that once I succeed in it, then I know we shall be able to transfer power wirelessly into people's homes without needs of wires and stuff like that.
Well, that'd be fantastic if you could do that. That'd be brilliant.
Yeah, I'm trying to work it out and see.
Brilliant. Well, keep up the good work, and even if you don't want to show us, the makings of the technology, if we just see it working, that'll be a step in the right direction.
What we shall do one time, I will show you people, but I first want to try to see if at all they are able to give me patent. That would be okay. But if at all they can't, then I'll have to think through it. Why die with something that would help?
Well, you might be the next Maxwell Chicken Boso.
Exactly. That's why what I'm trying to do. I don't want. That's why I've not told anyone. Actually, you guys are the first people to know. Apart from just my few inner cycle, the pastors, some few friends who have ever seen it work.
So
I'm not yet sharing it out because I'm looking at a way of how to maybe capture the top people in the government, convince them, so that even when I come out, I know I have a certain backing behind me.
just to cut you off for a minute, but now your microphone is working like great, and Alan has tuned his ear to your accent. It's usually
Yeah.
just the first time when you hear a new accent, sometimes you can fail to understand. But there's a guy called Moonkau. So Momokau is saying that he's also working on the same project. I mean, like what you are doing, Alan, and he says that he wants to replace the charge controllers with a PWM version, and he's saying that he's going to do this next week. So I guess also we will get more information from his side on the results that he will get. Usually comes on the lives. It doesn't join, but it's usually on the chat. So I hope you'll be able to share more when he gets results. And also ideas here. But Lam, I'm still waiting for you, man. I hope you'll be able to share more with this if it's true. I still have this feeling that Lam is just playing with us, but
No, you know, that day when I spoke to you almost made me angry. I was like, "Ah, let me just give up on this man and just continue with my own thing because no one could believe it. I
like I
have,
get so you see mostly on my videos, I usually post my email somewhere under the video on the first
mm,
comment on the description. Where I tell people to feel free to reach out in case there's something. So I usually get a lot of people who reach out. They say that we have this, we have this. But now when you tell someone, like I'm making this, I've developed this, there's a guy who was saying that some sort of magnetic tech that he uses to create electricity. When you tell them, like, because for me, like I want to see it like in action. Like can you share in action? It's not like I'm gonna copy it. Hide what you want to hide, but just show it on video in action. Then someone starts taking you through the circles, the circles, the circles. So like that day I was like tired of such stuff, you see. And then for you, you're saying that I'm gonna share this time. That time comes, there's nothing. You say that wait, I don't know, tomorrow I'll call you. Tomorrow, nothing. So I'm like, this man is just playing with my with
okay,
my
what happened that day was I had some work to fulfill, and on top of that, I also I had deliveries to make, and I had to first make sure who is this whom I'm going to share this with. Is it some like is this the rightful person to share it with? So that's why I was like, let me. I have to first call you, we talk, and before I continue. That's why I just needed that, but nothing else.
okay.
Yeah.
Well, again, you know, at the end of the day, proof is in the pudding, as you say. If you show us the evidence and it works, obviously that's going to be phase one. And phase two will be, well, how is it working? Because you're going to have to either patent it and protect it before you show us what you're doing. And then if you patent it, well, they'll be questioning you on the technology. And if they think you're breaking the laws of physics, then they're obviously not going to give you a patent for that, you know, because they'll but you know, it's you're going to have to show it working at some point. But I know you probably want to protect it for now, but at least for phase one, at least if we see it working, then we can go, okay, well, that's interesting. Now obviously we need to see it and see how it's working, but that's going to be more of a phase two.
Yeah. It's okay, no problem. I think even tomorrow, let me see how my schedule is tomorrow. I can record the video without anything, just an area, because then you see, you will be able to prove it and say, yeah, it works, or this guy is a scammer.
Okay. Momoko class is saying that
Or what
if
you can do, you can even tell me like what device do you want me to power it with, so that you can see. Because actually, another thing I realized, small as it is, this thing, as small as it is, the amount of power it brings, it is equal to these big 5 kilowatts generators. As small as it is, you can be able to pocket it, this thing, as small as it is.
Okay, well, that's a big statement to make, that can generate 5 kilowatts. That's a big statement to make.
I think
would
can even go over that, because the devices that I've tried to put on this thing. You saw the video, one of the videos.
I saw the
You
video
can,
in Uganda, and it once I could not be able to watch it over and over again, and like because I have to watch it and try to understand what is this all about. That's why I was saying, if you're willing to share, I don't think that there's something that someone can steal from it. If you can show on my WhatsApp, I can play it right now. Although it is in Uganda, so maybe you could translate to
yeah, this other one I made it in Luganda. So that's why I have to probably make one video tomorrow in English.
Yeah.
Yeah, but it works perfectly
I
well.
have a question for the panel, if you don't mind me jumping in.
Yeah, go ahead, ID.
Yeah, good morning, good afternoon, good night. I don't know what time it is where you guys are. So, so with Alan doing his experiments, with Lamb doing his experiments, what do you plan on doing with the results?
Well, from my point of view, I'm just experimenting to see what is achievable when what power comes out. I mean, I mentioned earlier about, I like Lloyd's idea where he has the solar panel outside, which charges a battery, and that battery powers the LEDs. Now, if you actually spec all them devices properly, then there's no reason why you can't get enough power to charge batteries 24/7 using the solar panels. Now, I haven't done it myself, so I'm just going by what I can see what Lloyd is doing, right? But for my own experiment, I just want to, my goal is to try and get a TV to be self-powered, like Maxwell Chickambuso. So whether that's solar, whether that's RF harvesting, whether it's some other technology, I don't mind. I'm not tied to one technology. I just want to see if there's a way, using what we have out there at the moment, whether it's MOSFETs or whatever, to try and self-power a device so we don't have to plug it in. Whether I'll do it, I don't know, because I only have a certain level of electronics. I'm not an electronics engineer. I have done electronics, but I'm not an electronics engineer. But I'm willing to at least experiment and buy a few bits and pieces and have a try and have a go at it and see what happens. As I say, it goes back to Thomas Edison and the light bulb. He didn't fail 1,000 times. He just said he found 1,000 ways not to design a light bulb. So, and I think you have to be very inquisitive and not let people who keep saying, oh, it can't be done, can't be done. I've been down that road in IT where I was told it can't be done, and I did it. So I know, and that's why I kind of don't listen to people who say it can't be done, because I've been down that road before. But, you know, if I do it and it doesn't work, I will show the video, as I have done. You guys have seen the videos. And I've said, I know if it doesn't work, I go, oh yeah, they were right. It doesn't work. You know, so I don't mind doing that. And for Lamb, I don't know if Lamb wants to jump in there.
Yeah, what are your plans with the results, Lamb?
I think
Yes, sorry, I have to do while you're cooking, so I'm sorry.
That's fine. That's fine. The question is, when you get your results, what do you plan on doing with the results? Are you actually? I don't want to answer for you. I'll let you answer that question.
Okay. What I'm planning to do with the result is I'm looking at launching a electricity generation company. That is one of the things I want to do, so that people are able to get electricity. Yes, they will be paying something, but we have to do it with the government.
Okay.
That's one of the things I'm looking at. However, if other ideas are brought, they are welcome to the board. I can still take them.
Okay. Okay. The reason why I'm asking, I mean, there is a purpose of why I'm asking. The reason why I'm asking is twofold. One, I guarantee you there are professionals trying to answer the same questions you guys are trying to answer. That's not lost on the engineer, the scientist, the physicist. They are trying to find the most efficient way to do everything. That's a common goal for the rest of their career, for the rest of my career. It doesn't go away. Now, the reason why I asked the question is, what if an engineer is the one that comes up with these solutions? Like, at what point do you say, this is beyond my level of understanding? I have to at least hear what someone who studied this, right? Not tinker, not just mess around with it. Someone who's actually spent their life on this. I would love to know that at least what have you tried already? And that's why I asked the question, what do you plan on doing with your results? Because the results that you're looking for already exist. The answers to the questions, specifically, Alan, when you were saying, I just want to know if it works, those questions have already been answered. Now, is it not valid because a scientist figured that answer out? Or at what point is it that you say, okay, this has already been figured out, let me try something else?
Because I want to do it myself for my own interest and for my own knowledge and my own learning. You know, there's been many times, and I've interviewed on my radio show people that have been told in the past, don't do that, don't look at this, that's been done, or you can't do it. Time and time again, I've heard this. And even with as I said, the book I'm reading now regarding Bill Tompkins and the advanced technologies these guys are working on are just way beyond what people are aware of. And even with the skunk works, when I talk to people about the skunk works, they say, who are the skunk works? Well, they're the people who developed the SR-71. And as I said before in Chris's show, Ben Rich, the CEO of Skunkworks, before he died in 1995, he said, we now have the ability to take ET home. These guys have advanced technology and advanced knowledge, but they won't release it because they, like I said earlier on, in the book that I'm reading now by Bill Tompkins, and if you go on YouTube and type in Bill Tompkins, you'll actually see videos of him talking about advanced technology, right? He said in the book, and this is in the 30s and 40s, he was saying in the book, he said, they are concerned about the petroleum dollar and the electricity companies. And if they brought out the technology out to the public, it would have a massive effect on the economy and society. And that's what they were concerned about. And that's why they kept their technology to themselves and they didn't release it out into the general public. And and I'm aware that there are things out there that are kept hidden for that reason. Medical devices that can actually cure cancer. It's been around since the 1920s, but they don't want to release it because the amount of money Big Pharma makes, and I used to work for Big Pharma, the amount of money they make in chemotherapy is just incredible. It's just ridiculous. So there are technologies and certain knowledge on regarding medical cures that will be kept secret because it will affect the bottom line of big corporate. And so I'm not being disrespectful to engineers or people who are doing it, but I know that there's more ways of doing things and you have to think outside the box. And sometimes there are people who are working in a business who can't think outside the box. I mean, I've worked for IT people who have said, you can't do that, it can't be done, and I've done it. So that's why I'm very skeptical when people say, but I have this expert here and I have this doctor here and I have this guy over here who's an expert and he said you can't do it, so you shouldn't do it. I've heard it time and time again. And people have gone and done it. So that's why it's not disrespectful to them. People will form an opinion based on the knowledge they have. And if their knowledge is limited, then they can only form an opinion based on that limited knowledge. And this is why my background in psychology as well, I talk about the fluid belief system, because a lot of the time, and the people I deal with all the time, is that when I give people information that challenges their belief system, they shut down. It doesn't resonate with them, or cognitive dissonance kicks in and they can't take it. They can't take the information. It's too much for them. And I see this, and I've spent 26 years, researching this alternative subject or subjects, and 16 years doing podcasts, interviewing hundreds and hundreds of people, from scientists to MI5 whistleblowers to military men to doctors and everybody in between. And it's amazing what they have told me that the general public don't know. So we have an education system that is very indoctrinated, and they will tell you what they want you to know. And if you try and go beyond that, a lot of the time they'll say, oh, no, you don't need to do that. Or that won't work, and they shut you down. Now, what you have to do is you have to stop yourself and you have to say, okay, that's what they said. But hey, for the hell of it, I'm going to give it a try and see what happens.
Yeah, there's absolutely nothing wrong with trying whatever you're trying. Lamb's doing what he's doing. There's nothing wrong with that. It's the
ID.
Yes.
Maybe for your question, maybe Lam can also answer. I think Lam said that his background is an electrical art. Oh, he's gone. He's gone.
Sorry about that.
I think he's gone. But yeah, you gone.
So there were a couple things that were said that were kind of like, it's definitely pushing conspiracy. Let's be real. Let's keep things into context. There's a lot of conspiratorial basis in what you said. And I
But
do believe, in my opinion, but just based on the conversations we've had, I
Yeah.
think you do chase the conspiracy more than the truth. That's just my opinion of just the little bit of dialogue we've had. I do know that a lot of your responses are based on what they will reject you from doing. But sometimes that advice is not rejection, it's based on not a belief. That's why it's not indoctrination. That word usually gets thrown around a lot when you start talking about professionals, especially engineers, being indoctrinated. I have been literally taught to think outside of my experience because that makes me a better engineer. So when someone says I've been indoctrinated, it's not that I believe that the physics work. Part of my studying is proving that the physics work. I spent 6 years studying physics, breaking down materials and understanding the properties and how they actually interact one another, electric fields, magnetic fields, and actually mathematically model it before I get the results to see if the math matches reality. These things are practiced every day in an engineering field. So when you say indoctrination, that's leaning on conspiracy because it definitely tells me you may not have had the experience of being in engineering college. I'm speaking specifically engineering because I can't speak on all the sciences. I can't. I can tell you specifically about the realm of engineering. I've practiced. I do practice. I still practice. It is not indoctrination until you get to the point where my knowledge base is limited, where I can't. If I start talking about medical interactions, I'm outside of my element. So now I got to believe and I don't have to believe it, but I can't have a full opinion of what's going to happen if I haven't practiced that. How am I going to give an opinion of that? I'm outside of my realm. I have to learn and be taught to do that. Stay in your pocket. This is your lane. This is your expertise. If you're going to go out here and you're going to be talking about these things, make sure you know where your boundaries are. That keeps me, at least, if you want to say, I think you use the word shut down, if you want to use that word to kind of speak on that. But it's not indoctrination. It's more based on the experiences of learning the subject. How do I impact a space without knowing what's been done already? I have to study what's happened, what's happening now, what potentially could happen, and then I include myself into trying to figure out better ways to do things, new ways to do things. That is typically how things are discovered. Give me the percentage of people discovering things. You said you've done it yourself. You figured out things someone else told you couldn't do it. I guarantee you had some level of background in what you were doing. I don't think you walked in the door and just said, "Hey, I know what to do."
Yeah, but let me clarify that. I haven't been to engineer college, but I was a senior IT manager and in charge. Yeah.
Before you come in, let's allow him answer the first question.
Oh, the original question.
What is your background?
My background.
Yeah.
It is so amazing. I'm an agriculturist.
Oh, I thought you were in Chico. Okay.
But I had to cross. Actually, from birth, I was gifted into electricity. It's actually these things of engineering and so on. But I was originally, I graduated from Makerere University in agricultural land use and management. So then after that, I just didn't have passion for what I studied. Actually, I even didn't succeed well. So I had to cross into engineering because that's what I wanted. And I started practicing it some few years back, and then this is where I am. So actually, even right now, most of all my work is just about engineering. Now, Mr. asked about what is the main reason as to why you want this? Other people have done it, so why? Now, the thing is this: most people have done it, but the way how they have done it is different. Because the only knowledge that people know about AC is through electromagnetism. That is the most, actually, I think it's the only one that people know. But now this one about radio frequencies brings another form of electricity in itself. It's still AC, but it's another form of electricity generation of its own. That is not yet known. So, however, even though right now we say that we are to go into the other old form of electricity generation, you'll realize that we need a lot of dams, we need a lot of fuel to be burnt in order for them to be able to run in the motor, which this one solves both of them. So I realized that's why what I'm looking at is electricity generation, because this one is going to save us all the other hassles, all the hard work. Imagine you don't need again years to build dams in order to be able to make electricity. You don't need again to be able to burn gallons of fuel daily in order to be able to run some coils in order for it to be able to supply a whole neighborhood. So that's why I'm pursuing it.
But you said this is a different form of electricity?
Actually, it's not a different form, but actually, let me say a different form of electricity generation, but still the same electricity.
But you're using radio frequency.
Yeah, radio frequencies.
But radio frequency, you would have to convert to electricity in order to use it as electricity, right? Is that our understanding?
Yeah, that is it. But the
So
conversion
you're converting.
Yeah, I'm converting the radio frequencies into electricity.
We have that.
But to which extent?
Anything wireless.
Yeah, anything else, but has it reached a point where it is able to be used apart from just charging the phones? But can it be able to cook? Can it be able to use to power EVs?
Yes.
And then I would be happy if you are able to show us that.
This is a physics limitation here, and I'm not speaking out of opinion. I've studied this extensively, so I'm not just giving you my opinion. When you're talking radio frequency, Alan mentioned earlier, we were talking about frequency bands and all of those things. When you're talking radio frequency, if you're in the field of that electrical, that RF frequency, that frequency is low. Because if it gets to a certain point of energy, you will burn. So the energy that you're talking about is at higher frequencies. It's at higher frequencies. So let me ask, what range are you talking about as far as frequency harvesting? What band?
I'm just speaking about the band that mostly the TVs use. And it's not limited to
very, very low. That's extremely low because we exist in it. So this is why I was saying, this is why I'm being specific with the frequency band. Yes, we can go to higher frequencies to get higher energy. The problem is we can't be in the vicinity of that. We cannot physically be in the field because it gets so high once it gets to a useful level of energy, not just RF sending signals through a cell phone. That's extremely low energy. When you're talking about energy like cooking, you're talking, I mean, if you do the numbers on how much energy is coming out of that fire to heat the food and all of that stuff, if you convert that to a frequency, you will see that it's way beyond RF frequencies. We talk about televisions. That's extremely too low.
Now it is just too low, extremely too low. That is that we are using. It's not the other high one that is able to destroy someone's life. It is those two very low ones, because there are even these ones that are. Because what I'm looking at right now is once I'm done with this one, there is another one I want to do. The one that is going to, the one that doesn't require either cell tower, but the one that just gets the naturally occurring radio frequencies from the rotation of the Earth.
That's lower than radio frequency from a tower.
Yeah, it's another thing, because I've got a formula on how to do it. So it's another thing I want to do it to get those very, very tiny ones in order for it to be able, let me say, for someone to light, to cook, and to do everything.
Yeah, so this is kind of the path that Lloyd has taken, Chris and Alan. Like trying to take the smaller pieces and then sum them up, like gather them all, and then create this higher energy pocket of energy. I can tell you definitely from experience, the amount of energy that you collect, if you actually sit down and do the numbers of how much energy we're talking and how much energy it's going to take to capture that energy, it may not even be worth the energy to do it. So, but definitely do the experiments. Check it out. Do the numbers. This is what happens in technical schools, in engineering schools. Go write it down, calculate it, measure it, test it, so you can see exactly what you're looking for. You can see it. That's definitely not something I don't want you to do. I want you to do it.
Yeah, now this is it. We don't need any energy for it to capture it. Actually, that's why, like the device I made, I'm from showing you guys here. Those cells, no nothing. You don't need even a tiny cell to be able to capture it.
So you don't need energy to capture energy?
You don't need it. That's why it defies physics. I know that, but it works.
Where does the energy come from? No, I mean, yes. Wait, but I don't want to make it so trivial that, like, okay, it's violating the laws of physics. That is not just something to just say and just ignore. There has never been a known system to even pull this off, and they're still trying. Engineers are still trying to figure out how to make things more efficient, because that's the limitation of our physical world. We can't. There's a certain limitation of energy that, like, you're not going to get over 100% of what's in front of you. That is not a known thing. So if this were even possible, trust me, you have people still trying this at a much, much, much higher level of understanding of electrophysics, electromagnetism, magnetism, electricity, electronics. They're still doing it. Don't assume that it's like left off the table, that no, this is impossible. No, but you can get as close to 100% efficiency as possible. That's usually the case. The better machine that comes out usually is because it's more efficient than the one that was there before. That's usually how we advance the system. It's more efficient. Now, 100% efficiency, that means you're not using any energy to get energy. So if you're chasing that, I mean, I probably wouldn't. No, do what you want. I'm not even going to say what not to do, but do whatever makes you happy, man.
No,
Okay,
I'm not trying to do it, but I've already done it, and that's why I'm out talking about it.
Okay,
It's 100% efficient. Yes.
Say that you share
I want to make
video.
a comment on that with ID. ID, we have to be very careful about, ego. I talk a lot in psychology about ego, and ego is a mixture of arrogance and ignorance. And sometimes and the Dunning-Kruger effect is all about people thinking they know more than what they actually do.
Yes,
and
sir.
I think you have to be very careful when you say that, there's people out there and they've been trying, but you're just giving your opinion on what you know. That you don't know everything. I'm not being insulting when I say that, but you
none
don't
of us
know
do,
everything,
though.
right? You don't know everything, and that's
No,
what I'm saying.
none of us do.
So you're only giving your opinion based on what you know, as I'm only giving my opinion based on what I know, right? But that's why it's important for me to experiment. And I know you said the whole conspiratorial thing. I've no interest in conspiracy theories, right? Because they're theories. I am interested in conspiracy facts, and I know exactly.
There's no such thing as that, sir.
Well, there is, unfortunately. Again,
a conspiracy cannot be a fact, because conspiracy lacks fact, which is why it's a conspiracy. It's a gap of information that you don't have, that you make the assumption to create a link. That's a conspiracy. So it cannot be a conspiracy fact. That doesn't make sense.
Right. Okay. Let me put it this way. During the 60s, when JFK was actually assassinated, right? There was too much media querying what happened, the magic bullet and all that stuff. So they decided, the FBI, the alphabet agencies decided to get two words and put them together, which was conspiracy theory. Conspiracy theorist. And he said, right, anytime anybody asks what happened, just insult them by saying conspiracy theorist. And then that's the best way to shut things down. And that's worked very well since the 60s. So normally when I hear people turn around and say something to me like, oh, you're a conspiracy theorist, I know their knowledge is limited, and their opinion will be limited, because they haven't opened their mind. They haven't stepped outside the matrix and questioned what's going on with the system. That's what I've been doing for 26 years. And that's why I've done 16 years of interviews with MI5, whistleblowers, military, doctors, scientists. I've done so many interviews. Okay. So I'm not saying I know everything. I'm still learning, but I feel that my open-minded approach to things is, I've learned so much by listening to these people and them telling me things that the general public do not know or they won't accept. So it's and that's why, and as I say, with respect to anybody who's qualified, yes, I didn't go to engineering college, but I was a senior IT manager in the corporate world, and I was in charge of 16 offices across Europe running the infrastructure for companies. So I do know, IT, and I
But
do
that's
know.
why you solved the problem of someone telling you it didn't work, because you had the experience and you had the knowledge, sir.
Correct.
They
Correct.
didn't ask you to do heart surgery. They asked you to do something that was in your lane. So you did not. That is not a good example of doing something that someone said it was impossible. You were on the job. You knew the job. You knew how it worked. And you knew, hey, I have a different approach. That's an experienced person walking in the door. That's not a layman.
Yeah,
That's
but
not
hang on.
somebody in their garage trying things out. You knew it. You
Yeah,
knew what you were doing
yeah, but
up to
hang
the
on.
point of their limitation.
Hang on. What I said was the book was telling me, which the book is written by so-called experts, that it couldn't be done, and I did it, right? So that's what I'm saying. Just because you have experts coming out saying it can't be done, and a lot of these people, experts, write books to tell people you can do this, but you can't do this. I kind of ignored it and I went off and I did it. And that's what I'm saying. I'm not knocking education. I love learning. I love education, and I love, trying different things. And I know you say stay in your lane. No, I will never stay in my lane. I will never stay in my lane. I will
Of
push.
teaching,
I will
of
push my
teaching. That's
knowledge.
all.
Yeah, I will push my knowledge in everything I do. And and there's a limit to what I know. I've said to you, I'm not an electronics engineer. I've done electronics, but it's limited knowledge, right? So I will go as far as I can in what I know, and then what I don't know, I will then ask people who will hopefully will know. But people who are willing to go beyond the, what the textbook says you can and can't do, and to say, well, okay, let's give it a try, because that's the best way to learn, is to just bloody do it yourself and give it a go. And if it fails, hey, it fails, but give it a go.
I would challenge that and say you probably want to learn from what's been done up to that point. Otherwise, you're
No,
learning. You're limiting yourself. To be honest, if you don't, this is a direct target. This is a direct comment for that Tesla theory or the Tesla comments. That's why he failed at a lot of his latter part of his career. He didn't care what everybody else was doing. He tried whatever he wanted to do, however he wanted to do it, and it didn't work because he didn't understand the physics that was evolved to the point where he needed to know that. He didn't know the limitation of the square root of the square root of the distance in your denominator when you're talking about a propagating wave. He didn't study it. He didn't bother even trying to figure. He didn't believe in electromagnetic waves. He was longitudinal waves. That was his mindset. That's how you send energy. That's how you send information. He did not care about Hertzian waves. He didn't care because he refused to study it. And that limited his success in the latter part of his career. That is a fundamental fact.
But what harm did he do by experimenting? He didn't do any harm. So he was experimenting and trying it himself. And if some of the experiments he didn't work, nobody got hurt. There was no harm. He learned.
But you do have people on this internet claiming how much of a genius that man was and how much his information was suppressed. And the Warcliffe Tower didn't work because of some company shutting it down. It didn't work because of the physics. He didn't understand the physics. That's why it didn't work. It has nothing to do with some company saying, I don't want this out because I don't want people to get free energy. That's where the conspiracy comes in, because that is a lack of information that's plugged in and saying this is why it was shut down. No, he just didn't know physics. That was it.
Well, I would disagree with that, but we can agree to disagree on it.
Someone is asking that there's a guy called Trent Balding. asking that the sound left, do you have a college degree? But you already answered. You said that you graduated with a degree. You said in agriculture.
Yeah, okay, let me, this is what I've realized. One of the fundamental breakthroughs that has happened through the genesis of this world, in
Yeah.
most cases, it has been by people who are not so much into that field. For example, if we look at the first plane to be flight, it was by the Wright brothers. They were not engineers taught from the field of engineering, but they self-taught them. Now, I myself, I was a land manager, but I saw this and I knew in my heart, with all everything, I knew it was possible. So I had to quit that, start teaching myself some things, and up to the point where I am. So if I was to go through the elementary engineering schools about electricity, what I believe I would have also failed, because I would have been taught in this that this is impossible. So at times there is a way education can open us into good opportunities, but at times when you face limitation, if we are told that this thing is impossible, that thing will remain in our heads, and there are possibilities that we shall not look into it. So that's why I
No,
like.
no, no. Alan said he'll try things that people tell him that it doesn't work. So no, that I wouldn't agree with that, because Alan's proof that no, that motivated him. That motivated him to go try something else. Go, let me see.
Yeah, that's why I completely agree with my brother in the right in the middle. Is it Mr. Alan?
Alan,
Alan,
yeah.
Yes. That is the perfect way to go. Not to go by what the books tell us, not to go by what the experts tell us, but you try to prove it yourself.
can I just add another quick story because I think it's very important, and ID does have a point, and I do, agree to a certain extent. But now today there's a YouTuber on YouTube called Matt Armstrong, and he's a car guy. Okay, he's a guy that worked as himself. He was fixing cars on the driveway of the restaurant where he worked, and over the last 6 years, his YouTube has gone up. He's got about 7 million followers, and his last video, there was 5.9 million views on his last video. And I'll tell you what happened very quickly. Matt Armstrong bought a Bugatti. So what he does, he buys crash damaged supercars and he fixes them, right? Now, yeah. Matt Armstrong is not a trained mechanic. He didn't go to mechanic school, right? But yeah, the guy is a multimillionaire. He builds all these supercars. He fixes them and he builds them. And the car that he had in America, one of these famous YouTubers flew him over to America because he also had bought a Bugatti. And the CEO of Bugatti said, you have to split the Bugatti in half to fix it, right? And the CEO said, there's only 3 places in the world that can do that. And Matt Armstrong said, you know what? We're going to give it a go and see how we get on, right? And he has all this on his channel on YouTube. You can watch him do it. And they split Bugatti and they put it back together, and they got it working, and they got it driving and everything else. And the CEO of Bugatti has egg on his face, because he said it can't be done. There's only 3 places in the world that can do it. And Matt Armstrong was only in a standard car mechanic's garage, and Matt Armstrong is untrained. He's not a qualified mechanic. He doesn't have a piece of paper to say, I went to mechanic school.
What's his experience?
Right. His experience is real life experience, taking cars apart and learning and working.
There you go.
Cars, right. That's how
the context, though, Alan. That's the context. He's learned.
Yeah, but
I didn't say you had to go to school for information. I didn't say that. I'm not saying that's the only place for information, but he was in the field already. That was what he did. That was his thing. So you can't remove him from saying he's unlearned. He is learned.
But here's the thing, right? He didn't. I mean, there's certain nuances that you'd learn in school that you probably wouldn't learn in the garage. But the fact that the CEO of Bugatti has said you can't fix that. Now, Matt could have turned around and said, okay, the CEO of Bugatti said you can't do it, so we won't do it. But he didn't say that. He said, we're going to give it a go anyway. Even though we're told that you can't do it, we're going to give it a go. And he managed to do it. So
He,
But I think,
you
but he's
can't.
he's
I think,
not he's not working in the supermarket trying that, right? If that's his background, if that's what he does, he deals with cars, he fixes cars, he builds up cars, he rebuilds engines, whatever it is that he does, he's in the space. That could be parallel to a Tesla. He may not go to school for it, fine. But if he's in the space, learning the space, studying the space, and then building on what's there, that's a learned individual. Yes, I would say that's his background. Just because doesn't have a piece of paper, I don't care. He's a learned man.
No, I totally agree. And he is a learned man. He spent years, learning and building these cars. But the fact that somebody like the CEO from Bugatti, who would come in and obviously with the arrogance thinking that he was the CEO and that he knows everything and knows more than Matt does. And he said, you can only, build this car and do it. He split the car in 3 places in the world. And Matt said,
Alan,
I'm just going to go do it anyway.
Alan.
Yeah.
Although I'm seeing that for math, I also follow Matt Armstrong, and I did to watch him. Some time back, I told him that there's this guy who is doing this stuff, Bugatti and this stuff. There's a day, I think, I don't know if I do remember, but basically, for Matt Armstrong, his father was like a trained mechanic, yeah.
His father
And
was a trained mechanic, yeah.
yeah. So he has grown around him as well. So I don't think like for him you can say that he started from like zero. I'm sure if your father is a
Correct.
mechanic, sometimes he will send you to bring that that sort of maybe spanner for him. He will tell you that maybe if you have to do this, you have to do this. But I know that he learned a lot also on his own from working on the cars. He got a lot of experience from it.
Yeah,
And
totally. Because his father never worked on supercars. He says that himself. I've never worked on these supercars. So his father was learning as much as Matt was learning with the two of them working on supercars. But yeah, I mean, it did help that his dad was a mechanic and probably taught him a few things. But his training from his dad when you went to a certain level, because his dad said, I'd never worked on these cars before. So he put the time in and learned, and he had these, I mean, if you watch it, Chris, watch Matt Armstrong, the amount of times he has failed to fix a car until eventually he works out what the problem is, and that's just keep on trying, give it a go and see how you get on. And that's kind of my approach, is that I'm not an electronics engineer, but I'll keep giving it a go. I'll give it a go and have a bit of fun with it and try different things. And maybe one day something will happen.
I think you're a little different, Alan, though. I think you're a little different because you are trying things that are not necessarily in a space that you've spent 30 years on. You're dabbling in other spaces that seems interesting. No knock on it. There's nothing wrong with that. But if you're talking about somebody like Matt Armstrong, if that's been his childhood growing up, that was his environment. That to me that goes beyond textbook. That's practical experience, and then building upon what you learned from your father, whatever else, wherever he carried it, it started and rooted in his understanding of cars. So if you ask him to write a security code for some IT company that needs it by tomorrow to do all these different features, what are the chances of him doing it? He can't just. That's why I said that's what I mean by staying in the lane. I'm not saying stay in your lane because it's restricted from everyone else. Practice what you want, but he has the level of experience and expertise. He can do those things because of the time he put in, because of the experiences he's gained over the years, many failures. I mean, you said it yourself. He had many failures. That comes along with the building of understanding, and I can parallel that with there are sciences that have already done some of this stuff, and it's not pitching indoctrination. I would love for it to be more of a cohesive. I could be at a certain level, you could be at a certain level, but we can still have the conversation. I don't want the separation. I want to know things that I've never seen, right? Now, if you find out something I've never seen, I'm interested. I'm listening. My mouth is shut and you talk, you got the floor. If Lamb says he's doing what he said he's doing, Lamb, I'm listening. If you want to show anything to say, hey, I did it, I would love to see it. Now, if you don't want to show it because of proprietary stuff, that's fine too. But that's a huge claim you made earlier about not needing energy to create energy. That is a wild one. I've never heard that one. So that's a new one on me. You're on mute. You're on mute, sir.
I think you guys can hear me, right?
Yeah.
Yeah. Let me try to send. There is one video. Let me first check and then try to send to Mister so that you try to play it. Because actually, you can even see when the area is put, it is off. When it is on, that's when it's working. Actually, by then I was just using this 100, the other old traditional bulbs of 100 watts. You get it?
Yeah, share to me on WhatsApp.
So let me just put for you on WhatsApp now so that you try to see.
Okay.
Yeah, I think Chris will play if you have a link.
Yeah. If it's going to share on WhatsApp, I'll see it and I'll download and play it right away. Let me wait and see.
Respectfully, Alan, I definitely like. I don't want to have any contention between everybody on the panel. I am not taking shots at you personally. If anything I'm saying is insulting, please let me know, because the intention of that is not to be insulting.
That's what I totally understand. And again, respect for everybody in their fields. The point I was just going to make with the Armstrong thing is that the fact that the CEO of Bugatti said it can't be done, and he went off and said, I'm going to give it a go anyway and give it a try. And obviously he didn't know whether it could be done, but he said he'd give it a go anyway. For me, as I say, I've a limited knowledge in the electronic side, but I'll still give it a go. And if it fails, hey, I've learned something. I've learned another way how not to do it. I'll do the Thomas Edison approach.
Why not learn from someone who's tried it though?
In terms of Matt Armstrong, for me, I'll say that you see, for him, he's trying to fix a problem that you know that it is solvable. Yeah? Like you're trying to fix this sort of car that you know these guys can be able to do it, but they're telling you that you can't be able to do it because you don't have the right equipment. I think it's sort of different than now, say, like what Lam is trying to do now, where like a lot of people have tried to do the same thing, where you can be able to get energy from radio frequencies, and they're getting millivolts or milli something, like you're not getting enough of energy to use from it. So like there's a lot of people even who have done documents about the same stuff. I see you shared the video, so let me download it and I play. But I think there's sort of different, because for Matt Armstrong, like despite learning on his own things to do with mechanics and repairing vehicles, like you already know that these are things that people can be able to do, other people can be able to do. So I can as well learn this and be able to do it. But if it's something that now the physics says that it is impossible, I think it becomes a big problem.
Yeah. A CEO saying that it won't work is not the same thing as science saying it won't work.
So
I would bet the CEO hasn't been in a garage in years. Probably.
Basically, the CEO is saying like you cannot be able to do it from where you are because you don't have like the right equipment. Like for them, they want to bring it to their workshop. Then from their factory workshop is where they have this sort of equipment that can be able to pull the vehicle apart. You have to pull the vehicle apart in the middle. But now Matt was able to do it. Like he just used basic stuff. I think I'll share that link of that video. You watch it. It was somehow interesting. Trent Lam is back. You were sharing a video that I want to play. I'm going to get it, but your stuff is replaying me, although.
I'm replaying you.
I'll be listening, but I gotta get off for about 5 minutes. I'll be back.
Okay.
I have the video here. Sure. So basically, what is the video about before I play it, or I just play it?
Actually, I was just trying to test just the radio without any cell, without anything connected. On one hand, the other old 100 watts bulbs. If you guys remember, the ones that consume a lot.
Yeah.
Yeah. So that one I was just trying. You see, when the area is connected, immediately insert it, it works. Immediately take it off, it goes off. No any other external electricity, no power.
Okay, let me play.
Yeah.
Oh, so
Yeah, you play.
this is your setup, yeah?
Yeah, that's my setup.
What you showed us earlier on, I think it's the same that you showed us earlier on the video.
Yeah, it's the same, but now the other one I'd modified it, like I was using a lot of more equipment than this. This one I was just doing it with only one bulb.
Okay.
Yeah.
Yeah, take off.
I think you see.
But now you see, you have to show us where these wires are coming from. Like, where is this wire going? Where is this wire going?
Okay, let me just explain where the wires are coming from.
Yeah.
These blue wires are coming from the transformer. So this board here is where the radio frequencies are put, and then it is transformed into electricity. Then the transformer will harness it and puts it into 220 volts. So the bulbs, you see the other socket, the other side. What I did, the transformer is connected to the other socket, so that instead of us connecting the bulb to the transformer, we connect it to the socket. And if you remember the other video I sent you, everything was from the other socket, because I just didn't want it, like, in case those wires were to knock at each other, everything would blow off. So that's why I had to put a socket where the output is. So this other wire that I'm holding with this friend of mine, that is the one that is connected to the what? That is the area. It was actually at the door, so you can play it and see.
Yeah, you know. Yeah, this is free energy.
It is getting to the end, but this one makes me to have like a lot of questions. Like, I want to know where these wires are. I know you've a few.
Actually, that's why what I will do tomorrow, I'll just have to make one where you are able to see that there is nothing, because I just did that for my own, but not even like, maybe I don't think of sharing it to anyone or whatsoever. That's why the wires are scattered all over, and someone may think either maybe I'm looking at electricity from here or, but nothing.
Like, if you can just clear the whole table and just place your this setup, the only thing on the table to be. Let me see here. Let me pause here and see. Because usually these things, people say that there are some hidden wires that you're not able to see.
Yeah, that's why I'll just make one tomorrow. But all those wires are just from within the table, nothing from electricity.
What do you think? He's saying that it is coming from the area, then you're taking it through from your component, you take it to the transformer, then transformer to the power supply.
To the output.
The output. Now you bring it back to. Now the output is the one which is lighting up the bulb.
Yeah, the output, the other socket, the other side would have been the output, because it's where I can put either a percolator or bulb or whatever. So that's why I put a bulb there.
Alan, what do you think?
Well, I'm just looking at the circuit board, and you obviously touching the. Looks like is that an antenna socket that you're touching? You're poking the coaxial cable into.
Yeah, that's the antenna.
Right, so the antenna, so that's coaxial cable. Is that 50 ohm or 75 ohm coaxial cable?
Pardon?
Is that 50 ohm or 75 ohm coaxial cable?
Asking about the resistance of it.
It's probably, well, if it's TV, it's 75 ohm. So that's 75 ohm coaxial cable. By the look of it, you're putting into an antenna socket, and the antenna socket is taking that signal and transferring it using the board, and then it's wired to. I'm not too sure what that brown box is. What is that brown box that the light bulb is wired to?
The behind box.
You say the transformer. This one.
That's the transformer.
Oh, it's a transformer. Okay, so
yeah, transformer.
So you transforming the DC into AC, and then that's why you're wearing the bulb.
Yeah.
Okay, and you have a socket there, a power socket there. Oh, that's where the bulb is plugged into, is it?
Yeah, that's where the bulb is plugged into, because the transformer takes it to that power socket, and then the socket brings it to the bulb.
Right. Okay. Well, you know, on the surface of what we're seeing, it's very interesting. I mean, somebody's ID wanted to know what antenna there. You said you're using a TV antenna. So TV antenna, analog TV antennas, as I said, are between 100 megahertz and 500 megahertz, UHF, VHF.
Yeah.
Trend is saying that there's a battery.
Pardon?
Oh, Trend is saying that there's a battery.
Where is the battery?
Now that blue thing on the board looks like a relay.
I
If you
told you
do,
that with the MOSFETs alone, you can't do it.
okay, so Chris, if you can show us the board. So the blue thing on the circuit board looks like it's a relay. Obviously, you have capacitors on there, and you have a transistor or a MOSFET that's there, a heat sink with probably a MOSFET attached to that as well.
Then ID is asking, is the bulb AC or DC? I think the most where are your MOSFETs are within the, like, your MOSFET. I don't see MOSFETs on. Do you have MOSFETs on your circuit board? And can you demonstrate this to us? Like, just this one, you can just demonstrate it on the live. Can you be able to do it?
Demonstrating the power right now.
Yeah.
No, right now, where I am, the area does not trap the kind of waves I want. It's too much, so I feared it will burn the circuit. So that's why tomorrow I have to either turn the area very well with the meter, and the meter is also left. I left it at the workshop. Then I take the video complete when you see everything without anything right from the area and then to the circuit, my circuit board, and then to the output, and then I put anything. Even though you can tell me whether you want a bulb, iron, or anything to cook, actually percolator, everything you want, I can do it.
But I thought you said you said what you're getting from the area is like just a small amount. Is when you go and now you try to like power it up a little bit.
Yeah, that is true. And this is one thing I realized with this.
So how will you destroy your circuit board right now?
How do I? Yes.
If what you're getting from the area,
yeah,
it's not that, like, just millivolts or small amount of energy. Before you take it through your circuit, and then you power it up, or you step it up. Then once you step it up is when now is way more, like, you can be able to use it to do way more stuff. So how will it be to, like, destroy your circuit at the moment if what you're getting from it is just limited? Like,
okay, this is it. Based on how I've organized this circuit board, it has a specific frequency that it works with. It's not every frequency. So if it comes when it is too much,
it
like, let me say when those waves are too much, the frequencies, it can destroy the circuit board, because I've tried it. And if it is very low, it does not work. So that's why I'm looking at taking it out of the area in order to give it its own specific frequencies where they don't need an interference with the outside. You've got
that DC AC converter, Lam. Could you not use a small AC DC converter rather than something that big?
Yeah, it is. Now I use that big because I was trying to power things that are too much heavy, like cookers, flat irons, those heavy appliances. Because what I wanted, that's why I used something bigger. But if it was something small like a TV, that one would be very easy. Actually, with a TV, I wouldn't even need that. I wouldn't need any, how do I call it, transformer. I can just loop it through this, and the TV is able to work 24/7 without anything.
And how long, when you plug it in, how long could you keep that light bulb lit? Will it just stay on indefinitely, or how long will it last?
Now, the first time it actually, it's not about. Okay, I didn't only do it with the light, with the bulb, because what I was looking at is how power consumption. So the first time the thing would light for even up to 2 hours, but what I would realize, the circuit board would afterwards blow off. That was the major problem I got. But the power would continue coming, not until the components blow off. Because once you tune it to a specific frequency, that it needs, you can use it as long as you want. So that's
So
why
could
I had
you,
to.
What is the frequency?
Yeah. Now,
What is the frequency?
and what we're using just a meter to check it before we plug it in. If it is that, and then we do it. We are just using these local meters.
You said
What
when
does the meter say?
Now,
wait.
in this video, in this video, it's not shown. It's not there. I didn't take it because this one I didn't take it because I wanted to show it to anyone, or I just did for my own.
Liam, you said
Yes.
that when which frequency were you using?
And now for my meter, I would use the one of 12 or 16. Now, if you did go higher than that at 30, because now where I am, it goes up to 32. It would destroy. And sometimes if I change to a
32
certain,
what?
like we're measuring it in ohms, because I don't have the real specific meter that shows the real frequency band, which I'm planning to buy it.
So when you say 30 ohms, you're talking about the termination that it needs. I'm asking specifically about the frequency. You said you're using radio frequencies, right?
Yes. Now that's why I told you I don't have yet the meter to specifically, which I'm going to buy so that I'm able to know that this is the real frequency that it works with.
Can I only ask you to do one thing? Look up radio frequencies for televisions, find out what frequency that is, and look up the physics needed to create an antenna to pick up that frequency. Because if you're talking about television frequencies, you need a really large antenna to pick up. Back in the day, they called them rabbit ears when they used to put them on televisions. There was a reason why you needed those, because it had to be a really long antenna to pick up those frequencies. So that's a very specific thing. And based on what I'm seeing, I don't see an antenna.
Now, the problem is, okay, let me just disconnect maybe my antenna outside so that I can show you the antenna that I use. Or let me just go with a torch and then I try to show you the exact antenna that I use.
I can help you. Well, I can explain that ID. The rabbit antennas, frequencies are based on wavelengths, and if you look at say a CB radio, for a CB radio wavelength for 27 megahertz, you're looking at about 8 foot by 6 inches, 8 foot 6 inches for that wavelength for that frequency. The fact he's using rabbit's ears for TV, normally if it's analog, it's VHF, UHF. It's normally between 100 megahertz and 500 megahertz.
I don't know. Are you able to see the antenna that I use? These local old antennas.
Yeah. So the rabbit ears, the old classic analog rabbit ears, would be UHF, VHF.
You see, yeah.
That's just a frequency band. That's all.
Yeah. It's not anything special. And it's just the way.
So how are you converting that? So you're telling me that board converts that radio frequency into AC or DC?
It converts it into AC. Because our radio frequency, electricity radio frequency is AC. So then after it has been converted into AC, we try to power it up like increasing its voltage. But since we want voltage to be very, how do I call it? The voltage to be at what we want, 220. So that's why we have to pass it through the transformer.
Yeah, I'm a bit confused on how he's using transformers in that board. I don't know. It doesn't make sense to me, but that's just me.
Liam, why does it spark at this moment? If it sparks, doesn't it mean what you're bringing in is a lot of you can see it spark here.
Yeah, that's why I told you. It sparks there because by then.
And what is that red? There is a red cable that is holding that.
Yes. Now that red. You remember the antenna has two wires. You have the ground and then the one that would have been the live. So that one, that white one is what would have been the wave, and the live, and then the ground we had to tie it there.
So if what you're getting from the radio, if what you're getting from the aerial is just like milli something, not that big. Now you have to put through your circuit before you amplify it, and to get something big. Like now you step it up before you use it. So if it's just in small amounts, like milli something, how comes it is able to create that spark? Like,
Is that static? Is that a static spark? I wonder.
I think that's how they explain that. I can't explain it much, but it doesn't have any external source.
just uh,
Because even like when you touch that board, it is able to choke you. That is another thing. But doesn't have any external power need. So that's why it is 100% efficient.
I think he shorted to ground.
Yeah, yeah. Now there it shot. Actually, that one shot to ground because afterward, I remember after when I again tried putting in something, the whole most of the components had blown because when we were trying to put because it was you also see it is a local thing, so it shot in the ground and that's when the
I would not believe that radio frequencies can cause that sort of arc.
yeah, exactly. That's what I'm not saying, man. There's no way. Because like you have to pass it through your system, or there's another system that it went through.
I've
You're
not got you.
you're saying that these cables are coming from the solar from the area.
Yes.
So it's coming from the area before you feed in through your circuit, and now you do it the thing that you're doing to it to step it up. Now this is before you step it up. So before you step it up, you say that it can be able to generate like this sort of sparks, man. This way. Ah, man, I'm still doubting you, but yeah, I think you maybe you
Now, now this is it. Uh,
I wish you
okay,
could
let me
have
check.
shown us maybe like now, but you're saying that it
Okay.
because of the area. So it means like it works with different areas. I think we're losing you a bit. What?
Are you getting me now?
Yeah, yeah.
Yeah, yeah.
Yeah. Okay, let me first check if there is another video that I made because I remember there is a video I made that was coming right from the area through those components and then the output.
Okay.
I
Let
don't
me
know,
check it.
Chris. I don't know, Chris.
Yeah, this spark is like this has to be like there's no way this is from millivolts, man. Millivolts can't do that. Alan even but yeah, let's wait. Like this spark it must be like this must be a lot of volts. Even when you do like just a battery, yeah? Alan, if you have a car battery, and you when it runs low, then you connect, you try to like to short it, connecting negative to positive. It's if it's very low, you won't see any spark. But if it's fully charged is when you see like a very massive spark like this. So there's no way that something just coming from the area can be able to like do such a spark. This is before he takes it through his setup, which he says that it can be able to like step up what is getting from the radio frequencies.
Well, I'm trying to think. I mean, because of my background, I'm a licensed amateur radio operator, and so I'm trying to think in my field of amateur radio, instance of where you get maybe static electricity. I mean, we obviously we know that if you don't put a lightning arrestor on an antenna, and it gets hit by a bolt of lightning, that will come down the antenna in the cable and could blow the back of your radio. But would you see a spark or a bang? I mean, I've had a Wi-Fi router be blown out by a storm. It came down the cable and blew out the Wi-Fi router. So the static electricity or the surge of power can definitely damage equipment. That goes without saying. But would you see a spark if it
But
did?
there's no like a storm or anything. You can see behind him there's the sun. Usually here in Africa, if you have the sun, it means there's you won't have anything to do with thunderstorm.
Yeah.
So it won't be static.
And
But
a storm will create an enormous amount of energy for a lightning strike or anything, like a brownout as we call them.
Yeah.
Like that takes an enormous amount of energy.
Mm.
So, in order to get that kind of spark, and I'm speaking just from my circuit design experience, one of two things: either you have a capacitor with a charge in it and you just discharged it, or you have a battery that you just shorted the two contacts and it sparked because you shorted ground to power, the plus to the minus. Otherwise, I mean, you can do it with an inductor too if there's actually energy in the coil, but that usually dissipates. So again, where's that energy coming from?
Now,
The antenna? There's no way you're getting that kind of energy coming from an antenna on a roof or that antenna that he's using. That's a lot of
now,
energy to create that spark.
now this is it.
I have to
tried to.
agree with ID on that. You know, that's a lot of energy coming from an antenna, Lam.
Now this is it.
Haven't taken
I think tomorrow.
circuit
Yes.
yet. And you haven't taken that energy through your circuit yet, because you're supposed to take it through your circuit, then the transformer, before now you get what can be able to run like a TV or do other things, other things.
Now this is it. Usually those they are called diodes, or those black things. For them, they have the ability to keep power. So in case of anything, they can always bring that feedback. But another thing, when we're putting in that area, like you can sit there and have the other it's called, is it area tune or something like that, that you can fix it into in order for it to not to create those sparks. So that can also, now the video that I was trying to look at, I didn't power it, like I did put it to power out. So even when I show you, may think like maybe but how come it is now not powering and stuff like that. So that's why what I can do, I'll just make one video tomorrow clear, then I can send it to you, because even this other one, it is exposing almost every part of it.
Did you build this board?
Yeah, I just built it myself.
So you have the schematic for this?
Yeah.
So this board converts RF frequency to DC?
RF, not to DC, because RF is already AC. So it has to just harmonize it, amplify everything. Then we have to take it to the amplifier, to the transformer to stabilize it.
Oh, you have an amplifier on the board.
Okay, let me say the because this is another thing I realized. There is a lot of things that actually people have not yet just understood about electricity, even about the workings of most of these components. Where, for example, you can say a resistor is used for cutting this and this, but I realize not just that. There are some resistors that do way much more than just reducing power or reducing voltage. It's what I realized on these things. So
what else do resistors do?
Yeah.
What else do resistors do?
Because I realized that even there are some places, because for example, you can still use like 3-4 resistors. But if you take out one, or you try to bring another kind of resistor that has the same value, or that would have done the same work with that one, it won't work there. It needs that specific one.
Usually you're only power matching them. They're not really special parts. They're resistors.
Power matching,
well, you can use them as a circuit design, as a voltage divider. You can use them to limit the current in your circuit, in a series circuit. You can use them in parallel to lower the total resistance of the resistors. You can do different things with them, but they're just resistors. They're not really special.
But this is what I realized. It goes way beyond that. It's not just because there are other places, for example, you would try to use another form of resistor that could do the same thing but won't work. It needs the other specific one. So that's why in building this electricity, I realized there is a lot more about electricity that is not yet known.
You only have through-hole resistors, I see.
I have what?
Through-hole resistors, those large resistors with the colorful bands. That's the only resistor I see on the board. I see integrated circuits. I see capacitors. I see a relay. I see heat sink. I see your resistors, and you have different types of capacitors. I see, but your resistors, you don't use anything different than just your typical colorful band resistors.
Yeah, exactly.
I wish you could have shown us, man. You say that you say that why can't you be able to show us on the video right now?
Hey, Chris. Hey, Chris. I'm sorry. It just hit me. What's throwing me right now is he has a power supply on the ground and on the right side of that screen. I see a power strip.
Yeah, there is a power supply there. True.
Maybe you have something
No,
here.
you listen. Okay, you talk. I done.
Okay, go on.
Now that power supply, it was not. We didn't put it. It's not anything that it's not bringing either power here or anything. No, it was unplugged. That's why what I'm saying is this. Wait, I do a video tomorrow with a clear table, aerial up, everything, so that you can see yourself whether I'm a scammer or.
What's about now?
Right now, it's already coming to midnight, my brother, and I left the meters. Yeah.
You say that why can't you do it now?
Right now, I've left the meters. It's at the workshop. It is some kilometers away. It's already coming to midnight.
Is that what you said? Is that what you said a few? Is that what you said a few minutes ago?
No, I no, you listen to me. Listen to me, Mister.
Reason to this one.
Pardon?
A few minutes ago, I did ask you like if you can be able to do it now on the live, and the reason you gave is different from the reason you've given now.
Uh-oh.
Now let me tell you this.
Yeah.
So I told you that it needs a specific frequency, right? But of which I measure it with a meter, right? Now the meter, I think actually even when we had just started, I told you that I left it in the workshop. I don't know whether you remember it. However, I also told you that radio frequency, what I realized, it's not the same in every area. There are places with the higher which can damage the circuit board, and there are places with the lower. And that's why what I'm looking at is after matching and knowing that this is the specific band I need, I try to build for it its own specific radio frequency so that we take it out of the area.
So you've never done it. You've never done it from your home that you're staying right now. Like
So the last time I came, since I stay in a story building high, so I realized that the frequencies were a bit higher. It would destroy side live. So I have been doing it at my workshop.
So Alan, I'm pretty sure you can back me on this one. When radio signals are received specifically for televisions, they are eventually amplified because they're so low energy.
Yeah.
They have to be amplified, right? So you have to have a circuit ready to receive that really low signal, and then you use some energy on your board to amplify it. How can frequencies in different areas blow your circuit up? This energy is extremely low. I don't even know where that statement came from. That it could damage your circuit. A radio frequency can damage your circuit.
This is it, Mister.
I mean, in amateur radio, we have things called preamps, and preamps are amplifiers to pull in weak signals. And a TV would probably have that kind of technology built in, a preamp to boost the signal. But as to how would a frequency or a signal that's coming into a board below, the only reason I didn't think, and I'm thinking outside the box here because I'm not an electronics engineer, but the only thing I can think about is that it's not the frequency that's causing the problem. It's the conversion from the energy that's coming in to wherever it's going into. That is probably where the trouble is and causing the problem, not the frequency itself. Maybe it's the amplification or the switch or the change or whatever is taking place is where the cause is when the energy gets amplified. Maybe that's where the problem is.
So, but yes, where the sparks are coming out at, like he hasn't transformed it yet. Still.
Now this is it, sir.
Trent, why will you not power your home with this? Like, if this thing works the way you're showing us, like, why are you using the government
electricity? Yeah. Now this is it. My core plan is to power out my house, but that is why I told you at first that I'm looking at a way of taking it out of the area so that I come and disconnect to the EDCL power and I plug it mine. And also actually start making incubators that are powered by frequencies. because that's the main role I do in Uganda. And actually, it's what pushed me into this, because when I realized that incubators were taking a lot of power, my other thing would be, what is the solution for this? And I had to look into electricity. How do I generate mine? You get?
Let me replay this pack. I don't know. There's this comment from.
I think probably what we need is Lam, if you could do a cleaner video on a table, without everything else around it, just to kind of show us what's happening. You're holding on to a blue cable there, or some kind of cable in your right hand. What is that cable that you're holding on to?
The one on my blue hand. If I try to play that video, because I took this video some time back. If I try to replay it.
Now your audio has gone funny again.
Okay, I now get it. Are you getting now?
Okay, yeah.
Yeah, you play the video.
So tell us what that cable is in your right hand.
Because I took this video I think a month back, so I don't remember these other. So you first try to play the video. First try to play the video, then I can remember.
There's a moment Trent said that you said that this video is not yours. Is there a moment that you said?
No. I didn't say that.
You said you took it, but for me, when I took somewhere, I will remember. But it's okay. I think let me play.
So you don't know what that cable is in your right hand, or in
let him play the video.
I think he was the one filming. You were the one filming.
I was the one filming, so we were doing it with my friend. So you play the video. I can try to recall.
I'm playing it.
Yeah.
There's a wire that the guy is holding. Two cables actually connected. And they're coming from, I think they're going to the meter.
Because there was that was the one going to the meter. The meter that was because it was going to the meter the other side. Because as I told you, you had to first check and see the things coming in. Yeah, that is going to the meter. There were two. One is blue, then one is brown.
You can see here.
I think you can see it.
It's not really visible, but it is somewhere here.
I'm happy to say I'm confused. I'm not understanding what's going on there. I think
he said that he was going to share another video. I opened WhatsApp, but I haven't seen it. He said that
this one actually I opened the WhatsApp, but wasn't. I had not turned them on. I was not powering anything with it. So even when I share it, it will not still make any sense. So that's why I can take
You can just share. Maybe it will help explain a little bit or give more.
It was because I was trying to cover every component on it, so that's why I will have to make another one tomorrow.
ID, what do you think is going on there on the board? I mean, I'm seeing relay, I'm seeing capacitors, I'm seeing a chip that looks like an LM356 or maybe a 555 timer, and resistors, obviously, and some kind of MOSFET or a transistor there.
Yeah, that's the reason why I asked earlier. Do you have a schematic for this? Like, how did you build this circuit? Because you can't really tell from the top that how he wired it underneath. That's kind of, you would have to see the bottom, or if he had a schematic, it'd be a lot easier.
Now, that's why. Now, if I'm to give you the schematics, like I'll give you the entire blueprint of everything. But
that's
now,
fine.
what I have to do,
if you don't want to share it, that's fine. But that's the only way that, like, there's no way anybody can just look at the board and know exactly what it's doing. I mean, I can identify components similar to Alan, but it doesn't really tell me anything unless I can see the bottom, how things are wired up, what's connected to what. But
Alan is, I know. For me, I believe this power is coming from somewhere else. I know you say that it is stuck. No,
I'm not convinced, Chris. I am not convinced on this one.
I'm gonna post it at the right moment. Do you believe
because now this is it. In almost all the videos, because even though there is one that I made, that it was boiling water. The one that was using a 9-volt cell.
Yeah.
Almost all of them. Once when you are putting, should it touch the ground, it sparks. That is an area without anything, but touching it on the ground, it sparks.
I don't know what that means, but so help me understand. Your antenna's coming in through that wherever that spark is. It's coming
Yeah.
into this board. That board is then tied to the transformer, and then the transformer is tied to the bulb.
Yeah, that is okay. The area comes, then it goes into the board. So the board then goes to the transformer, and then the transformer is and then outputs the power to the other
And what is
socket.
the transformer doing?
Now we had to convert it to 220 volts to stabilize it very well, because some of these components, when you're using them, that's when you realize that they actually have much more use than actually what we have been taught or what we knew from school elementary.
You're getting 220 volts from an antenna on a roof?
Yeah. Okay, it comes in millivolts.
I think it's 240. In fact, in your country it's 240, right? In our country, in East Africa, it's 240.
Well, even 240. If you have 24 millivolts and you go to 240, that's like to the 5th power. Like, that's a huge jump. How do you make that jump?
Now, I think I have a video where I was measuring the voltage. Let me check on it. Then I send you where the meter was telling me the voltage that was coming out.
Yeah, we need measurements. It's hard to really figure this out.
But now it was coming after it had gone through the transformer. That's when it was bringing for us the voltage 220 was it 220 239 volts around there. So let me look for it and share it, and you see
220 AC.
Yeah, AC from the antenna.
And you see this spark is not coming from the 220 that he's saying about. This is before.
No, that spark is coming before, but once it touches the ground, it has to spark. Based on how I've made that circuit diagram.
Spark from what? It does. Where's that energy coming from?
Well, look, if it's sparking, it's not really a good sign anyway. I mean, that's something you're gonna need to rectify, because
it's something bad. That's why I told you it's because I didn't use something that's professional, so it had to touch the ground and sparked. And actually, afterwards, that circuit board got spoiled. I had to change most of the things, the components from it, to rebuild it afresh, because that sparking is not something good.
This looks big. That spark looks much larger than static electricity.
Yeah, it's and be quite dangerous. So, you definitely need to work out why that is happening and sort that out.
Yeah, let me check. Let me check if the one that was showing us the voltage there. Let me show it.
Yeah, you do, and come back. Let me read 1 or 2 comments. I see there's Cecil is here by the ID. I know ID and Cecil usually they have a thing going on. And
no, he hates me because Lloyd is a fraud.
Cecil hates you and says that you work for the he said that you're giving me disinformation, so we should not ask you anything. But Cecil, thanks a lot for coming around. Today I thought you're not gonna show up. But even Trent is asking a lot of questions here as well. For me, I also have these questions that Trent is asking. Like, so one of his questions is why aren't you powering your home with it at the moment? He says, so is this all custom, or did you get it out of a machine? I think he said that it was custom, like he made it.
Yeah, he said it was custom. He made it. Yeah.
What are the LEDs for?
Who is asking that question?
Me. On that board, there's a yellow and it looks like a purple something in the middle of the screen. Those are LEDs. Am I correct?
Well, maybe the LED is there just to signify that there is power going to it. And when he pulls it out, I mean, if you play the video before he touches the coax to the unit, is that LED on? And does it go off when he disconnects it and then goes on when he connects it?
Yep, that's another way of asking what I just asked. Yeah, that's what I really want to know.
Yeah.
This before he connects, is it you see?
Yeah. And then if you play it forward when he plugs it in, does that light up?
I don't think that it does.
No, I don't think it's lighting up.
I don't think so either. That's why I was asking, what is it doing?
I don't know. Actually, if you look at that, it's just a very small. It lights up a little bit. If you look
is that
at
from the bulb?
It could be from the bulb, or it
I
could
think
be lighting up a
just
little bit.
reflection from the bulb.
Well, just it seems to light up a little bit.
It's like it lights up somewhere here. Somewhere here, I think.
Yeah.
Although,
yeah, it's not making sense. I'm sorry.
But the thing with this thing is, someone cannot just go live like right now and maybe show you like how they're doing it. I know he's saying that it's because the frequency that he's getting from the error right now, it could destroy his setup.
But I would have to ignore that I know fundamentally, like the energy that he's talking about from RF frequencies, it's extremely low. It will not create that spark. That's a large spark. I just don't. I would have to ignore that to continue. So that's why I'm saying it's not making sense to me. I'm not saying it doesn't work. I'm saying it just doesn't. I don't get it. But it could work. I don't know.
Yeah, I think we need to see another video of it on a table away from everything else and showing.
Don't forget the ground and the earth is the biggest battery. But he's not getting anything from the ground. Although I see his back. Have you shared? I see his back.
The one that I remember, I took the voltage after the components had blown, so it was just 0.01 volts. It had blown, so that one that I've shared is the one that I was now using it with a flat iron, with a light bulb, with other like a lot of components, a lot of things on it, and was able to work with a flat iron perfectly well within seconds. Actually, it even blew it up because the power was too much for the flat iron.
See, when you say those things, I have to ask, what are the power levels?
It's a lot of power. I think it's over 5 kilowatts of power.
5 kilowatts from the antenna?
Yeah, you let him play for you, and also you see the gadgets that I was working or that I was trying to use it on.
5 kilowatts?
It can even go more than that.
Yeah, you would have to show that. That's a claim.
now that is it. I'll maybe speak when it is done, but you can try it. First show it.
Yeah, the only issue this is in his language, so you won't understand. Let me just
let him play as I talk through it. Yes.
There's some echo thing. Come back on your side.
On my side.
Echo.
Let me see. Is it still there?
Hello. Yeah.
Yes. Hello. Is it still there?
It was. Maybe it's now. Let me play.
Okay.
Then I think once you're done.
Yes.
Let me play the video.
Okay.
Gisemu nga kweri naye pasa weri simanyi soko jemu bali haya kati jwe sawa zino katuli mugezesa balibu yaffe eyakaya tekako paasi nijemu balubu banjirekemu ndoza balubu soko soko gisemu nga kweri naye pasa weri simanyi soko jemu balubu haya kati jwe sawa zino katuli mugezesa balbu yaffe eyaka katulabe oba paasi ya 2 kilowatts egenda kukolerako bulungi. Eyokyeddewo in less than 2 seconds.
So you can see that they've connected the iron box.
Yeah, now the plug. Yes.
That's what you're getting from the radio, from the aerial.
Yeah. Now I think you're going to see it. I think this one I filmed right from the area. So.
Successful test. So amasanyalaze go tugajja mu aerial tewaliwo.
I think you can see our area where it is and the type of area.
It's hard to believe with a power strip in the shot.
Tega kukuba. Katika powering. Pasi eri mu kusiirira sewo. Pasi y'abaana eri mu kusiirira.
You can see the flat iron is steaming hot. Actually, it's burning now.
So, pause it real quick. Hey, yes? Chris. So, one of the things that you're using right now is a soldering iron. Those things are energy hogs. Those things eat up a lot of power to get hot. Especially that iron there. So, you're saying you're getting all of this or just the light bulb from radio frequency?
Now, I was using a flat iron with that light bulb plus then this, how do I call it? This black, this thing that we used on the TV to convert power. But that flat,
the DC block?
Yeah, that is a DC converter, AC/DC converter to output it into 12 volts and stuff like that. Then that specific iron is not, we didn't plug it in, but that one is just 30. That one is just 60 watts. So we were that's why you see it plugged the other side on electricity. The black one, that one is direct on the electricity, but still that one is just a small thing on the flat iron.
So what's running from radio frequency right now?
What is running on the radio frequency is that light bulb, that flat iron, that even got spoiled. Actually, we would even see it coming, smoke coming from it in about 1 minute also. Then this AC/DC converter power thing that we are trying to disconnect to also add it on, and we see if we put as many equipment as possible, will this thing still be able to power up? And it did excellently well, only that now the flat iron was starting to blow off. We had to stop because it didn't have the regulator.
Yeah, I just don't buy getting that much energy to power an iron from radio frequency. That doesn't make sense to me. I'm sorry.
Lam.
Yes.
I don't know. There's some sort of echo coming on your side. I don't know, is it from your... Like yeah.
Is it from my side or your side?
That now it's better. Now it's better.
Okay. So everything there is powered from radio frequency. Nothing. No external power source. Yes.
I know. Trend is saying that this is perplexed, like is confused with it. But I wish you could demonstrate it for us right now. We could have just seen, man, how you doing it. And...
I've told you why it is impossible now, but I'll do for you a video tomorrow.
So I'm gonna take the time right now to applaud Alan for the video he put together where he actually just showed voltage and amps. Like you really don't need to go any more complicated than that. You don't have to wire up irons and light bulbs just measure the voltage and the amps. That's all you have to do. You don't have to hide behind converters. You don't have to hide behind power plugs and questionable wiring to outlets that's sitting on a table. You don't need to do any of that. Just a voltmeter and measurements. That is it.
Right. Unfortunately, I thought I'd done it, but I didn't do the one that I was checking the voltage. Apart from, unless if I'm sure the one that I measured was the one that I was using a 9 volts battery to power out to bring in frequencies in order for it to be able to to cook. That is the one that I remember pretty well. I measured the voltage, and I can show you if you want it. You get?
Yeah.
Yeah.
I think Chris is confused too.
Yeah, I'm reading comments, but yeah, I'm confused too. I still want to know more. I'd seen this video. This is the video he sent to me, and it was view once.
Yes.
And so unfortunately, view once you see it, it disappears. But now you shared it better, so you've seen it. But you said this socket. What is it doing here? This
that is the output part, like from the transformer, then to that socket. It's just the same arrangement like what I'd done last time. Nothing different.
What about the bigger one here, which has like a phone charger and?
No, that one was coming from electricity. We were using it to power only the phone, and then this soldering and nothing else. I think you can see it clear.
Yeah, hey, Chris, in the comments, Trent Balding said, "Why didn't you just use the voltmeter that's at the top of the screen there to measure it? Like that would have been very simple to do."
No, actually, I just didn't record it but we first of all have to record to check the voltage before. But we checked, and I think it was around 239. So that's when we had to power in all these devices to check because voltage and current can be different things. So I think you can see the antenna that I showed you.
239. What is that? The frequency or is that the volts?
No, that is the volts that was coming before we powered on those things.
What is the standard voltage in an outlet where you're from?
Where I am.
Yeah.
I think it's 240.
Yeah, it is 240. So that's why we had to make sure that the power comes around 240, between 220 to 240, to be able to power up our equipment, like the equipment we use at home.
So you got just enough energy from RF to create 240 volts.
Exactly.
Sounds like it's coming from an outlet somewhere.
And it's like this. It's very normal not to believe it. It is very, very normal.
So, and you're saying you're getting he said he was getting 12 hertz.
12.
The frequency was 12, huh?
Yeah. It was okay. Like, I think you can see the meter that we use. When you go back to the other video, you see the kind of meter we use. It's not.
Our power supply is 240, 50 volts. We use the 240 by 50 hertz. We use the British version. So
yes, exactly.
So you're able to push the milliamps to 240, also the frequency to 50.
Yeah, exactly.
Man, it's interesting. Honestly,
how did you do that? You would have to build a circuit that's tuned to that frequency and that bias level. You have to tell me how you did that?
That's why you have the relays there.
A relay alone is not going to give you that.
That's why in most cases we have to retune the area in order for it to give us the exact frequency that we want, in order for it to work. Because should it be higher, it will cause problems. Should it be lower, it will not be able to work.
I would say that so when you're converting analog, and here's my experience. So when you're pulling in radio frequencies, technically it's all analog until you convert it on a board or something. So they use what's called an ADC, which is analog to digital converter, and then you do all your processing, and then you convert it. You can convert it back to an analog signal and send it out to some other transmitter or something. But if you pull in that energy, if you pull in that frequency, the energy is extremely low. So in order to actually come up to 240 volts consistently, you would have to, you would have to convince me that you've created a circuit that can do that from an RF signal. That is not
No,
trivial. That is not
no,
that is not a simple thing to do. So I cannot accept that what I'm looking at is an analog to digital converting, radio frequency to 50 hertz, 240 volts. That is a very specific design for a circuit to do.
now the problem is this.
Look at the bricks that you plug into your laptop. Those bricks are that size for a reason. There's a circuit in there that's doing the AC to DC conversion, and you need a good amount of space on the board to do these type of conversions just from AC to DC. So you're telling me that you have the capability to do this on that board that you showed.
Exactly. Now this is it. Mostly when we
before you go on, Lam, I see Alan had dropped off. I did not realize, but he's back. But also, like, why couldn't you charge like your phone with
with that
with this?
Charging the phone, that is something very, very small, very, very. Now, if I was able to charge the phone, then I wouldn't be able to know whether real. My main thing was much power, not just something to charge a phone, a laptop, a TV. No, those were very low for me. I needed something that is able to cook, because my main thing that I was running this project for was to get enough power to be able to power out an incubator. And an incubator runs on coils. So that's why I had to use flat iron, things that are high power consuming, not just phones.
See, so there's a reason why I said radio frequency. If you had paid attention, if you were not here earlier, he's taking radio waves and converting them into useful power to light a bulb and do all the things he said on the board. So I'm not just talking out of my ass right now. I'm actually in the conversation. So,
Alan, it's asking your message, but it was back then when you wanted to go off.
Yeah, sorry, Chris. Thanks for letting me in there. I'm going to have to make a move, chaps, because I have to do the dad's taxi and pick up my son. So a big thank you, Chris, for having me on the show. Much appreciated. ID and Lam, good having a chat with you there. And Lam, it'd be great to see another video of that with nothing else around, just the board and and the bits and pieces. It'd be great to see that, and then and see it working. But great, enjoyed the chat, guys, as always. And I'm going to, during the week, I'm going to use them new LED lights, and I'm going to wire up that circuit and use the proper MPPT Victron controller, and then I'll do a video and show you it working. And then if it works, I mean, we'll see what power comes out of it, and then I'll show you anyway. I'll show you the amps and I'll show you the voltage, and then you can take it from there. But good night to everybody. Have a great one.
Alan, real quick about your video. The reason why I commented about the increase in the current, when you said you had 6 panels and you were getting 5 volts dropping down, I assume they were all in parallel at that point.
They were all in series, not parallel.
In series. Well, power, it would be more than 5 volts then. 5 volts going across 6 panels. They're only going to get like what, 330 millivolts.
Well, what I did was the panels are 5-volt panels. And they only really give, I mean, it's advertised as 1.1 amp, but they don't give that. They were only giving about 100 milliamps. So what I did was I wired them up in series, and for the power of the panels, 5 volts each. So
no, I'm sorry, not the panels, the LED lights.
Oh, the LED lights were.
They had to have been in parallel.
They were wired in.
It looked like you had 5 volts, 1 amp for each. So if you have 6 in parallel, it'll be 5 volts, 6 amps. That's why it was 6.2-ish amps.
Yeah, I think they were wired in. I'll have to check. I think I just wired them up together, so that would have been in parallel rather than series. Would be in parallel, and so you would have got 5 volts. And obviously the amps, I ramped up the amps, as you've seen on the video, to increase the actual power to the LEDs.
Yes. I did do some numbers in your comments. as
Yeah.
far as efficiency and how much power it took to do that. Now, you might get a different reading if the battery is undercharged. Like
Well,
maybe it'll kick in and start charging, but I wouldn't expect a lot of energy. But you'll probably see more energy than 2% of what you were putting in.
yeah, well, what I need to do is I need to run down the battery to at least 90%, because if it's charged, if it's 100%, the controller won't do anything because it'll overcharge it if it was to do that, and it's designed not to do that. So what I need to do is run down the battery. So when I wire it up and I test it, it actually does send something to the battery, so we can see it, and I can put a little monitor in between so we can see what's happening with that.
Yeah, that'll be a good way to see some level of current flowing to recharge.
Yeah, exactly. Yeah, because I'm as curious as you are to see if this works, and I want to monitor it. I want to see if the actual amps are going to the battery. But I know as long as the battery is 100%, we won't see it. So I need to plug in the battery, run it down, put an inverter on it, plug a TV, run it down for about 2 hours or whatever, until it's down by about 90%, which means that it will accept any power that's coming from the controller, and then we'll be able to monitor that, and I'll have it on video.
Yep. That'd be great.
Yeah. All right, guys. Listen, take it easy. Great chatting to everybody. Have a great day. Bye.
Okay,
Bye
bye.
bye.
Thanks a lot for being around. So, we have someone called Jeffrey. Jeffrey Dunn is saying that he doesn't know how the Liberty Engine 2.0 makes sense to me. There's a time I think we did a live stream about that, but there was a question for you, Lam, from Trent.
Yeah.
Trent was asking like how far is your like the closest mass station where now you are getting the radio frequencies from? Like how far is
I,
it?
I think they have kilometers away from kilometers. I think maybe 2, 3, 4, 5 kilometers away from where I stay, from where I do the experiments from.
I think there's usually
I'll be right back, Chris.
okay. There's something which uh Professor, what is the name of the Dr. Eli had showed me that usually depends with the, is it inverse proportional to the mass station, the location where the mass station is where you get the, like if it's very far away you're going to get very small when it comes to millivolts, like millivolts that will be like tiny. But I don't know how you're able to do this. I wish you could be able to share, like to do a live stuff more than this, because recorded video, sometimes someone feels like you're hiding something under the table or you're not showing the full information.
Yeah, that is true. That's why what I will do, I will I'll make one clear video tomorrow without no edits, no what. You'll be able to see this is just an open place. The area is up, it comes, then you can verify.
Or we can do, are you okay we do it on a live stream?
Live stream.
Yeah.
At what time?
The time that you just be okay with.
Live, it is possible, but it will just be tricky because I don't know the time I'll be free and I'll do it. So that's why what I wanted to do is after I'm doing my I just get some time, go either percolator or something like that, something that can easily be visibly seen that this is working. I put it, record everything without cutting anything, everything clearly seen. This is an open place without any table or without any wire, other interference, and then you see.
You can tell me the time, or if you're okay tomorrow when you're doing it, you just let me know the time and we can do it on a live. On a live, people will have fewer questions.
Okay, we shall see tomorrow. But I think I'll communicate to you on WhatsApp.
Okay. Cecily is saying that it does not, but Cecily said that he's using radio frequencies. But Cecily said that he doesn't believe he's using radio frequencies. What I believe is he's tapping into negative energy.
Which negative energy? But it is radio frequencies. That's what I know. because it's what I've tested and it's what it's radio frequencies. The main thing is just knowing how the art on how some things work.
And Trent is saying what? Trent is saying the comment that this just looks like you put a wire on a radio station and plugged it into a power strip.
Yeah, it looks like that, but it's not it. I'm just getting it from right from radio frequencies, nothing else. No any other either wire plugged into what or what. So that's why this video you can still play it and then you see that this one is never.
Pass. Eh.
You see now this one doesn't show us the full story that one. That's why I was saying that you see if it's alive now, if it's alive when they're showing me something like this, I'll say like, man, can you show us under the table? Can you show us that cable? Where is it going? Where is it going to? Where is it coming from? You see,
I'll take a video showing every cable where it is coming from under the table first of all, every clearance, and then you see. Yeah.
If I'm being honest with you, but the good thing is for me, I've been honest with you from the way they start. So, and I told you like I don't believe this, but I know some
Yeah.
people. When you did ask the question, first of all, the first time I told you it was 100% said no, yeah.
Yeah,
But then
yeah.
it got to a point where 85, it was 86 saying no, but now it is 70% saying no. So I think you have managed to convince
30%.
yeah 30% that you say it's possible, because initially it was like no one was believing.
Yeah. Just let the whole video to play and then you, because I think if there was anything like maybe something being you'd be able to see. I think you can see like trying to zoom out now. You can even see the smoke coming out of the flat iron, everything. So that's why I think it might even be much more than the 5 kilowatts that I'm thinking.
Or you think you're getting out more than 5 kilowatts? That's why you say that for you you figured it out better than what Max Kumbu.
Yeah, because I think maybe if we see, I cannot say that I figured out better than him because I've never seen like much about his innovation or stuff like. I think you can see the flat iron almost burning coming out, and I've not seen much of his work, so I cannot say that I know better than him. I can't say that not until I've seen what he has done. We've tested. I've seen why is it like now people who have bought it are not coming out. All those things, then I can see maybe I know better than you, or maybe you are still ahead of me or this, or maybe you had a conspiracy about it. So all those things. I cannot say that is not good or what. I can't make that without verifying.
I'm seeing here certain reporters just trying to Google. They say that there are some people who did like an experiment. For them, they were say that, for example, researchers harvesting ambient energy from a massive 960 kilowatt television broadcast tower from 4.1 kilometer away were only able to pull out 60 microwatts of usable electrical power. So 60 microwatts, that was 0.00006 watts. So
Yeah.
you how like for you want to say that 60 microwatts was the one which was causing that spark like to light up in the
Exactly. No, you said that they transmitting it was around 90 kilowatts of power.
The like the radio station that they were getting it from was
Yeah.
was using 960 kilowatts.
960. Now that's a lot. Because now for us in Uganda here, it's around. Because I have one of my friends builds those telecommunication masks and so on. Told me it's between 30 to 50 kilowatts. That's what they use.
Yeah, and so imagine these guys, they were like about 4 kilometers away, which is even shorter than yours, because yours you said that you said 5 kilometers.
Yeah, I think and I've not yet, but I think it's 5 or even more than that away from the masks, those transmitters.
And for them, you see, for them, they were able to get only about six, like 0.0006 watts.
Yeah. Now
But
me,
now,
I'm getting
and
kilowatts.
for you are saying that you're getting more than 5 kilowatts. Anyway, there's a question from Trend.
Mm.
Trend is that you still haven't talked about how you are charging the phone with the same strip, and said the strip was connected to something else.
Why I wasn't charging the phone with the same strip?
Yeah.
Okay, this is it. The amount of power that sometimes this thing produces is
Yeah.
way too much, to the point that sometimes you see that light bulb there. We have
Mm.
to first of all put that bulb in order to first of all because it takes a lot of power. So it helps us to first of all pull off power from it before we can plug in those things. That is what I've seen. Because in most cases, you realize those meters we've blown so far 3 4 meters. Like you just go without first of all putting that light bulb. Then you just plug in the meter. It will just hear it making noise. It is like it's over voltage. It is a lot. It can't measure it. And should you again just tap it twice, that meter is gone. You've so far lost around 3 of them. So that's why I couldn't risk putting my phone in it. I knew it would blow. So that's why what I had to do was to get things that take a lot of power. The flat iron, those light bulbs, then the other converters, then first put into it. Because one thing that I have to also look at right now is how to reduce and to regulate and to make sure that the power comes exact what is needed without anything becoming much. So I think
Uh,
I've answered him. Yeah.
you say that there's Cecily disagrees with you that there's no way you can get that power from from frequency, from radio frequency. By this, Cecily is someone who believes a lot, especially, and he supports a lot people experiment free energy devices. Now, for him to question you like this, uh,
Mm.
because Cecile is like someone who should be supporting you right now like crazy. And you see, even for him, he's saying that he doesn't believe that you're getting that amount of power from radio frequency.
Now, it's like this is what I can say. It is very possible not to believe it because if it was done by 1 2 3 4 5 people, or if it was, then it would have been very possible to believe it. But right now, there are some other technologies that can be produced, and then you look at it and you're like, "This is so mind blowing. I can't believe it." So, maybe it is. This is also part of it. Maybe.
Yeah, he's asking, our trend is asking that where is all this energy coming from? The wire connected to the bulb. Measure that. Oh, he's saying that you measure the wire connected to the bulb.
Saying that what?
You measure the wire connected to the bulb.
Mm.
Like asking if you can, although now you see now that was the things that you can be able to do if it was like a live stream and you're measuring it and we see it. Like we can be able to, if you go to measure, like if you go to measure some certain cables or like the appliances, what you're getting out of it, and we
Mm.
see that maybe, but yeah, it could have given us more information anyways.
Yeah, if maybe I was able to, but I explained why. Because most cases, if it's without first of all using those high power taking things, it blows the meters off. So I had to protect my meter at first.
I don't know, but the Liberty NG 2.0 makes sense to me. Jeffrey, are you still around? How do you feel about what he is talking about? In case you want to share something or to ask him a question, this is the time that you can feel free to do so. I'd seen some up from Travman. There's something that he had said about what you're doing, and I'm looking for it.
Mm.
Trend is asking like how comes you could not measure the iron, like you did not measure the voltage and current that is going out.
I think I explained that. I've explained that. Why? It's
Because
not
it
that
will,
maybe I've been. Hmm?
you said because it can blow up some stuff.
Yeah, it can blow out some stuff, but also another thing, I just didn't take the video when I was married because in most cases, to me, it was because I was that video. I didn't make it for anyone or for any. I didn't know if we would even have this kind of meeting. So I was just doing my own stuff. continuing and pursuing. So that's why to me it was not making any point of measuring this comes this and this like that.
So basically, what you're trying to say is, for you, you are not using this type of electricity or this type of technology to light up your home at the moment, because you don't know how, as of now, you don't know how to regulate the power output yet. Like
No,
yeah.
no, there are two things why I'm not yet using it. Okay, let me say three things. Number one, the power that comes from is too much, so I don't know yet how to regulate. Number two, these radio frequencies, as I said, they don't occur in the same environment. Like they are not the same anywhere. Sometimes at my place, other places, you realize it's too much. When you try to tune in the area to a certain direction, you realize it's too less. So that's why to guard my appliances, I said let me first leave. Then number three, I am living in an rented apartment, so I don't want to risk the neighbor's house and stuff like that. Actually, my landlord's house. But once I've known how to regulate everything, I'll talk to him and I'll tell him I'm going to put this away and I'm going to use my own power.
But if you're able to put in through this, like, can't you just power like simple home appliances with it? You don't have to. You don't have to go and connect it to the entire house, maybe to redo wirings and all that.
No, it's very easy. What I will do. What I will do is just connecting. Like I can get a socket. I first go to the main meter box, disconnect and remove remove the connection to my because each apartment block has it. Each apartment or each room has its own power like meter. So I disconnect my own and then I just power it. I just connect it and then from my house, then it is able without redoing the wiring. But I just want to first rectify everything, regulating it and also making sure that it has its own frequencies without even need of areas. Because the way I saw it sparking.
How will you measure the frequency?
How will I measure? Like the other meter that I showed, the other meter that you saw. It's
the
what
yellow
for
one?
now. Yeah, the yellow one. For now, it's what I'm using, but it's not effective. So that's why I have to buy another effective meter. So that now the questions of which band I'm using, all those things will be properly covered.
That multimeter will not cover different bands.
Yeah. That's why I'm like I have to buy another. But for it, we are just using it to check it in just ohms. So there is a way how
ohms? You're measuring ohms.
Like okay, when the wire comes from the meter and when the wire comes from the area, you try to measure it this side. That is the way how it flickers the meter. So once it has moved it to a certain extent that we know that this is where it works, then we know that this positioning is well, then we connect it.
Yeah, I'm still confused on how you measure frequency with that meter. It's designed to measure whatever country you're in. If it's 50 hertz, 60 hertz, it's designed specifically for that frequency. Anything outside of those two common, I think there's probably other frequencies, but they're not designed to do multiple frequencies, more than maybe 2 or 3, maybe, but I know at least 2.
Yeah,
you're talking about anything outside of 50, 60 hertz. What are you measuring? What are you expecting to see?
Some of these things I can't explain well. I think the best thing we can do is let's just watch the video tomorrow and then we are able to get everything we want. Because why I'm saying I can't explain well, because you guys, you have specific sophisticated instrument that is used for measuring this and this, and it gives you accurate reading, which is okay. Now for us, I don't have it. So that's why some things I know and I have to forge my way out. So that's why even like last time whether it was you explaining how like the voltage, the frequency tuners, all those things, because once you go into most of those things need the power to for them to be able to work. So you'd realize that first of all, the power you'd be trapping, you're already wasting. You need another power to be able for you to see it. So that's why I had to just use my own small understanding to come out with this.
But I'm lost in how are you assuming that the frequency is whatever it is. I don't know what you think the frequency is. How do you know what to tune to? Like, how is that even possible? You said you built the circuit. If you built
Yeah,
that circuit, you designed that circuit to pick up a specific frequency. What frequency did you design it to?
and that's why I told you. For us, we just try to first measure because we don't have this the one that measures frequencies. So what we do, we go into our meter and then we tune it into a certain frequency that we want. So once we see the meter has moved to that, then we know this is the exact.
Wait. You modified the voltmeter to measure different frequencies?
No. We don't modify. We've not modified anything on it.
How do you pick up anything outside of 50 or 60 hertz? How do you pick that up?
I can't explain that, but you'll be able to see.
I'm not asking questions to be like mean or anything, but you said you designed that circuit. That circuit that you said you designed, and these are questions that I would expect you to know if you had actually designed that circuit.
Yeah, I understand what you're asking. I understand exactly what you're asking. But as I can tell you is that for us, okay, what I can tell you is we are trying to use something that is not supposed to be for that thing to do that thing.
Okay, because so how do you prove that it's doing that we don't expect it to do? How do you prove that?
That we don't expect it to do.
Yeah, you said you're capturing things, you're doing things that we're not supposed to be doing or experiencing. How are you detecting that? Like, what is proof that you're detecting something we don't know about?
Okay, let me say, for example, if the wind is blown from one corner to another, it's something that cannot be seen unless maybe a windsock moves. But if you see it, let me say a cup flicking, you can know that actually this one came, it was much or it was less. So if the cup was able to fall, then I think it was more than the one before. So that is the exact thing that I'm using. For example, when you connect the antenna into the antenna to the multimeter, then you take it into the ohms to measure those milliamps and so on. Like there, you will see it moving, and so to show you that there is something small being detected. But even though you touch it with your hand, nothing. Even though you try to put it in your mouth, you will not feel anything. So once you, yes.
I was just interesting in that isn't ohms. Ohms, I think is resistance. Yeah.
Yeah. It can be resistance. Yeah, in most cases, it is resistance.
Yes, for you measure, what do you like usually? What do you measure? Like, what do you measure? You measure voltage, current.
So what we do is we are looking at frequencies that are coming. Yeah.
You said frequency which is coming is 12. That's 12
fast. We use the one that is of 12. Of course, should it go actually 12 and 16? Should it go beyond that or less than that? It doesn't work.
12 or 16 hertz?
Yeah, we'd call it 16 hertz.
Well, how are you measuring that?
Using the multimeter.
The multimeter will not measure 14, 16 hertz.
Now, this is it. Let me do it tomorrow and then you see.
If you pull the data sheet for that multimeter, you would have to show me where it's able to pick up 14 hertz. It's not designed to do that.
Yeah, that is true. It's not designed to do that.
Is it a fluke meter? FLUKE? That's a very common yellow color. That's why I'm asking. Is that a fluke meter?
I think it's what you call a fluke because I've never thought of knowing much about it. And let me see.
If it's a fluke meter, they usually make those yellow multimeters like that. So they're very, very popular because they're very cheap and they're definitely usable. But they're designed for AC signals. They're designed specifically for frequencies that go to the common houses, like 50 hertz, 60 hertz, depending on where you are in the world. They're designed specifically for that. So to do anything outside of that, it's not going to pick it up.
It's okay. Let's do like this. Let me make a video for you tomorrow from the meter
Yes.
after, like, let me say, after putting the kind of frequencies we use, then you see it from the aerial, everything, nothing connected. Is it able to power up anything, or it's not able to?
Okay.
Yeah, I think that is it.
Yeah, it's okay. It's okay. I think let me see. Jeffrey saying that if you stack up the he's talking about the Liberty engine will increase voltage, but because it's the small amount of frequency, the watts is way too small. Oh, I think he's also talking about your stuff. He's talking about the
Mm,
being too small. There's a comment
Ha-
which I've seen from you.
Have you ever heard of a crystal radio, Lamb?
Momo is
yeah,
just
yeah. I've ever heard of it, Christian Radio.
You never heard of it?
I've ever.
I'm sorry, I don't understand. You've never heard of it?
Okay, I've ever heard of it because actually, even this one of my primary, when I was just starting, it was the idea came from the Crystal Radio.
So you've used one, you've seen one.
Yeah, I've seen one.
Do you know how much energy they actually convert into some sort of signal, maybe to drive an LED or something?
It is very, very little, millivolts. Actually, I've never used it.
Micro watts.
Yeah, microwatts. So it's because there was a certain video I saw in YouTube, and someone was lighting it 3 LDA with it.
So as a reference, crystal radios converting RF signals to, let's say 5 microwatts, just to give it a number, but it's in the microwatt range, 2 digits. If it's
Yeah.
converting RF signals to 5 microwatts without amplifying, you're saying your system is 1 million times stronger than that
Exactly.
at 5 kilowatts.
Yeah.
1 million times stronger energy that you're picking up than a crystal radio. Then that means that so that means you're in the vicinity. So that energy is passing through you. Am I assuming that wrong or no?
Yeah. Okay. Exactly. Okay. Let me say it would have been like that. That's passing through me. But remember, this comes in like it is very small. So I doubt whether all that energy is coming through me, because most of the physics and the magic is on the board, not only on what is coming.
Yeah, that's a hard one to believe that you're 1 million times stronger than what's already available. Like where is that coming from? Because if you're pulling from the same ambient air, you're pulling from the same RF signals, the same environment. Even if you're in an area with a strong signal, you're saying you're 1 million times stronger than what a crystal radio can pick up in RF signals. That's a large claim. That's a really big claim.
It's okay. It's fine. Yes.
Momoka was asking, like, do you have a PLL on this board, or is that, like, he's asking if that is what is the IC of your board?
Great question, Mumu.
Pardon?
I don't know if you can see the screen, but Momoka is asking, do you have a PLL on this board? Is that what that IC is? He's asking if that is what the IC is.
Hey, I'm sorry, Chris. Before he answers that, I made a mistake. Not 1 million times, 1 billion times. He's claiming 10 to the 9 times a crystal radio, which is 1 billion. So he's claiming 1 billion times stronger than crystal radios.
But the producers are not. What he's claiming is like, said I2UID, but what he's saying is like impossible, but he said that you're able to do it. I think there's an issue again on your side.
Yeah, your microphone's going in and out, Lamb.
It's like you froze.
Am I on now?
Yeah.
It's the echo.
Oh,
Okay, it's
sorry.
good now.
Now, yeah, that guy was asking if I'm using a PLL on this board. Yeah, there is a certain PLL that I'm using to match the frequencies. I think he's answered.
And Trovman is asking, like, how do you know you're targeting radio frequencies and not just using an antenna to pick up atmospheric energy like this? I think he's sharing a video.
Atmospheric. Now, if it is getting another kind of what, so that would mean which kind of other energy is there apart from the RF. So it is the radio frequencies that I pick, because it's not that maybe I'm running it during stormy days or it is just during the sunny day, as you can see.
Let me get the video and see. And Adebayo is still around. Adebayo is also saying that ohms is resistance. Like when you say that you're measuring and you're getting ohms.
Mm. Now, the only thing how we can sort out this is, let's just wait tomorrow, and then you guys get a video which shows everything.
What if you don't come back?
Oh, what if I don't come back? That gentleman who is the host, what's your name?
I'm called Chris.
Yeah. Chris has my direct phone number.
All right, Chris. When you call him, let's go live and we can see if we can get him on the phone if he don't come back.
Yeah, that's so. I told him that we do it live. Yeah, but he doesn't. He says that live. But you see, if it was like during a live stream, we can be able to ask him. Maybe show this as like it is easy to clarify things compared to right now when we're talking about a video, and we have these questions like you don't know what this is. This maybe where is this going? So if it was like on a live stream, it could have been much better.
It's okay, we shall see tomorrow. But what I can tell is I would prefer I do a detailed video of everything, so that I come and show you now all those things, frequencies, what. I'm saying that because usually my programs are not very straight, so I can't tell. That's why I'm telling you in case I get time tomorrow. But if I don't get time tomorrow, then that would be on Monday. But I'm going to try to fix and see tomorrow. And now, and another thing, why I'm saying so, like, if we are to go live, several people would want to ask questions and stuff like that. So you'll find that almost my day would be gone. So that's why I would rather make a video with detailed everything. Then right now, since in the evening hours I'm free, then I can play it to you, and then you can ask anything you want.
You have good excuses, but also I'll say, like, why can't we do like that live stream in the evening when you're free, like at your home, like right now? You say that today is because you forgot to carry your meter. So
I have not carried my meter.
Yeah, you come with your meter. You already have this equipment at your home. So the only thing that you're missing is the meter. Why can't you like carry the meter tomorrow to your back home? Then at time when you're free, it just shows on the live like, yo, this is how I do it. You shot the
I think I also told you that RF is not the same. The signal is not the same in every place. That's why I'm trying to build one that will not require areas. I think, I don't know when you remember that, because at my place, when I tried to change the areas, other places would be too much, other places would be too less. So that's why I stopped. I don't know whether I remember that. Like, that's why I'm not using it.
You said so, and you said you cannot now be able to do that because you don't have a meter. But now what, like if you come with a meter and you try to tune it to move it to a specific location that you feel like you get it sending the enough radio frequency that you need, then you
what I will do, I'll try, but in case it doesn't, then what I will do, I'll just do a video from where I usually take it from, then I come and show you. But however, I'm looking at a way of solving that permanently.
Okay. Trevman had shared this video, but this video I think is how powering with atmospheric electricity works. Oh, this is different. They're saying that they're using atmospheric electricity. from 10 years ago. A Corona motor and electrostatic motors.
Guys, if you don't mind, I think can I leave the live because I'm feeling somehow exhausted and I'm kind of hungry.
Okay. It's okay, man. Thanks a lot for being around and see you next
All
week.
right, see you.
Yep. See ya.
All right.
I don't believe you though, but see you next time.
It's okay. It's very right not to believe me. It's very right.
Yeah, I don't believe it either, Chris. I don't believe it either. I think this is the last time we're gonna see this guy.
It's okay, no problem. You can mark my actual. What you can do, you can
I
even
think
go to my tick, but I don't have anything there. But if you think I'm lying, you can go to my TikTok page, Lux Technology, where I post my incubator, so that in case you don't see me, you can say this guy is a scam, and it will affect my client base. In case you think,
he's persistent and he will come back because so like today he joined and last time you had a conversation with him, it did not go well. I feel like this guy is lying to me and but
no, that day it's you who failed to believe me because I first wanted to talk to you and ask who is this, whom am I going to send it to? All you started telling me was you are a scam, you're Muyai. So I was like, really? Why would you say something you've not heard from anything?
But you see you are the one who contacted me like a lot of people do, yeah? And they tell me developing this type of tech. Then when I tell them to maybe share more information, I see it. Like how is it going? No one is willing to do so. Then for you tell me that I'll call you at evening. I don't know, I'll call you at this time. I don't know. That time comes, you say that I'll call you at this time. And I was like, this guy is just like other people are giving me full of excuses and there's really nothing here. So there's a one word I know from Luganda is called muyaye, oli muyaye, which means like you are like you're not straightforward or you're like yeah, something like that. So I told him
Olimia means you're a scammer.
scammer.
Yeah, but I think I explained to you why I said that. I said that because I had to wake up very early in the morning. I had errands to do. I had to deliver incubators to the client. So I do, and the reason I said you had asked for the video because all the shots is there. Then I told you I'll first call you because I needed to know whom am I sending it to, why, so all those things. So that's why when you told me Olimuya, at first I asked myself, I told I was with one of my friends, and the person was like, so I asked my friend, yes.
I was saying that so you see like if you're someone who is contacting me, I think it means that you already know me, yeah.
That was my first time to watch your videos and to see you on YouTube, so I didn't know anything much about you. So that's why at first I had to talk to you because there are sometimes people who can ask you like that. Kumbe, they just want your video, post it on YouTube for them to get likes and probably to make money from you. So those are the things that I thought through.
Adebayo is saying allow you to, so it's okay. I think you go with that option. It's saying that allow you to create the video and then you can be able to explain it on a live stream. It's saying that is better.
Yeah, I think that would be better so that you can have enough time to ask anything you want.
Okay.
All right.
It's no problem, man. You go ahead and enjoy your day.
All right. Good night, all my unbelievers.
I think it's 65% now. So I think you did good. I see it's 64% no. Earlier on 64% no, 36% yes. Earlier on it was 100% no. So maybe you have somehow managed to convince a few people.
Yeah, it's okay, no problem.
Yeah.
But it works. Yeah. Okay, bye.
Okay, bye.
See ya.
All right, see ya.
It's okay, man. Let me. But let's see what he will share. Though it could have been nice. You know, on a live stream, you can ask someone to show more stuff than on a video. On a video,
Yeah, but he wasn't going to show you more than that. Just a prepared video. He wasn't going to show you more than that.
Yeah, it doesn't sound like willing to do that. I feel like he's giving the excuse of it will. He said that it will do what? It will damage the
Hey, remember Gerald said the same thing. I tore it down. I don't have it. Lloyd said the same thing. I don't have all the parts I need. Like, this is a very common way of avoiding just showing what the claim is. But I am like really skeptical because of that circuit he showed and he knew nothing about it. If you're going to design a circuit to do what he said he did, like, I did not ask hard questions. They were not hard questions if he designed that. So I don't think he designed that board, and because he didn't really know how it worked.
Previously demonstrated.
Showman is saying that I don't know show. But Roman, I'm gonna play it. Yeah, he said that he designed it, but also I don't know. The other guy was for him. I think he was just filming. Nesta, you just missed. Nesta also says such stuff, but he never shows anything. I don't know if you
He's
know.
claiming 40,000 watts.
Yeah, but he never shows anything. Although there is a time he tried to join, but his connectivity was poor. He told me that he was at work at night. I don't know, doing a night shift. But
Yeah, Nesta, the last guy's claiming only 5,000 watts.
Yeah, Nesta is saying that he's able to output. That's like five. No, the last guy said 5. So Nesta is saying
5.
that's 40 kilowatts.
Yeah, 8 times that.
Nesta, are you sure? Nesta, are you willing to show us? The guy just showed us a video of how it's doing it and all that. But Nesta, for you never share. There's a link you can join if you want to. Nesta, today I think your connectivity is okay. But Nesta, I have a feeling, you know, some people I never know if they are saying the truth, or because for some I feel like there's some people who use it to do what. There's this English term that I'm forgetting, but it's like where you make fun of something. So because like there are those people who just come and they say that I can be able to do this, I can be able to do this, and you just listen to them and you know like this person is just making like
trolling.
Yeah, more like trolling. Yeah. So
Okay.
so there are some who email me and I feel like they're just trolling, or they just want you like to give them some sort of airtime. But for Nesta, I don't know. For Nesta, I think for him is usually maybe he's correct about it, because there's a time he wanted to show, but the connectivity.
Can you show anything, Nesta? Anything right now? A video, a link, something?
Let me send him a link. So when this guy also reached out, Lam, I feel like he was just sort of like trolling or something. He's the one who emailed me, who texted me on WhatsApp. And so I was like, who is this? Maybe. Then he explained that you can be able to do this and this. I felt like, this just must be a joke. And then he himself told me that I'm gonna call you on video at evening. Then at evening comes and I do ask him. Then it's like, no, I did not ask him. I think he texted me at evening and he was like, I'm gonna call you tomorrow on video. Then tomorrow morning again he says that I'm gonna call you at a certain time. So I got a little bit furious and I told him like, you the one who told me that you're going to call me, and you keep on saying that you're gonna call me at certain times. Not like I'm pressuring you to do this call or not. And I say that I've heard this story before. Most people come up with these things. They are mostly liars and like scammers. So and he said, we are not going to talk again. He said that he will not talk to me again. But then later on he shared this video which we just played, but it was V1s. So I could not even understand because the language is different. For them, they speak a language called Uganda, which is different from ours. A little bit, that is.
You talking about Lamb?
Yeah. But anyways, let me wait to see what he will say. As Nesta is saying that it's not rolling, but he will share. Jeffrey said that atmospheric energy is another form of frequency. Let me play this video and see what it's all about.
Atmospheric energy is another form of frequency. I thought atmospheric energy depended on the capacitive nature of the atmosphere. Like frequency, regardless of frequency, the atmospheric the gradient of the electric field as you go higher and higher in altitude. I thought that's what that was based on, not frequency.
Jeff, uh, Jeff is saying frequency. I think even Traubman was saying that it is different between frequency and radio frequency and atmospheric energy. That's why he shared the video. He said that maybe this guy is tapping into atmospheric energy and not really radio frequency. Even Cecile, I don't know if you saw the comment from Cecile. Cecile also agreed that you cannot get that amount of power from radio frequency.
Yeah, but Cecile says some weird things sometimes. He said he thinks that Lamb was tapping into energy that we don't know about. Well, if we don't know about it, how the hell do you know?
He said that it's negative energy or something.
How do you know? Like you're just claiming it. Man, this is hilarious.
Next, are you going to join? You said that you clicked on the link. You click and come. I'll see you. I haven't seen you here yet, but if you do, I'll see you on this side. Oh, Cecile's also. Jeffrey's also saying the same. That maybe that guy is confusing it with. I don't know if you've seen the comment from Jeffrey. He's saying that that guy might be confusing it with radio frequency. Although the guy said that he's 100% sure for him he's using radio frequency.
But he has no way of measuring it.
Yeah, that's the thing. He said 12. He said 12. I tried to Google. He said 12 hertz. I tried to Google. It says that there's no way you can get like the antenna. Like, there's no way it
that
will
antenna size would be ridiculously large.
Yeah.
Hold on, let me Google that.
It says that to efficiently transmit 12 hertz signal, your antenna will need to be 606,250 kilometers long.
For what?
Or 383 miles long. Like it
for
has
12 hertz?
Yeah. That's what Google said.
Yeah, I'm getting an antenna for a 12 hertz electromagnetic wave is physically impossible to build because the required size would be thousands of miles long. At 12 hertz, the electromagnetic wavelength is about 15,500 miles or 25,000 kilometers, meaning a standard half wave dipole antenna would need to be roughly 7,750 miles long.
Oh, yes, the same 7,000. I see. That's too big. So basically, it means maybe he's confusing with what he's measuring, because for him he was talking about ohms, which is
right. That's what I'm saying. I don't think he's measuring what he thinks he's measuring. How do you know what frequency? You don't have the tools to measure it. A voltmeter is not going to measure atmospheric frequency.
Yeah, for him, I think he's measuring something different. Travelman is agreeing with you that you're correct without being able to measure it and tune it to certain frequencies. You're not using frequencies, and also, but Nesta is talking about some stuff here which is not able. It doesn't want to come and talk about. You say that you have to create the lowest potential point in the circuit. Maybe for you, like Nesta, how are you doing it? Like on your side, how are you doing it to be able to get 40 kilowatts? Like how are you doing it? And how do you measure? Like how do you measure? What are you receiving from the antenna? Because for him, he said that he's getting 12 hertz. For you, what are you getting out of it? And we are seeing here that 12 hertz is actually impossible to build such an antenna, like to be too big.
Yeah, I don't think Lamb understands the numbers that he's using when he's saying 5,000 watts and 12 hertz, and he's using these terms, but he has no idea what that means physically. Hey,
Yeah,
just to give a perspective, you have a laptop, right? You have a laptop that plugs into the wall, so it converts AC to DC for your laptop, right?
yeah,
Typically, it has that big black box in the middle of that cable, right? From the wall to your laptop, there's a black box,
yeah.
rectangular box. What is it, like maybe 3 inches by 1 inch by three by?
Mine, mine is big.
It yeah, it's like a remote control almost, like a television remote control size, right?
Yeah,
Could be roughly about that. That is only converting 50 hertz, 100. Let's say in the US, it's 120 volts at 60 hertz. It's converting an AC signal with a specific voltage and a specific frequency into DC. And that's one frequency or two, because sometimes they work on 50 hertz or 60 hertz. But the point is, it's not working on all frequencies. It's specifically designed. All of that box, that block that's between your laptop and your outlet, that box is responsible to convert that AC to DC. And look how big it is just to do two frequencies. Two. Like, we're not talking 10, 15, 20. Two frequencies it needs that amount of material just to convert AC to DC. That's, when he was bouncing around frequencies, I'm like, how are you picking up all of these different frequencies? I don't see an antenna the size that you need. I don't see the circuitry that he had on that board. It wasn't complex. I mean, it was just a bunch of resistors on top with some sporadic parts, but they didn't really seem like they went together. Like when you typically have an IC, an integrated circuit on a board, there's usually like some capacitor surrounding it, some maybe a transformer, or not transformer, inductor, maybe a MOSFET, maybe something that's tied to that type of IC, that chip. There's typical things that go around it, usually large capacitors, because when you turn these things on, you put a large capacitor on the voltage, on the bias to turn the chip on. You don't want that to fluctuate because of some resonant frequency on the board. You put a large capacitor on there to hold the voltage to a solid 5 volts or 3.3 volts, whatever it is. That's usually right next to those ICs, really large caps, to keep that voltage steady. So I didn't see the typical things you would see on a power board, that it looked like a power board, like if you rip it off the back of a television or something. If you look at the power board that converts that AC to DC to distribute to all the components on the T board, the T-con board on there, whatever it is, I didn't see any real structure to the layout of the parts. So I was confused just looking at the top. And, when I asked for the schematic, he said he can't give it to me. Okay, that's fine. But that board right there. That board right there. So typically when you have, let's say DC coming in or AC coming in, AC to DC boards, they're called power bricks. They're usually built separate from a control board. If you rip open a television, there's usually two main boards, and then there's a board that does all the LEDs turning on and off of the screen. But the power board is separate from the video analog audio and video board. Those are separate because if noise gets on one or the other, you could really screw up the electronics on them. So the power board, that looks like a power board with these large caps. You only really use those when you're trying to keep some voltage as steady as you could possibly keep it. And that needs a large capacitance. It keeps things steady. It doesn't go like 5.5 to 4.5 to 5.6. It'll keep it a flat 5 volts. That's usually where I would see those around ICs built around a specific circuit designed to do a specific function. I don't see an actual circuit here. Like, I just see parts. The LEDs, they don't make sense. The resistors, like, they just look so random. It doesn't make sense to me. But this video is definitely confusing.
Yeah, it is. It is. That's why even for me when I watched it the first time we talked to him, I was like, there's no way. I feel like he's just getting electricity from somewhere else. And
Oh
also
yeah.
think I don't know what I was doing that day, so I didn't reply him back. So today that's when I saw someone call joining, and I thought it was some guy from. There's a guy from Nigeria. I don't know if it's at the bio, but there's a guy from Nigeria. He wanted us to do an interview with another guy who is able to make. He said that he can make. He was able to make a water generator, but now it was only outputting like microwatts or something. It could only be able to light like small LEDs. It wasn't much, but he wanted us to do an interview with him. But it was a long time ago, I think last year. So I thought it was the same guy. But for him, I hope you share more, then we can see.
Yeah, that
But
would be nice.
the problem with the video thing is you're not really able to ask questions like beyond what you see, because someone will just come on the live and they will explain and explain. But if it was like during the live or when he's at home, then he shows us how it's being done, and now you can even ask more like, can you confirm this? That way, by then you can be able to convince everyone. If there's anyone who is doubting you, you can convince them 100% like what you're doing is real.
Yeah, he didn't. He didn't. I don't think he passed the test with some of the questions from the chat. And myself and Alan. I don't think he passed because he definitely was saying some gibberish stuff, some really weird ways of explaining things. I thought a good question was, "What is that wire in your right hand?" That was a great question. What the heck is that?
Yeah, I think he did not even know as well, but that's why somehow it's connected to their meter. If you see it here, but for him, I think he was the one who was taking the video, and maybe this setup was built by. You see this guy, the guy who is here, who is holding that stuff. I think the one who built whatever this is.
I don't know what that is, man. That's.
But you see, that wire is going to this one. So it's going. It's
How
going.
can you tell what's going where?
But yeah, there's a lot of stuff. And when you ask him about like the socket that was somewhere there, he's saying that it was bringing in electricity, but it wasn't doing anything important. Nesta, you want to come on? Nesta usually says a lot of stuff, but he never wants to come and join.
Please come up, Nestor.
Maybe Nesta can explain better what this guy is doing, because he's also like you. The way you're using radio frequencies, he's also using RF. But again, this wire, I don't know. This side I know where it's going, but now this side, where is it
I
going?
can't see your mouse. I don't see you dragging anything.
Yeah, but there you can't see my mouse, and this is different from the other one. Sorry, I mean, you see on the, let me use on the upper side. On the upper side, that wire that is holding, it's going to the meter, right?
Maybe. I don't know.
You can see it going to the meter. You will see it
Up,
going.
yeah, I see it now.
But now the lower side, where is it coming from?
Yeah, where's the other side of that meter? There's nothing connected to the meter.
Yeah, that's the question now. That maybe it will be nice for him to explain that part.
Yeah, I think a lot of times these things are put together to confuse you, just so you can't really say it's fake because you don't really know what you're looking at.
But you are the one who noticed that. I think it was here. That plug, like you can see, is plugging in something on the ground close to it.
Yeah.
There's something there which, for him, the way he's explaining is that he said that it was for that there was some external, like it was bringing in power, but it wasn't being supplied to, not connected to anything. That's what he said.
I think he ripped this board out of some other component. Threw some wires on it.
Yeah, I'm feeling so. I think maybe I'll try to ask AI if maybe a screenshot of the component. Then I ask AI if it can be able to find it maybe online, or if it can be able to reference it with anything.
What is the circuit right above on the top left, but right to the right of that orange looking piece at the top of the screen? What is that circuit?
I don't know what that is, but it doesn't look. Is it connected? I don't think that it
I
is.
don't think so. It's just floating.
It's not connected to. You're saying that you're trying to come on, Nesta. How? Just click on the link. I'm not used to streaming on YouTube, so unfortunately. Oh, but you say that you're trying to come on. You just click on the link, then it will bring you on. You don't have to show your face. You can switch it off.
Yeah.
Let me bring my comment. But I think that thing that you're saying ID is not connected to anything.
Yeah, I don't know. I can't. It's just so hard to tell what I'm looking at. And why is he wiring directly to the outlet? The lamp is wired directly to the outlet.
Yeah, so the way he was explaining, let me try to get my camera back. The way he's trying to explain is that you see, once you feed it to his board, you have two wires. This, I think, the blue wire, and also there's this other one which is green and yellow. They take what you get from the circuit board all the way to the transformer. Then from the transformer, it takes it now to the power supply. Now to like the outlet now. Now the outlet now is the one which he did put a bulb on it. He said that was,
Why not just wire directly to the transformer? What is the outlet doing?
by the could have just wired it directly to the transformer. Yeah.
Yeah, that doesn't. The outlet is confusing me. Like, why did you even have that in there? You could have just wired the transformer directly to, because that's all the outlet's gonna do, right? The outlet just passes voltage. It doesn't do anything. It just passes voltage and current.
Unless maybe his plan was, if it was a plan like you want to connect multiple appliances on it, like it was with the iron box, and the other video was the iron box and what, and the bulb. Yeah? Maybe if that was the case, then it makes sense.
Yeah, I think we're just looking at a bunch of random parts right now.
You say that we're just looking at a bunch of.
Yeah, so if you look at the board itself and those ICs, the little 8-pin one on the left, and then I think that's a 16-pin on the right. The little ones near the larger caps down there. So if you look at the pinout for that, usually there's a voltage, there's a 5-volt, and then a ground, right? There's usually power pins. You gotta wire them up to turn them on. I don't see any of that for that 16-pin chip there. The whole right side looks like it's not even wired up. But I can't tell unless you flip the board over. I can see all the pins. But it looks like the chip is on the far edge. You never put chips on the far edge of a printed board, because how do you wire up? It's on the edge. Usually you put them in the middle and you wire the components everywhere around it. It doesn't make sense to me.
Yeah. You know, like he set up with more questions or more confused. So that's why for me I was saying, man, we need to see this on a live. It will be better to ask the right questions. But let's wait to see the video maybe you make and see what it will be able to explain.
Yeah, he's
Nesta,
not coming back, bro.
yeah, you say that guy. I think he will because he seems to be more determined. If it was me, Nesta is here by the you Nesta today you're here. Nesta, are you at work again?
Hello, can you hear me?
Yeah, turn
Yes,
your camera off.
You guys can hear me clearly?
Yeah, yeah. I
yes.
don't know if you want your camera on or not.
Nah, it's all right. I'm not used. I'm really. I'm being honest. I'm kind of antisocial, so I get a little, a little social anxiety sometimes. I'm gonna be honest.
Okay.
I don't be networking or streaming or nothing like that. I'm just one of the guys that be on the sidelines just watching life. But
You said
yeah, man. I like you guys are very interesting. I like the topics. I'm very interested. In what you guys. I'm learning from you guys also, but I'm learning. With my through my how would I say it, my experiences and um building circuits. But yes, yeah, I'm keeping it 100 with you guys. I actually did it. I actually was able to harness energy. I built this device, this technology. It's not too many components. You just got to be able to place the components in the right position. That's it. You place in the right position, you could create, make the cause the antenna to be modality agnostic, very, very sensitive, pick up even microscopic vibrations. So my system can pick up the the smallest noise. It's so sensitive. It's basically a electromagnetic field telescope, but for antenna.
and you said you're able to get out for 40,000 watts or 40
Yeah,
kilowatts.
40,000 watts. I get about, I would say, because I'm getting more current in, because there's voltage and current. You got to understand.
Mm,
Voltage, I mean, because I know I'm preaching to the choir, because I know you guys pretty much know this, but electric fields, you gotta understand voltage is ions, right? So basically, like, let's just say like this, right? On the positive terminal of a battery, you got the ions and you got the negative pressure on the negative side, right? So you got more electrons on the negative side, right? So the oxidization. So thing is, the ions, let's just call the ions home. The ions is the atom, right? The ions has less electrons. So
yeah.
basically, yes. So basically, between 2 points, the buildup of ions create voltage. So you have to be able to, how I say, trap the electrons. You could trap them. You could have them flow through a circuit if you complete the circuit right. Constantly running. So you trick them into just flowing forever. So you got to create basically a quantum field. Quantum flux where the electrons itself, it's just like outer space. Because if you look, I don't want to go off subject, but if you look at actually outer space, the darkness is just blue. You know what I mean? It's dark purple to blue. You know what I'm saying? So the ions, the electrons is neutralized. That's why you see the darkness in space. It's just full of electrons. You know what I'm saying?
Mm.
So so basically, yeah. So my system is modality agnostic. It can sense the slightest basically it could sense the noise. It could sense the noise, but it detects the noise. A lot of system can't do that. My system can detect noise, actually detect noise, and it could detect the shape of the noise. It could
Mm.
detect, what I'm saying, where the noise is coming from. It would tap into that resonance. It would create a flux pathway. So we don't need satellites. So my system is fully independent of satellites. It creates the flux pathway by accessing objects, because every object on the planet Earth, even our bodies, is a medium. So my system can tap into each medium, and the thing is, it's trying to focus on the highest potential, which is the gamma, which is the highest, the ether. We call it the ether. So my system would access different components to access the ether. It would basically use different objects as a straw
And you say
or a magnetic lens to
You're saying
access current.
ether up in the sky? Is that what we're talking about?
you say
The
that
ether, the ether is all around us. There's energy all around us. You understand me? But the thing is, with the voltage, you got to understand the high pressures is because of the radiation of the sun, and anything that's closer to the sun, to the earth, is high radiation, right? It's negative pressure during the day cycle. Is negative pressure is no negative pressure on the night cycle. So during the day cycle, you got negative pressure because of the rays, the photons from the sun.
Why
You know
why
what
do
I'm
you
saying?
call it negative pressure?
Why do I call it negative pressure? Because
Yeah.
negative pressure, if you take negative pressure minus high voltage, you get current.
I have no idea what that means.
High voltage, there's positive voltage. There's positive and negative, right?
Uh-huh.
So negative pressure, if you minus negative pressure, high negative pressure, if my system creates high negative pressure. If there's high negative pressure, you minus is high negative pressure from high voltage, you get current. So for example, the sun has high voltage. The earth also has high voltage from the core of the earth. The earth is a big capacitor. So if you have two voltage sources, right? Voltage from the earth, right? Come from the core, and in the sun, you have two negative pressures create high voltage. Two negative,
I
like
thought
we
the
talk,
earth was ground.
huh?
I thought the earth was ground.
The earth, yeah, I mean the earth is ground, but you got to understand is the material density because the earth has material density, different materials cause different currents and different electric fields, magnetic fields, and all that stuff. But the earth itself has certain materials, right? It has copper. All materials come from the earth. Copper, silver, all that stuff. But it has a the material density has a part to play in it. You know what I'm saying? So the earth and the sun, you gotta. I mean, my opinion. My opinion. I tell people all the time, like the earth and the 9 planets is why the sun is still even have energy because they all work synchronized together. The earth and the sun
And
is
Nesta,
synchronized.
you're saying that you've been this like you've begun using it yet, or you haven't deployed it
Yeah,
yet?
yeah, yeah. I mean, I built one already. Me and my turn, like at the end of the day, with my interest, because I built this thing and it's worked. So I already got an attorney, and I've been at an attorney, but I've been working on this thing since last year, 2025. So I got like 3 patents in this thing, and I already got accepted into a university. Like that's how you know real. That's how real this shit is. You know what I
Can
mean?
I? You've got a patent on it already. Can I be able to search it? Or I think it's
No,
patent.
not yet. No, no, it's still patent. It's patent pending. You know what I mean? I got 2 patents. I got uh, non-provisional. I got CIP, and then I got a provisional right now.
Uh, I think
And
just
So
what
the
to
provisional
specifically
gives me
is it?
1 year to work on this shit.
Is it energy conservation? Like what is it like?
Yeah, it's
What is
energy.
it about?
It's energy conservation. It just transfers the energy. But the thing is, my circuit I create the lowest potential point relative to the universe because like I said, the high pressure is voltage. Anyways, it's voltage all around us. Radiation is voltage. You just got to be able to be able to tap into that voltage by creating a circuit that's relative to the universe itself, right? But it is a lower potential because there's nothing that's greater than the potential of the sun. You know, you could only create you could create something that replicates that, but it's no voltage that be higher than the sun. So that's a high voltage potential point already. You know what I'm saying? So my system just creates a pressure difference that's allow the antenna to be sensitive and allow current to flow. The current flows from the environment. It just flows into the antenna. Like I get like 100 amps flowing into the antenna itself.
That's a
I think
lot of amps.
Yeah, I get like 100 amps and above, more than 100, like up to 300 amps sometimes. But it all depends, It depends on the capacitance. You know, what I mean, you create. If you put bigger, like apply bigger capacitors to my system, it is more. It stores more current. You know, what I mean, and more energy watts. So it could actually get more than 40,000. It's just I limit it to 40,000 for now.
like you could in future you could go beyond that 40,000.
Huh?
You think that in future you could be able to go beyond the 40,000 watts? You can find a way to go beyond 40,000 watts that you're getting right
Yeah,
now.
yeah, yeah. No, no, it's already. It can go beyond 40,000 watts. You just gotta, build the wire wider. You gotta have bigger wires, and stuff like that to hold more current. You know what I mean? Because
So we're
copper.
talking about a physical electrical path.
Yes, it's physical. It's physical circuits. You just gotta you figure out. You just once you place everything in the correct position, that's it. And that's what I
Mu-
was able to do. I placed everything, all the components in the correct position, and it took me a while, but I was able to get it done, and I got it done, and I was able to get high current. And not only that, the system itself is, like I said, it's basically bridge the gap between real world physical. It's like Tron. You ever see the movie Tron?
Yeah.
Mm-hmm.
Yes, it's like that, something like that. You physically bridge the gap between the real reality. So that's why my system, you can literally tap into frequencies, into the noise. Like I said, noise is every object, even the human, our bodies. So my system can literally, it knows, it could know exactly who you are by just your frequency signature.
Mumuka,
So
Mumuka is asking like, first of all, he's saying that what you're talking about is the magnetic connection between the sun and the planets. I get that, and he's asking if you can be able to share the provisional patterns.
no, right now
No,
I can't. I'm being honest, like I said, because your interest. But the thing is, like I said, my system is in the labs. I mean, it's taking time. That's why I can't really show nothing. I mean, I'm doing everything, trying to do things the correct way. I mean, professional way. But
okay.
um, yeah. It's big because this system itself, like I said, you could alter the property of materials. So far, all I know is that, like I said, glass and plastic, it alters that. Once it taps into the resonance of glass and plastic, it taps, literally. I mean, I shouldn't be saying this because, yes, it alters glass and plastic to make it literally invisible. So we don't know what other materials it could affect. Maybe rocks different, water it affects different. But yeah, it's like it taps. It's deep, man. It's really deep. It might sound crazy to y'all, but yeah, it's more than just that because it's deep. It's deep. I don't want to say too much, but yeah, this is some powerful shit, man.
Yeah. I think Mumuka understands the thing that he was asking. Mumuka was asking, how do you create that lower potential point? I don't know if you understand that question.
How do I create the potential points?
The lower potential point. The questions are on the screen. If you look on the screen, I think you can see them.
Oh, hold on.
You see them?
The system, you said, yes, a higher negative energy will create the difference between voltage. Voltage is the environment. You have placed all components in the correct position. Anything that's close to the earth. Oh, that's me. To create
Have
an
you,
energy sinkhole is what it sounds like. Yeah. Basically, it's a black hole. It's like a black hole. I created like a black hole vortex within my system, the circuitry itself. So basically, the circuit itself is just like outer space. That's why I'm making me think like, are we traveling to some type of material itself, the whole universe, because it's like the unit, like the circuitry and the density of the materials itself is like a little mini universe, man, within the circuit itself. And the circuits, they work the same way, with the same laws of thermodynamics in the universe, the universe works, but it's just on a smaller scale. That's why, me personally, I don't think that voltage never goes to zero. It goes to zero point 0.1. It's always some type of vibration. Voltage never goes to zero, and my system proves that. So my system it could tap into zero point 0.1 picovolts to over 1,000 picovolts signals. So that basically, with my system itself, you could basically transfer messages below the noise threshold, and only my system. Let's say you have a network of my systems all over the world. It could
so
basically, I could send messages below the noise threshold, and only my system can detect it. Not even, you know.
so so needs like your system can generate like this a lot huge amount of energy or power, and also it can be able to like send messages. Like it can do way more stuff.
Yes, I could do. Yeah, I could do way more stuff. Like I said, man, with this system, it's a whole new level, man. It's a whole new level of technology because it's like Basically, if I like, let's say if you take my system, right, and you put it into a robot, the robot becomes 10 times powerful, meaning that the robot, the human eye only renders at 60 hertz per second. But because my system moves at the speed of electricity at a feedback loop, it basically it's like a how would I say it? It's like an organism, a electrical organism. But the thing is, it needs AI to as the parent to govern it, because if it don't govern it, then it would try to tap into every frequency, meaning that literally it would tap into our bodies, everything around in surrounding space within miles and miles of range, and it could, like I said, it could use your body as a conductor to tap into the realm, the environment, or the ethereal, the ether. You know what I mean? So that's why
The,
I'm using AI and neural networks in order to able to regulate this. It's like a baby. A baby want to put everything in its mouth.
I think that's why Jeffrey is saying that you should be careful because you might create a portal.
I buy what?
You might create a portal, like a
I
portal. I
re-
think it means if
that's
you,
what I'm saying. That's what I'm saying. That's why I don't want to say too much. That's why exactly what happened. That's exactly what happened, man. That's why yeah, this shit is deep, man. It's
but,
yeah, yeah.
but
That's
when are you going to begin using it, like personally at your home?
well, it's different variants. I got different variants. I got
Mm.
five different variants of the system. I got a higher variants, which you already know that's the government. But the
Like
system,
you,
I got variants that actually could charge just for people, just to charge, your house,
mm.
your car and
So,
everything,
so,
and
so, just
smaller
so I
applications.
understand, your system specifically just takes radio waves and creates energy.
Yeah, it creates it does. I'm just taking the potential points. I'm taking the radio. I'm not actually understood the transient. The transient, you can stack the transient, but the transients ain't doing much. That's what mankind been trying to do for the longest. That's what you're doing. You're trying to stack transients. You're not going to get any much current like that. That's not the way you do it. Transients is just noise, radiation. But you could use transients to control. If you could tap into transients, you could literally like manipulate the transients too. So you could create your own noise, and that's what my system does. It creates its own transients, and if you control the transients, you could control the higher voltage inputs by just controlling transients.
Moonka is saying that he wants to see your system so badly, yeah?
Come again?
That he wants to see your system.
Soon, soon, soon. That's what I say. That's why you guys gotta just be patient, man. Like I said,
I think
just give it.
you,
Like I said, it's in the lab. I can't really do much.
Nesta, you've been telling me so since last year. Like I think
I
since
know,
last.
but like I said, I've been working on this thing, but I'm making it. I've been, I had figured it out last year, but it
Okay.
wasn't as efficient as now. Now I've been working on it for about a year, and almost a year now, and like I said, it's way more advanced than now. When I first started. You know what I'm saying?
Why would you care about efficiency? If it works, it works. Efficiency you can work on later.
Yeah,
Like if it works, it works.
yeah, it works. Yeah, it works, but right now I'm just trying to is more more heat dissipation. I'm trying to create because the system like right now. Okay, for example, you're trying to build voltage, right? I already did that. I got high voltage already. I'm getting high voltage and current. Now I'm trying to. The system is creating such high voltage, and I'm trying to go backwards now. I'm trying to go down. Negative. You feel me? I'm trying to dissipate some of the heat because it's so much heat that what I mean. I'm trying to dissipate. I gotta work on a heat sink and material. Because it's different materials, but I'm trying to put different materials together to create a heat dissipation system that quickly dissipates the heat. Although my system can zero out the heat, but because heat is radiation, so it's noise. But it can, but I'm just trying to make it as efficient as possible right now.
Yeah,
I like candy.
what is inefficient? How, like, what do you, put some numbers to it. What is inefficient?
I would say I'm about my system is about 90% efficient.
Wait, if it's
It's like
90% efficient, why are you still working on efficiency? That's pretty high.
uh safety. You still we still try to figure out the system because safety. It's all about safety because like I said we still it's still new. How we say it? What's the word? It's new places that we get into. We trying to we discover, and so it's like yeah, so that's why it's like it's about safety right now. We're just trying to make sure that this thing is doesn't tap into anybody's resonance, man. And mistakenly tap into your resonance. So it's like, it's a lot of coding behind it. It's right now we just writing codes for the system because it runs off neural networks. So we have to write codes to make sure certain instructions and statements. What I mean, to make sure it don't ever have to tap into anybody's resonance.
Not to dox yourself, but what kind of background are we talking?
Background? What do you mean? What do you mean?
Like for you, like what kind of background? Like, are you more dominant in? You don't have to be too specific. I'm just curious. Like, what
Well,
is your field of study?
my field of study was before I kind of was into like coded programming, gaming and stuff like that. But unfortunately, I lost my laptop. I lost all my work. So it's like, what I mean, from what I heard about Maxwell Chikubusu last year, it sparked my interest. And you guys, talking to you guys, it really sparked my interest. So I got into electrical engineering and I studied for a whole year, man, every single day for 24 hours. It kind of sounds crazy. It might sound crazy, but I like studied this thing and research online and research and read, for a year straight, nonstop, every single day, thinking about this thing. Eat, sleeping, thinking about this thing, dreaming about this thing. That's how I was able to get it done.
Like you started building it last year, or it was way
You
back.
break it up, you break it up. I can't hear you.
I'm breaking up.
Yeah, I can't see you, Chris. I can hear you, Chris, but I can't see you.
My camera went off, but I think you can hear me. It's saying that I'm breaking up, but I think you can hear me. Nesta.
I think Nestor's breaking up now.
Yeah, I don't know. Man. It could be.
Yeah, there's some.
I mean, it could be the government. Who knows?
I think he's moving around.
Yeah, where you moving to? It seems like connectivity is not as good like where you are. Or you're going in. Oh, I think it's going back to his job. Last time you were at work, we could not be able to hear you though. Nesta,
Yeah, can you hear me? No, it's bad.
it's breaking up. Yeah.
It's breaking up.
There's a place.
Yeah, the government, I'll tell you that much. Hello?
Yeah, you're breaking up.
Yeah, we're gonna have to sign back in again. Yeah, you
Okay.
guys gonna have to go live again.
Oh, I hope you
What
get.
the heck was that?
Oh, Nesta is breaking up a lot. I don't know what. Mumkau seems to get what Nesta is explaining. It seems that it's getting energy from ether. Someone said ether.
Yeah, there were. I don't know. It's just I hear a lot of words, and a lot of words are just not making sense. I mean, using words like pressure voltage. Like, wait, are we talking pressure or are we talking voltage? I know people try to describe voltage as a pressure, but voltage itself is it's a potential difference. So I know that the description of voltage that people use, but when he said he's converting pressure to voltage, that confused me because I don't know what is pressure in electricity. Is that still voltage?
Yeah, pressure. I think he meant voltage and he said pressure. Because Usually when they say negative energy, there's a word that I hear a lot, negative energy or negative energy. Then they'll say negative voltage, I think, and now it comes to pressure, negative pressure. But I think it refers to voltage. I was trying to Google about it, like what someone means by what is negative pressure in energy and voltage, but I said negative pressure in electricity is not a physical suction like a vacuum, but relative measurement, meaning a voltage lower than your chosen reference point. But now for them, they'll explain it
That's
that in,
just a negative bias then.
yeah, that's what it said.
What? Yeah, it didn't make sense. I was trying to keep up. I just he was losing me a lot with like some of the numbers and 40,000 watts.
But
That's
yeah,
an even bigger claim, and that's a lot of energy. How do you? I would have to see it. That's something I cannot
how
just
we,
take face value.
yeah, how we come to shade. Maybe once he gets the patent, like he's saying. But he had said that he had patent that stuff. Usually, if there's a patent, you can Google it and see it. But then he said that it was still provisional. But if you're getting out 40, like that 40,000 watts, which is 40 kilowatts, that's a lot of energy. I think the government will want you to, they will want you to do what to improve on that, and you can be able to supply, like, I don't know, is he back or what? I think he's back. Like, you can be able to supply data centers, because data centers as of now, they need a lot of electricity. He has dropped again. So maybe I wanted to ask him, like, what does he plan to do with all this energy that he's getting, all this power? Like, does he just want to power his home, or maybe sell it to the government, or is he just using it for fun?
Yeah, that's what I was trying to ask. Like, what is it to do? Like, are you converting RF energy to power? Is that all we're talking about?
Yeah, I hope he comes back. I don't know. Although usually its connectivity has a lot of issues. But when he's somewhere that he works. Jeffrey saying that low and higher ether pressure, such as descent of the toroidal coil, is a low ether pressure. So I think it's trying to explain the negative pressure and stuff like that.
I've never heard the word ether used to describe like pressure in a toroidal. So that's a new one on me.
Jeffrey, how are you doing, man? You want to explain more? But Jeffrey has been around for a while today. I don't know him though. I think this is the first time that he has come to watch what you're doing. Momuka is saying that they will also get into your head. You want to be able to sleep at that point. You have to step away. Or is Momuka is telling Momuka Plus is telling Nesta to step away from using, I think, AI. So he's saying that Nesta, if you're working with an AI to help you build this thing, be extremely careful. They will lie to you with a smile on their face, and you get so far down the path, you won't even see it. I think that's what is happening to Lloyd now. But for Nesta, he said that he has built it. So if he has, maybe it's a different story. But I think what Momuka is saying is like what Lloyd is doing. I think Lloyd now is so deep into AI that if you ask him anything, like, he cannot answer you like from just his opinion or from what he knows. He has to ask AI before he can answer.
Yeah, he's stuck. I
Next
thought
is
it was interesting that he He actually opened up a charge controller just to prove himself right. That was weird.
Oh, him. But yeah, him. I think. I think he has. I think maybe if you've been doing something for so long, and someone comes and shows something different, I think it feels like maybe they're letting you down or they're putting you down or something, and you try so much or you try to use anything to like to make them feel like they are false, like the other party is false. Because I even saw this, I think I haven't said that well because I was trying to reply Nesta, but Nesta, it was on your side that we began hearing those static stuff. But let me get this comment here. I want to show you. There's a comment that I saw of one of Lloyd's past guys going to comment on. There's a video that I'd cropped about Alan. I'd clipped it from the live stream we had last time. It was just about Maxwell and some other stuff. Then I saw a comment from one of Lloyd's like general. He was asking this. Let me see if I can share that one on the screen.
Mm-hmm.
He was asking like, I feel like they're trying so much to, in a way, disapprove what Alan did. But Alan was very good, and I wish they could be that way as well.
Yeah, I like Alan's approach because he's not fearful of sharing the results. Like it's whatever the results are the results. But I think the most of those other guys, they're hiding it. They don't want to tell you that there's no current. They refuse to show it.
Yeah, for them they refuse to show the current. I don't know if you see these comments. It's from
that guy Andrew. That guy's a nutcase.
Go
ahead. I'm sorry.
You say that he used to be in the US by the I think, but he's from my country though. And he was saying that I'm putting a brother down. I mean, he was saying, what did he say to me? There's a comment he said to me that I'm putting a brother down. In a way, because I'm African and Lloyd is also African American. So
you're siding with an American?
Not really. Like I'm siding
or attacking
with Alan. I think when I was trying to share this link.
Oh, okay.
Yeah. Even Lloyd himself also said such a thing, that I'm siding with Alan. But I was just asking him, like, you see how Alan has explained, he's showing the power voltage in, current in, then he shows very correctly like what you're getting, voltage out, current out. That way you can be able to now compute power in, power out. But now the conversation in a certain way turns to like I'm supporting this other person and I'm putting a brother down. I don't know, stuff like that. But you see these comments, this was a different video about does big oil suppress. This was I clipped this from the live stream we did with Alan last time. You were on it also. I think even in this video you come in at about minute 5 or so. Then for him, he did not even watch this video. He just came to comment that did you open the MPPT to make sure it is an MPPT. Secondly, you didn't do as you had explained. You need 2 PWMs and 2 batteries and a boost converter. Otherwise, you're not doing the same experiments. So he sort of like came to attack, I think, Alan on the experiments that he did. I don't think that even Alan himself has seen this video because I don't think that he even knows that I posted that clip. Because I think for Alan, he follows a lot my live streams. is not really into like the short videos that I put up. So he came and attacked him on this one. Like, so it means like if you're going to buy an MPPT charge controller, you have to make sure you open it inside, you confirm it is like what they are using in the experiment. I don't know. That just sounds odd. Like it sounds like someone who doesn't want to accept some certain type of results.
It is 100% because they don't want to accept the results. A PWM and an MPPT controller, the main difference is the smart level. Like it knows how to detect to find optimized power, right? When you're charging specifically, whether from a solar panel through a charge controller to the battery, you can optimize the power point, meaning there's a maximum power level where the efficiency is as high as it can get to recharge the battery. It's not one number, it's not one level. It moves depending on this how much energy is coming in the solar panel. It depends on how much the battery's been charged. Those things fluctuate, right? Sun goes up, sun comes down. That means the energy from the panels go up and then they eventually start going down. The battery itself, if it's fully charged versus 50% charge, that can be up or down. So when you're putting power from solar to electrical to the battery, the maximum power point, the efficiency specifically, the efficiency can be maximized. The MPPT controller does that. It maximizes that. It optimizes. That's a better word. It optimizes the charging. Now, a PWM, it'll just charge. It may not be as smart as an MPPT controller, but it still does the job of charging the battery. So just to say it doesn't have a coil in it, then all of this doesn't mean anything. No, it's still valid. I'm just looking for current. Where's the current? Whether you have a PWM or an MPPT, where's the current? That's all. So that's BS. Opening up a charge controller to prove your point. That's weird. Just say that there is no current. We're done.
Yeah, yeah. I'll just show it. I think, but Alan said that he has gotten exactly the same now PMW, a PWM, and I think he's gonna use it now to do the next test. But I know the thing that they'll say next will be the solar cells that he's using.
Did you see the comment I left on Alan's channel?
Yeah, I did.
The breakdown of the math. Like that's what I've been trying to figure out. Like if I can get the proper numbers, I can do the numbers right there and just put it in the chat. Fortunately, Alan just gave me exactly what I needed, and I was able to give him feedback for his second video. Hey, by the way, the reason why that 5 volts dropped down to 3 volts is because you're not giving the the LEDs enough power to run properly. Crank up the current allowed on that power supply, and you give each panel 5 volts 1 amp. That's why his design went up to 5 volts 6 amps, because he's using 6 panels. He's using 6 set of LEDs. That's why that makes sense now. Now he's getting 5 volts at 6 amps. Each amp goes to one of the LED strips. So that made sense. But it was only possible because he showed the proper numbers. So once he did that, then I redid the numbers on the second video. If you go in the comment section on the second video, I redid the calculations to show it's still only 2% efficient. This is really garbage. If this is an energy harvesting system, you're dumping 98% of the energy that you're putting in. That is a waste.
Yeah, I remember the second video it got out. It was 4.6. It was 4.6.
It still came out to. If you go to a second video now, you can see. Maybe I did the numbers wrong. Maybe we can calculate them properly here. But if you go to a second video, I did the exact same breakdown, just with the updated numbers.
Yeah, it got out. The current was 4.6 milliamps, if I'm not wrong. The first one was 1.0.
Yeah. So I did the exact same math. I hate that. I did the exact same math, but just with updated numbers from his setup. Now that he has proper power going to his to his LEDs. So right there, that's that second one.
Yeah, it was
4.6 milliamps. It comes out to 0.426 watts. Your system is now 1.4% efficient. So it's 0.426 divided by 30.9. 30.9 watts. That's how much he's getting from the power supply. 4.98 volts at 6.2 amps. That's what he's providing the LEDs. So that's how much power he's putting in. And what he's getting out is 0.426 watts. So he's dumping 98.6% of his energy. That's a lot. That's literally dumping all of it.
Yeah.
So right there, he's showing his 5 volts, 6 amps. And he's getting 92 volts, but only, what was it, 4.6?
Yeah, 4.6.
4.6 milliamps. When you do the numbers, it's only half a watt. But he put 30 in. That's a waste. Now it might be better if the battery's not charged. If the battery's actually wanting energy to come to be recharged, that'll change some things, but I don't expect it to go up to 80%, 90% efficiency. It's not going to get that. I mean, at best, if I had to guess, I would probably say 10% at the best. 10% efficient, maybe. I mean, that's really pushing it, but right now he's sitting at like close to 2%. That's really low.
Yeah, I remember the last time during the last stream we had, when I did ask AI, it said you'll be lucky to get 100 milliamps, which is that is like 0.01. Is it 0.1?
0.1.
0.1, yeah. To say that you'll be lucky to get such amperage if you did those were, he said that he was gonna do 390 something. I think 394 solar cubes. He was gonna start
You broke down pretty well on that video of when he was claiming to get those solar panels at 2.7 volts or something, where he was claiming the number, but the number was based on direct sunlight. I thought that was a really good catch. And he didn't want to accept that when you were saying, like, those numbers you're talking about are from full sunlight. You're not giving it full sunlight, so you're not going to get that number from those solar panels.
Your problem is the Lloyd doesn't accept now. He said, no, why am I getting different results from my side? Why am I?
What did he say about this live? Why didn't he come up for this one with Alan?
This one, he said that Alan is using the wrong solar cells. Then,
but you proved that he made a statement.
Yeah. So I did ask him. Like, you told me that you can be able to use any solar panel. This was early last year when we had just known each other. And he said no, I never said so. I told him that you did. He said no. So I told him I'm sure I have proof. So I went and looked for that clip and found it. I think it was like 2 hours late. It is we did a long interview with him, about 2 hours. Then I got that section and shared it with him. It was towards the end. Then he listened to it and he said that that's not what it means. He said that my English is somehow failing me. Like I'm not understanding what he said in that.
Wow.
I think he will make a video maybe to explain also. Then later on he went on to say to me, I don't know, AI videos, AI answers, and the videos he the videos that on his videos he usually don't use any type of any type of solar cell. He prefers specific ones. But I was like, I know this, like I already know this, and I've seen your
Right.
video. You use specific ones, but just a year ago you told me that any can work. Now all I was asking, like, for just a simple like a simple thing, or like you can just admit that maybe last year when we talked, maybe I did not hear you well, or maybe I was in the heat of the moment and I said any, but I did not mean any solar cell can work. But now when you say that you never said so, and I show you the proof you said so, and now you come to say that my English is failing me, or I did not understand you, like it shows you and someone who can't really accept something that you said, like you will refuse to accept the truth or stuff like that. Then I don't know, I said what I'm not teachable or something like that. And he said that if I can't accept that, then he will not come on the show. So just said it's okay.
Yeah, he's definitely going to cut you off now because you're seeing him for what he really is. I've seen him. I've heard him say something like similar to, with voltage is useless without current. I've
Yeah,
heard
yeah.
him say that.
So in that interview, he said so as well. He said so. I have this interview. I'm glad I saved it. It was from a year ago, actually. I'm glad I found it, because what he was saying in this interview is different from what he's doing right now. I'll say so.
Yes.
Back then it
Now he's
was more
saying
about
you don't need current.
yeah. And back then he said there's any machine in order for any machine to work, you need this and this. But right now, I see Trovman is sharing Trovman is sharing the 0.79 amperes badge or milliamps. But even that one, I still brought it up to him. I told him, like, he said that he can't be my teacher because I refuse to accept like things that we were like taught at school. So I told him that I'm also like, I also did engineering stuff and all that. So he told me that I don't want to be taught by him because of these things that I was taught at school, and if I remain so, I won't be teachable. And I said, like, but my teacher, I would prefer a teacher who, if he makes a mistake and misreads something like 0.79 amperes or 79 milliamps, like he will
Yeah.
be able to accept when he knows, like, you made a mistake. Like someone will accept that, hey, maybe I misread this one, or I did not see it properly. Like, it's just simple to accept when you make a mistake. But now this is someone who never accepts anything. Like, he will go on to make a video to defend himself. I don't know why he does ask AI those
Yeah,
questions.
he's stuck in the AI loop.
Yeah, but he said, I think I've gotten that part. Truman, I thought you have already had dinner. Truman said it good to add dinner or something.
Yeah,
Yes.
Okay, so why would his be any different? He amplified that, which is voltage, electricity, voltage from the air and the earth. Each antenna he built would have done that automatically. So he doesn't need to transmit anything. It stole his patents, used his patents, and made the first broadcast. I don't care is with any applications. If you got voltage times current, which means amps, you can run anything you want. Far as this electrical, when we talk about electrical motors and stuff like that.
You see, that's what he
So
said. He said any application, you current and voltage. When you multiply current and voltage, which meant power. But right now, you see, it comes to say that when I was asking him a lot about why he was misreading that value, actually he misread it on purpose, because on his video, on this side, is misreading 0.79 amperes as as 79 milliamps. Yeah.
Mm-hmm.
And on what is getting out, it was 0.46, and that one he read as 0.46 amperes. He did not read it as 46 milliamps.
Milliamp. Right.
So it means like it's sort of like just misreading it on purpose so that you can show that power in is less than like power out. Like power out is more than power in, you see.
Yeah,
But
yeah, he definitely has been embarrassed with but it's funny that now you're going to watch all of his followers make all these excuses. Like that's crazy to me. That is crazy. I think he's blatantly wrong, but he won't even say it. Even when you catch him with his own words.
yeah, yeah, for him he'll say I never said so, but when you get it now for him to listen, he then changes
He says your
again.
English is bad.
He says my English is, I don't understand. My English is failing me.
Yes, Travman, he uses a power supply as simulated solar. That is not simulated solar. That's a power supply. That thing's going to put out way more power than your solar panels. Solar panels are what, 20 watts, 40 watts? Them power supplies are like 1,000 watts sometimes. Like those, they're designed to put out high power. So it's not simulating solar. Why don't you just use the solar panel?
It's crazy. It's crazy, but maybe he knows what he's doing and he has time to perfect it. I know
And
the
those
biggest.
solar simulators are actually used to just test to make sure that the thing turns on. It's not made to put it at highest power out. It's not made for that. It already has a threshold voltage that when you hit it with a certain amount of certain amount of power, it'll put out a certain amount of power from the solar panels. That can be measured and saying, okay, it works. You don't have to stress it with high energy to see if it works. That's all it's for. It's not meant to drive it. It's just meant to test it. But he wants to, hey, look, this is how we get. Nah, whatever. Power. Good luck in showing all the stuff that he was saying. But I think you caught him in the loop here. I think you definitely sort of, pretty much put his words in his own mouth. And he can't even defend it because it's a different story now. Remember, he was talking about the voltage and current. Then he stopped saying that and he starts saying just voltage. Then he starts saying, oh, I can get it from the battery. But wait a minute. You've been claiming you've been getting it from MOSFETs this whole time. Why are we not talking about MOSFETs anymore?
Yeah, even in this video, it's more about MOSFETs. I think he talked about transient. It's just that this video is too long. Like,
yeah, he moved it.
Like 2 hours. Yeah, we did an interview long time ago. Back then, he was talking about MOSFETs, transient energy, and the MOSFETs were the one which were creating more current.
I gotta hop off. I gotta do some personal stuff. Thanks for letting me up. I'll keep an eye out for when the next time you go live. I don't think you're gonna see Lamb again, but I'll I'll hang around if he comes up.
I think he will pop up, but I think he's more determined. But it's okay. You go ahead. Let me play this video that was shared by Travman, then I'll go to bed as well. It's like
all right.
Almost.
I'll talk to you later, Chris.
Okay.
See ya.
You Travman, that other video had already played it. The one of the solar simulator had already played it. Maybe this one, my camera somehow went off. I don't know why. Here it's showing that it is on, but the software is not picking it. But the good thing is it picks audio. Yeah, there's a guy who had asked about the robot fightings. I think as there's a whole video of it, the entire event when it happened, and I thought maybe I'd do a video reaction on it, or more like a live stream on the same. I think if tomorrow I'll be okay, I'll do that. But let me play this video. So this video is saying that the guy is powering with an atmospheric electricity How atmospheric electricity works to generate electricity to power things like corona motor, an electrostatic motor. Let me see.
Hi gang! I'd previously demonstrated generating power using atmospheric electricity. A hexacopter was used to lift one end of a wire high up into the air. Meanwhile, the other end of the wire was connected to a corona motor near the ground. Electricity then flowed through the wire and corona motor, making it turn.
So back then,
Flowed through the wire was connected to a corona motor.
Back then, a drone used to be called a hexacopter.
High up into the air. Meanwhile, the other end of the wire was connected to power using atmospheric electricity. A hexacopter was
A drone used to be called a hexacopter back then. Oh, that's why you say it so. You say that you thought it was funny because Lloyd called the bench power supply assimilated solar. Oh yeah, I remember now. In that video that he quoted, yeah, I remember. It was in that video, right, where he quoted 0.79 amps as 79 milliamps. I remember now. He did, by the way, he did. Usually for him, if you go and ask him now this, like you said this, he will say that he never said so. Then if you show him video proof, he says that your English is failing you.
used to lift one end of a wire high up into the air. Meanwhile, the other end of the wire was connected to a corona motor near the ground. Electricity then flowed through the wire and corona motor, making it turn. In this video, I'm going to explain how it works. Much of the following explanation is adapted from Nobel Prize-winning physicist Richard Feynman's lecture on physics, a section called Electricity in the Atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. According to Feynman, this extends upward to 50 kilometers, or 31 miles.
50 kilometers. Let me confirm if we have audio on the video. Do we have audio in this video, or am I just playing a video and there's no audio, man? Trogman, do you have audio on the video? I don't know. It's refusing to show me the. It's refusing to show me the what? I want to confirm if we do have audio or not. I hope we have audio in the video. I know I think we have audio in the video.
Where the air is very conductive. This is the case in fair weather. In stormy weather, like a thunderstorm, things are quite different, and I won't talk about that here. But if this voltage exists between your head and the ground, why don't you get a shock? The reason is that your body is a good enough electrical conductor that standing on the ground, you're basically a part of the ground. The equipotential lines would look like this. There's still effectively 0 volts between the top of your head and ground. Similar effects happen with trees, buildings, and so on. What about the electric current? A downward electrical current exists and consists of positive ions. Molecules are clumps of matter that have a positive charge. These ions are moving slowly toward the ground. The current density from these ions is very small, around 10 microamps or 10 picoamps, crossing each square meter or yard every second. So in any small area, there's not a lot of power. And that's the explanation about atmospheric electricity adapted from Feynman's lectures. To take advantage of this atmospheric electricity, we electrically connect one end of a wire to the ground and lift the other end up into the air. In our case, we got good results at around 120 meters or 390 feet up. At 100 volts per meter or 100 volts per yard, that's 12,000 volts between that height and the ground. But just as with you standing on the ground, the wire is an electrical conductor, and so is also at ground potential. Looking at the equipotential lines around the wire, that voltage of 12,000 volts exists between some distance away from the wire and the wire. You can see that the equipotential lines are closest together at the top of the wire. This means the attraction is strongest there, and electrons make their way upward in the wire. Let's look more closely at the top of the wire. We'd put 6 sharp points using sewing pins at the top of that wire, but for ease of illustration I'll draw just one. Notice that because of the sharp shape at the point, the charges are crowded together at that point. Remember also that there are positively charged ions in the air. An electric field exists between the negative charges on the wire and the positive charges in the air. And we can represent that electric field by drawing lines between pairs of opposite charges. Notice that the electric field lines are closer together near the point, meaning the electric field is stronger there. It's strong enough to remove the negative electrons from the sharp point, where they neutralize positive ions. But due to the voltage, there are fresh positive ions moving downward and fresh negative charges coming up from the wire. We now have electricity flowing through the wire. The electric current in that electricity is very weak though. We didn't measure it, but from my experience with electrostatics, I estimated in the low microamps, or more likely even lower. That's not enough to turn an electromagnetic motor, one like you use in everyday life, but it is enough to turn an electrostatic motor, like this corona motor. The corona motor consists of a plastic cylinder surrounded by sharp-edged metal blades. Every second one of those blades is connected to the wire going up into the sky. That means that when the wire starts conducting, those blades are now at whatever voltage the top of the wire is up in the sky, though opposite in polarity, positive. That's why you get a shock when you touch one of those wires. Negative charge is then pulled from the plastic cylinder through a gap between the edge of the blade and the cylinder. That leaves the cylinder with the same charge, and since like charges repel, a repulsion occurs that rotates the cylinder. The next blade is connected to earth ground and becomes negatively charged, and since opposite charges attract, it attracts the charged area of the cylinder. It then neutralizes that charged area by taking electrons from the ground. And that's how atmospheric electricity can power an electrostatic motor like a corona motor. Well, thanks for watching. See my it attracts.
It's not really like you're getting a lot of electricity from it again. Jeffrey is still around. It's not like you're getting a lot from it, yeah? As I said, it's a relationship system going on, high and low ether pressure, high and low atmospheric pressure. So it's only maybe that guy, Lam, who did figure it out how he can be able to do it. I hope I get his video. If I get his video, I'll share it and then we can talk more about it on a live. But from the way he said that because we're going to the weekend, maybe until Monday is when we'll be able to shoot it. I think when the day comes and he has shot it, he has the video, it will be interesting to see what he has and also discuss about the same. I hope he's gonna share something that is more informative. Like Adebayo said, to give him time to go and do his thing. For me, I wished that we could have been able to like show it on a live. It could have been much better because now you can ask some questions. But whatever the situation, because again, you've seen like Nesta doesn't want to share. More people usually doesn't want to share. So given that we've gotten someone who say that they can be able to film, I think it is interesting. So let's wait to see what we will be able to see when it does. And Jeffrey, Danny 8616, thanks a lot for being around, man. See Travman, Travman, thanks a lot for being around. And others, even producer I think is already gone. Usually comes around for a minute and goes. But I've seen there's been a lot of people been around from like the start. Even Mumkau today, it's right. Usually Mumkau comes around for a few seconds and it goes away. But today Mumkau was like here from the start and he was interested, especially in what Nesta was trying to say. I know Nesta was going deep into what he's doing and it is interesting. I hope maybe one day he'll be more willing to share more so that others as well can learn from what he's doing and maybe question if is it possible or if maybe he's just playing with us. Sometimes these things are people can just play with your mind, but some people also have some truth in what they're saying. And it becomes very difficult to tell between the two, especially when you ask someone to share and they are not willing to do so, or when they're just sharing half, like not really the full stuff. so you're not really able to learn from it. But thanks a lot for everyone who was around, and let me go to bed. It's like 2 a.m. so let me go to bed and see you next time. Tomorrow I wanted to do the other live stream, but it depends if I'll be free. I think I'll do the one for robots fighting, like a reaction or so. In case you want to join in, feel free to come on. I'll schedule it a little bit earlier. But in the meantime, man, have a great day on your side, or a great night on your side, if it is a good night. And see you next time. Tararara. If I had music, I could have played like Matt Armstrong's music, but I don't have.